Right. So I think in the paucity of time, we will start. Good morning, Chennai. Can we be a little louder? Good morning, Chennai. So, welcome to this 122nd edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here. This is the second one in Chennai we are doing. The last one was in 2013, 10 years ago. A lot has changed from then to now. I'll give you a quick story of what's happened from then until now. So we've been organizing these events all around the globe. We finished around 121 editions in 36 countries as of now. We will soon be touching 42 countries by end of this year. So if you see, we are spread out all across the globe. It's something which we are very proud of. Everything is executed here from India, from our offices in Chennai, Mumbai and Delhi. So it's something which we are extremely proud of. Like how we are organizing this event today, we organize the same way in other countries also. This is a one-day event where we have presentations from facade consultants, architects, leading material manufacturers, and then have a couple of panel discussions. So it's been a very interesting journey for us. We've had great response all across the globe. Every country is different. Certain countries have different challenges from others. So for us, it's been a learning curve, and we've been able to bring a couple of new technologies, a couple of new ideas which we've been organizing in other countries here to India. So I hope you enjoy today's event. But I'd like to start off with thanking our event partners, without whom this event wouldn't have been possible. Starting off with Schuko. So Schuko is our presenting partner. They are a German company into aluminum door, window, curtain wall systems, a very popular brand globally, and now been in India from the last 14-15 years, and also picking up over here. They are our presenting partners of this event and almost partner with us in 30-35 countries around the globe. Our premier partner, Alstom. Alstom has non-combustible composite panels. Then our associate partners, Blick System, it's a Polish company. They have innovative systems for rain screen cladding, podium glazing, and other fixing solutions. They are along with their Indian representative and distributor, Diamond Engineering Corporation. Coil is a Belgian manufacturer. They have some very unique anodizing techniques. Anodizing is now coming back into fashion. This is not the normal anodizing which we do. This is some high-end stuff which is possible. So they are also with their partners, Diamond Engineering. Danpan is an Israeli company. They have polycarbonate sheets which can be used for roof and cladding. Again, a very interesting new material for the Indian market, where you can use light as a good architectural element. Dow needs no introduction. So this is the mother company of formerly what was known as Dow Corning. They have rebranded as Dow now. It's their sealant product is called Dowsil, one of the leaders in structural glazing solutions. Euromax is aluminum coil coating company from Belgium. They are also represented here with their local partner, Diamond Engineering Corporation. Fundamax, again, a very popular product here in India, high pressure laminate for external grade high pressure laminates for cladding. Austrian company, been a long supporter of this event since the inception. Kinlong, Chinese hardware company into a lot of fittings, accessories, tools. Kurare is the mother company of the laminated glass interlayers, Throsifol and Sentry Glass. So you would have heard of Sentry Glass in a lot of specifications, SGP. So this is the mother company, Kurare. Ozone, Indian manufacturer of hardware solutions for glass and curtain wall. AC Controls is a British manufacturer. So they have window automation solutions for smoke control and natural ventilation. Serge Ferrari is a French group. They have fabrics which can be used on for facades. So obviously fabrics are used for tensile architectures for roofs popularly, but now you can use them on facades. You'll be hearing from them later today. Siderise is a British manufacturer of cavity barriers. Cavity barriers are used for curtain wall fire protection. They are distributed by their local partners, Olac. Terraco is from the UAE. They have a very interesting product which is EIFS. You would have heard of it. External insulated facade solutions. So that's again another interesting material for facades. Viva is an Indian manufacturer of non-combustible aluminum composite panels and metal panels. And then, of course, this whole conference was based on what we have been doing for the glass industry, for the doors, windows, fenestration industry with our exhibition. Our next show in India is on the 23rd to 26th of November 2023 in Mumbai. So this is the basis of which we started these conferences. And then as soon as we finish Chennai, we have one in Cairo on Tuesday, followed by Milan on Thursday. Then we've got a couple of weeks break. We go back to the US with Washington, D.C. We've got Hyderabad on the 7th of July. We've got Hong Kong. We've got Shanghai. We've got Mumbai. Of course, we've got a lot of other events in between. And the next one, and the last one for India for this year, will be in Mumbai on the 5th of October. The other thing which we have done is we have collaborated with the Society of Façade Engineering. The Society of Façade Engineering is a global association for architects, for facade engineers who are interested in the field of facade designing, engineering, consulting. So they have these awards which are called the Facade Design and Engineering Awards, which they do in London in a very stylish way. It's a black tie event in central London. So we've partnered with them since last year. We've been doing this event since last year with them. So we have, they have now opened this up. It was earlier only a UK-centric award event, but after partnering with us, we've taken this global now. They've got these 6 categories which are both for UK and international. We had a lot of international entries last year, just 2 entries from India because it was a little late since we started promoting it. But if you feel you've got an interesting project, either yourself, your client, your facade consultant, or along with your material manufacturer, you can nominate yourselves over there. It's a truly global event. It happens in the heart of London in a black tie setting. So it's a very interesting format. And I request all of you who are designing buildings over here, designing interesting facades, and you feel you have any of these 6 categories, you can fill up your nomination. You can visit this link or scan this QR code and apply for this. So I think the nominations end on 19th of June. So we've got 3 weeks. So yeah, so this is it from me regarding the conference. I hope you enjoyed today's day. So we won't, just a couple of housekeeping questions before we leave. We won't be taking any questions due to paucity of time. So any questions you have for our speakers, you can meet them outside. All our associate partners and our event partners have a booth outside. Please network with them in the networking breaks or whenever you get an opportunity to do so. And we have recorded this event today, so a week from now we'll send you the YouTube link of this event, and then you can watch the recording of this event. So that's it from me. I'd like to call upon today's event host and convener, Nikhil ParasuRaman. He's the director at SE Controls India. So he's going to be hosting today's event and taking you through for the rest of the day. So over to you, Nikhil.
Good morning, everybody, and Vanakkam Chennai. How's everybody doing? Good, good. Good to see you all, and thank you for spending your day with us today. Welcome to the second edition of Zak Chennai. It's a special edition because 10 years ago I visited Zak first time when I started my career with SE Controls, and life's come almost a full circle now. And this is the 122nd global edition of the Zak World of Façades conferences. So welcome to you all once again. My name is Nikhil ParasuRaman. I take care of SE Controls India, and we are into smoke management and smoke control systems using facade automation as the backbone of our systems. So just to start off today, Ahmed's already done a bit of housekeeping. So we'll be taking questions at the networking break and not during the sessions or just after the sessions. And another thing is I would like you to please keep your phones on silent mode as a respect to all the speakers and panelists who are coming to speak here, because we have a very exciting lineup for you guys. Now starting ahead, let's start with C.S.Raghuram ji, who is a founding partner for Trilogue Studios, and he'll be delivering his speech on sustainable design processes in labs and education buildings. Raghuram ji, welcome. Welcome on board.
Okay. Good morning, everybody. More than the presentation, I was more nervous when this guy was fixing all of these contraptions onto me. So anyway, so hope it works or continues to work. So we have a long day ahead, and we already have the timer. So I'll just jump right in. Thank you all for coming. I'll set the expectations. What this presentation is that it is not a set of pretty pictures. It is not even a project that is completed. What it is is that it is an example of a design process that we as the company are very, very keen to bring in, which is bringing in sustainable design practices very early on in the design process, because that's where the actual difference is made. And it is not something that, it's not a pursuit of any certifications or, platinum rating or, gold rating or any of that kind. What it essentially does is that it brings in a financial viability to the customer when we bring sustainable design practices into the built environment. Because end of the day, if the customer and the client is actually agrees to incorporate some of these features, that's when we architects, builders, etc., can actually make a difference to the built environment. So this is actually, and also it also establishes that sustainability is scale agnostic, which means that you could bring in sustainable practices in a small classroom. You can bring it into an R&D building which is just built on 0.6 acres, 30,000 square feet, or you can bring it into massive, large-scale, complex industrial or commercial buildings. So this is a case study of a project that's not very far from here. It's in Maramela Nagar. It's an R&D building for Tagros Chemicals, where they're putting up their lab buildings. Essentially on a site of about 0.6 acres, a lab building is extremely technical, right? So there is actually very less space for, actually it's not fully, the full screen is not visible. Is that something that you could do? Right, so the lab building is actually a very technical building, right? The labs are essentially the core of the building, and then the support spaces, which are your offices, your services and utilities, etc., are actually literally servant spaces. So they actually only are there to support the main function of the labs. So being such a highly technical building and on a very tight urban site, we had to create this box-like structure with a central atrium. While he sets up, I'll keep talking. And keep enough space for expansion into the second site. Then what we did is, then we looked at the basic planning of keeping the main labs on the north-south and keeping the main, the conferences and offices actually on the western facade. Now, ideally, we always say that, buildings have to be oriented north-south, take care of wind directions, etc., etc. But when you're working on an urban site, a very tight plot, you do not have the luxury of, it's okay, we'll keep going forward. We do not have the luxury of all of that. So if you actually look at it, this is actually the western side, all right? So, I mean, this has been warped, but this is the actual western side. So what essentially ends up happening is that this becomes your main facade over there, right? So if you look at the axonometric, we ended up creating the parking in the low level, creating your main entrance again on the western facade, because that's where your main roads are, and then creating your utilities and services right at the very back. It's on the east. So trying to protect the lab and from lots of solar radiation, and then keeping these support spaces on the east and the west. And then we continue to stack it up on the upper levels, keeping your pilot plants, keeping your labs, and again the support spaces, and then your lab support spaces also coming in the east and the west. This was from the evolution of the main of the concept. Then we go into the actual planning of the building. So here we look at, again, like I said, this number 10 is where your main labs are positioned, facing north and south. So to the right is north, right? And then to the top is west. So that is actually the main facade, and also the most, the dangers when you look at the amount of solar radiation that is coming in. And then, of course, you have all of the, utilities and other support spaces coming on the east. So this was the initial renderings that we presented to the client, but this is not where we stopped, right? Because this was just the starting of the whole process. Now, we collaborated with Yaksa Environments. They specialize in energy efficiency, they specialize in daylight analysis, energy modeling. And what we did is we started looking at a base case and then a proposed case. So when you look at it, the plan is now tilted. If you see when I presented, the west was at the top. Now we've just got it due north. So we looked at, creating the studies based on the actual plan as it is, and then bringing in modifications and improvements to the facade. This presentation is again focused on mainly the facade is because that is actually one of the major pain points when it comes to solar radiation, when it comes to energy gain and heat. The equipments, which is your air conditioning, your electrical, etc., are also there, also going to contribute to it, but they actually come secondary, right? Because you can have actually a lot of control in that. But here, depending on site constraints, depending on the layout, that's actually going to be a main pain point. And if we control it, we can actually bring in significant amount of difference. So these, the ECBC compliances, ECBC norms are then taken into for the first level of analysis. And then we started modeling. This again is on the western side. This is where the main entry is. The rest of the lab actually extends to the, on the right. This is the west, it's due north. Just to again reorient you all to the plan. So if you look at it, in the base case scenario, without any surface fenestrations, without any surface treatment, we looked at almost a 55 to 60% of glare. The UDI, the useful daylight illuminance, was for greater than 2000 lux. ECBC stipulates up to 2000 lux as UDI, as the ideal condition of UDI. So if you look at this, more than 45% or more than 55% of the spaces were higher than the norms. So that resulted in significant amount of glare, and as we'll see later on in the presentation, that began to contribute significant amounts of solar radiation gain into the building. So again, we modeled the same thing on the first floor levels. So if you looked at it, more than, again, 56% and 21% was higher than the 2000 lux. So that is again, the ground floor, the first floor. If you start looking at it, this is the main lobby, on the western side. All of this were contributing very significantly to, solar heat gain and radiation. Now, so this is a compendium of all of the studies. Again, I'm only presenting the data on the summer solstice, which is June 21st. If we did, of course, the whole process involved a significant iterative process that went during the summer solstice, the winter solstice, which is December 21st, thereabouts, and also the equinox, which is September and March. So then I'm just only presenting only the worst case scenario. Then what we did is we looked at creating a parametric facade on the western side, and then in order to give a break, we peeled away certain parts of the building in order to create certain terraces that will be shaded by the roof as well as the upper levels, and then try to study what is the impact of the on daylight and also on the solar radiation. So then, again, you're looking at different angles. So what we did is we looked at louvers. These vertical louvers, we again did a multiple iterative process of 60 degrees, 115, 125. We modeled it using Ecotech, Rhino, Grasshopper, and we looked at different results. And and for each of the buildings, each of the openings, we ran these simulations. And what we found is that, again, 115 and 120, if you looked at this, I'll just go back. What we started finding is, if you just start looking at this as the base case, right? This is the base case, which is you're getting the shading of about 29%, and with the vertical and the horizontal shading, we are increasing the shading to about 60%. So those are the important findings. Now, as you look at it, as we go forward, we start seeing the difference of we start seeing the difference as to how much of an impact simple design interventions at the very early stage in the building process starts giving positive results on the energy efficiency point of view. So now we looked at a different angle. We looked at again the iteration on the 125-degree angle of the louvers. This is to the vertical. And then we looked at on some aspects the shading difference started dropping. So we did find that end of the day, 150 angle begins to yield better results on the shading and therefore in the solar heat gain. And creating therefore the final configuration of louvers for the detailed design. So there is a scientific process that we want to bring in into the whole design exercise through simulation, through software, through technology, so that there is a rationale behind the choices that we make. So once we do that, you see that the glare starts dropping from 55% and up to just about 39. Your the useful daylight illuminance, which was way above 56%, starts dropping to 35, 39, and your useful daylight illuminance in that 300 to 2000 lux starts going up to 46%. So that is the impact that that technology, that simulations can actually bring to a project. Again, automatically a lot of difference starts happening to the daylight that's coming within the building. Again, we ran once we did this, the parametric facade, we then ran this data once again. And again, so here I'm only presenting you the final results. There were a lot of results that obviously we had to throw out of the window. So I'm only sharing with you what we finally zeroed in on. Now, we take the same thing and we look at the solar heat gain, because both daylight and solar heat gain go hand in hand. You increase daylight, it may be good. You reduce your dependence on artificial light, but you're allowing a lot more solar radiation in. You cut out daylight, you're going to increase dependence on, on artificial light. So it's actually an iterative process which requires a lot of patience. But today, with technology that is available to us, we can run these simulations fairly quickly. And what we are trying to do is that we want to create this process. We want to create this template which almost everybody can use. It's not specific to either Trilogue or to Yaksa who are doing it, but it is available to almost everybody in the building industry, because at the end of the day, knowledge is for everybody to use, essentially, if we want to create a positive impact for climate change. So looking at the base energy model, we looked at the basic envelope specs, a fly ash brick concrete slab, single glaze units without any insulation. And then we analyze the amount of cooling loads that are coming into the building as a result of that, and then take it forward with air conditioning loads. Now just keep a watch on these values that we are looking at. We're looking at 9 tons, 6.6 TR, again in the third floor 9 and 11.3. So I just want you to keep an eye on those figures. This is the base case scenario. These are the average cooling loads that are coming in without any shading, without any specific facade intervention. And then once we bring in these parametric facades, why I keep saying parametric facade is because we looked at it essentially is only louvers. But what we then went on to do is that we tried to use an algorithm in the Rhino Grasshopper plugin to create a little bit more interest. At the end of the day, I am still an architect, so not a data scientist. So I did want to create that particular interest. So that's why I keep referring to it as parametric facade. But it is essentially a louver design. So once we looked at with these louvers on the facade, and we improved the envelope specifications with your XPS insulation, high SRI tiles, a better glazing with better solar heat gain, better shading coefficient, we'll start seeing the results immediately. Now, these louvers, today, actually, if you just walk out the door with all of those stalls there, every one of those stalls can actually provide the solution for what we're talking here today. So actually, I'm a big fan of collaboration. I'm a big fan of how much the applicators, how much the industry can actually contribute to us designers. And it's very important that in the coming years, with so many challenges due to climate change, I think it's very important that we go hand in hand. Now, again, we ran the simulations on a peak summer day. Simulations were run for, again, all the different solstice and the equinox. And then I'm just presenting the results of the worst case scenario. So again, we're looking at energy factors, light, glass, looking at different different facades, the north, the south, east, and west. And then automatically what we were looking at, 9 and 8 and 11, the average cooling load started dropping drastically. And what we finally looked at is almost about 20% of savings in cooling, on cooling loads, just by the whole introduction of this facade. So, and this, we are only looking at the facade itself. We now will, as a team, as an organization, we extend these studies into renewables. We extend this into water consumption and storage and reuse. We look at indoor air quality. We look at ventilation and so on. But for the purposes of this today's event, being about facades, I'm presenting only the facade component of our project studies. And then, again, end of the day, these are the renderings that we have presented to the client. We're waiting for a buy-in. But what ends up happening is that the payback time, what we have calculated, there is a delta X that that is incurred due to the incorporation or the design or the execution of these facade elements. But when you balance it against the savings in your air conditioning loads, you're looking at a payback time of about 2 to 3 years, after which you're only looking at savings. So it's not just on, like I said, it's not just pretty pictures, but it is the technology and the process that goes behind it and the financial viability of it that actually will help us sell this idea, right? And then again, this was actually looking at it as a straight facade without any of the and parametric nature, and then we started looking at creating this, creating this kind of wave pattern a little bit more, creating this wave pattern, a little bit more interest into the design. And these are the internal courtyards that we see in this picture. We're going to now focus our energies into then the next level of design development. So the software used, we looked at Ecotech for shading device articulation, design builder for energy simulation, Rhino, Grasshopper plugins, and Honeybee for daylight and glare. And special thanks, of course, to our collaborators, Yaksa, and very special thanks to my colleagues who have taken the time to come here from the organization. Thank you so much. It means a lot to me. And thank you all for your patience hearing.
Thank you, Raghuram ji, for that insightful presentation. Sustainability is the word of the day, and the next speaker as well. Welcome, Mr. Niraj ji, who's a country manager of Danpal. He'll be speaking on facade solutions for optimized light and solar control. Welcome on board, sir.
Thank you, Nikhil. On behalf of Danpal, India, I would like to thank Zak World of Façades for this opportunity to speak here in front of wonderful crowd here in Chennai. And I think that was a wonderful presentation by architect Raghuram. We have we have some link to that to this presentation as well, and would like to present some solutions on the facade solutions, which we can actually see the optimization between the daylight and solar control that a facade brings into the building. So before we get into the topic, let me briefly introduce about our organization. Danpal as such is a more than 50 years old company with a lot of innovative light architecture solutions. Danpal is the first company who actually came up with a translucent panel system with standing seam back in 1980s. Danpal is a global brand present in the 60 plus countries, 10 million plus square meters of Danpal on panel installation in renowned projects across the globe. We have 6 architectural solutions, as you can see, that includes facade, cladding, skylight, outdoor, interior, and shading. We call it as light architecture. So in architecture, the facade of a building is often most important aspect from the design standpoint, as it sets the tone for the rest of the building. From the engineering perspective as well, the facade is of great importance due to its impact on the energy efficiency. The soul of contemporary architecture is innovation, newness, and novelty. Novel in this case means willingness to experiment with something new that hasn't been tried before in terms of space, light, shape, or material. The contemporary architecture typically uses unconventional material or the use of industrial material in domestic spaces. These 3 principles, when applied to the building, ask us to be innovative with our choice of material and solutions. The daylit spaces hold a lot of potential for energy savings. We have seen that in the presentation of architect Raghuram. It also yields substantial benefits in terms of increased revenue in retail spaces. It yields substantial benefits on human productivity and health. So it is up to us, by using these modern materials, to seek and create building facades that gives us natural light as well as control the solar heat gain. Facade need to bring in, yes, definitely the daylight. The daylight with it accompanies the solar heat gain as well. So we need to look at the, create a balanced facade which can bring in the daylight but also allows for the solar control. Well-designed sun control and shading devices can dramatically reduce the building peak heat gain and cooling requirements and improve the natural lighting quality of the building interiors. Let's look at briefly, I'm not going to go too much into the deep of the aspects of light, but just in the basic, we will just look at what this commodity light is and how we can use it in the buildings. So we know light is electromagnetic radiation spectrum with a wavelength defined between 400 to 700 nanometers between the infrared and ultraviolet rays. The main source, of course, is sun for the lighting on Earth. So along with this light comes other properties such as heat, which we feel, and there are other properties as well which we don't feel or see. There are three main properties of light: the speed, reflection, and color. So as you can see, different parts of the light here, starting from the microwave, infrared, going up to X-ray and gamma ray. The visible spectrum is of course limited. Talking about the three properties, the main properties that are important of light from the facade perspective is the color and the reflection. So the color itself has three properties, that is hue, chroma, and value. Hue is basically the color, if we like a blue, which is defined by its wavelength. Chroma is also called as saturation, and value is the lightness, that is how dark or light is a color. Speed, of course, we know nothing travels faster than speed. In vacuum, the speed is almost 300,000 kilometers per second. Coming to reflection, this is an important property from the design point of view for facade. A concrete block or brick surface diffuses light, and only 10 to 20% light gets reflected. That scatters in all directions. By contrast, a glass can reflect almost 100% of light, and it can get reflected in one single direct beam. So you have different kinds of surfaces like specular, glossy, or diffuse. Before we get into the designing with light, keeping it light in mind, let's look at some of the benefits that light brings in. Here are some benefits that are listed. The office workers with windows had more sleep per night than those who didn't. Office workers with good daylight had up to 40% improvement in their productivity and also in sales in retail spaces. Daylight is the number one natural element wanted in the workspace design. A well-designed classroom with a natural light explained 16% variation in the learning. Workers in offices with natural elements like greenery and sunlight were found to be 15% more creative. There are, of course, other benefits like the view quality. Natural light improves the mood and also positively impacts the circadian system functioning, and of course, vitamin D regulation. Another aspect that we can keep in mind while designing with the light is the lux levels. The lux levels is nothing but the illumination that is required for a specific spaces. This requirement can change from a building type to different areas in a specific building. So warehouses with the large items may require lux levels illumination of 108 lux, whereas warehouse with small items 323. A factory with a detailed assembly, the requirement of lux numbers can increase dramatically to 10 times that is required in a large items warehouse. The outdoor lux levels on a clear day is approximately 10,000 lux. So when it comes to lux levels inside the building closest to the glazing or a window, it falls down to almost 1,000 lux. And in the middle of the building, probably it may even fall down to 25 to 30 lux. There we may need to have the artificial lighting requirements. Another aspect is interior lighting. The human-centric lighting is important as it explains how we are able to sleep at the nights or even during the daylight. Why workers prefer to work under specific light levels. We know that the most obvious effect of light on the human being is it enables us to identify the shape, color, perceive information related to the objects. But the daylight also impacts our biology. It affects our hormones, alertness, attention, and fatigue, and also determines our body clock. So it's important that we need to pay attention while even designing these interior spaces. Now working with the natural daylight and understanding the light temperature. Again, as I mentioned, in the properties of light, the color is important, and this light temperature is related to the color temperature. The windows which are, the desks which are placed near the windows and people sitting there were found to have a positive impact of the natural daylight, whereas the people who were sitting away from windows were found to have a negative impact in terms of, having sick leaves or not feeling well while working. So the color temperature, as I said, is important in any building space, and in highly concentrated workspaces, this should be close to 5,500 to 5,800 kelvins, which is typically a midday sun color temperature. Here is a table where you can find different sources of light giving the with the color temperatures in front of them. So as you can see, the midday sun is somewhere here, which is 5,500 to 5,800. So anything below has a lower light level, a lower color temperature, and what you see above is, in fact, it's the other way around. So again, designing for the interior spaces also need attention to the glare and reflection, which a glazing system that might bring in. So there are of course two types of glare which we can differentiate: the direct glare that is brought in by the sunlight or a badly placed lighting element on the eye, and indirect glare is something that is reflected from the smooth surfaces on the workstations, maybe a laptop or even the work surfaces. So glare should be avoided in most cases as much as possible. I think this is something which architect Raghuram has touched upon and discussed in detail. We can use the computer-aided modeling simulation softwares. So with this kind of advanced simulation softwares, a detailed light map can be produced, each reflecting the choices of the material that one needs to use in the facade. Or even you can decide on where the actual artificial lighting is required. So here is an example of a simulation of a building, same building at 3 different times in a day, and you can see different types of illumination that is given here. This is corresponding to the kind of illumination. This is the glare which you see here, whereas you can see some of the dark areas where we need to consider the artificial lighting probably, and depending on different seasons or different times in a year, this can change. So of course this computer softwares, these simulations can help to actually define what kind of environment you want for a specific building, and depending on that we can choose a kind of facade that is needed. Of course Danpal has these softwares, and it can be provided for different kinds of panel, starting from the various colors to different thicknesses. So the figures can change dramatically, and we can suggest after doing the simulation what kind of colors can be used in a specific building. So here is an example of Danpal-based facade system that creates a balanced interior. Here basically Danpal panels have been used in the roof. You can see the natural daylight that is coming in during the daytime, and there may be need of very little artificial lighting. An example of again the balanced interior with the facade applications. So we can, depending on the requirement of light, and we can change the different kinds of panel and different kinds of color, and we can achieve kind of a balanced interior environment. Another example with the roofing with a different system. So as we all know, with light, we are also bringing in the heat. So how can we actually design a glazing that can bring in the daylight, but we also allow the solar control? It's important to reduce the solar control to the extent that is possible. So solar heat gain is basically influenced by the glazing type, the number of panes and any glass coatings that you have, or any material surface that has coatings. So solar heat gain of glazing ranges to over 80% for uncoated water white glasses. SHGC indicates how much sun's energy is striking to the window that is transmitted inside. So you can see here the SHGC is indicated for different thicknesses, and the number of panes can also, define what is the amount of solar heat gain is gone into the building. So with the help of different kinds of panels that are available with Danpal, and choosing the right kind of color, we can actually reduce this solar heat gain, and it could be reduced to almost 0.17, which is quite low if we compare it to the previous slide. For the context, when considering the laminated solar performance glass, the figures could range in between 0.61 to 0.25. So with the multi-cell panels of Danpalon, we can achieve this particular solar heat gain of 0.7. Here is an interesting example of a circular building completely clad in Danpalon panels used with a proprietary Danpalon facade system. The panels were additionally finished with mattifying soft light effect. This coating is applied while co-extrusion, and we can have a balanced interior where we can block as much as heat possible, but we can have the light. Another example, using different kinds of panel, we can bring in the as much light as possible, but block the solar radiation. With these computer softwares, we can also control the light, solar control through this simulation. So we have seen that we can create the light maps. So with this simulation, we can also create the heat maps, wherein we can actually make choices. So this kind of software are always helpful to make the decisions on the what kind of material to be used on the facade. Here is another kind of panel that has integrated louvers within the panel itself. When installed in facade, it can block the midday sunlight entering into the building, while evening and mornings we can have more light coming into the building. Another example of low E panels, this blocks the infrared rays and reduce the heat gain. So here are some examples of facade, which are in combination with glass of Danpalon panels. Another example of facade with a Danpalon panel as second skin with the glass. Some examples from India, project installed in Hyderabad recently, the largest prototypes center in India. A project in Mumbai where facade has been used as Danpalon panels. A project in Hyderabad which you can see as example of outside facade and how the light is transmitting inside. So that's that from me. Thank you very much for being patient and hearing me out.
Thank you, Niraj, for that presentation on sustainable materials available today for a greener facade for tomorrow. Next presenter will be Nandakumar ji from Evermark Facade, and he will be explaining to us about life of a project manager. Even I would like to learn a little bit on this now. Thank you, sir. Welcome on. Thank you. Please give a round of applause.
Thanks, Nikhil. Good morning, everyone. Yeah. My topic is little different from the regular technical topics which are lined up throughout the day. So I want to present something new. It is not new actually, which we are experiencing every day in the projects, but I want to get into little more details about project management, and especially I'll be talking more on the facade project management, which I feel it is the need of the hour. And and this forum will be, I thought this forum is a perfect forum where I can present this topic. So this is my first slide, where I just want to start with this. So facades, as everybody knows, it is the exterior covering for a building. So we normally do facades for various reasons, not only for aesthetics, but aesthetic is one of the main reason. And my first picture tells that behind every glorious facade there is always something hidden ugly, but ugly in the sense it's not ugly, but we are just trying to make it more aesthetically good. And the second one is more related to my topic today, wherein we have good designs, we have good consultants, we have good architects, we are doing fantastic designs, and also in India we are doing designs for Western countries as well. But when it comes to project management, I think we are lagging behind a lot. And the second picture shows that we have a lot of specifications in place, we have so many things in place, but when it comes to execution and managing the things and the realizing the design, I think we are behind, and I thought this picture will tell more about that. So coming to my topic, which is called facade project management. So let's define what is facade, who is a facade project manager in the first place. A project manager who is specifically assigned for the facade works, who takes care of the planning, execution, controlling the project. So the facade project manager plans and designates the project resources, allocates the project resource, a particular person in a particular role in a project, manages them and directs them and gets the work done. And nothing but the least, the project manager should be able to communicate with the entire stakeholder at the right time and the right place. So we need to have a project manager who can communicate properly day-to-day ongoings of the project. And everything has to be done within the organization goals and the client interests. So this defines a project manager in general. So why we need a facade specialist project manager? So we are seeing, we have a lot of project management companies or project management consultants in India. And normally what happens in a project, which I have seen like 99% of the projects, there is a general project manager who takes care of the facade as well. Like most probably a person who takes care of the civil takes care of the facade project management in a project. So as you know that every commercial buildings we have facade, and as the facades are getting complex and complex every day, so we need to have a specialist project manager who has experience in the facade, who can take care of who understands the requirements. Because facade is not only about the civil, it is about architecture, structural, and even the fabrication. And so a lot of streams are getting aligned together. So that kind of experience only a specialist project manager can have. So that is why I thought there is a requirement of a facade specialist project manager. So what are the qualities of a project manager? The first thing is whoever appoints the project manager, he should give authority to the facade project manager. So we can't appoint a project manager and tell that he is not given any power, so that will not work. The first thing is the project manager should be able to take decisions across the table on the ground, and he should be able to he should be able to build a team, lead a team, and he should have a proper communication. So communication, as we all know, is the key for any project management. So the communicating with the stakeholders and to the proper stakeholders is very important. So these are the qualities of a facade project manager, and most of the time what happens is the installation manager, as I see in many projects, is considered as a facade project manager. Though installation manager is an important element in a project, the project manager is a person who takes care of the entire project, like from the starting till the handover is responsible. So he is the one-point contact for the project. Like so, even he should be involved in the design, he should be involved in the procurement, he should be involved in all the communications, management level decisions, everything. So project manager is not an installation manager. So that should be very clear. So since it is a very general topic, so I thought let's get into the details of facade project management and let us apply to our project specific to the facades. So there are 5 project management process actually, which is taught in a facade, in a project management, the project management skills. So the first one is the initiation, which is the starting of the project. Any project start is an initiation of the project. Then planning and design. So this is a must. And then we go to the execution of the project. Then monitoring and controlling. So this is a cycle. So now planning, execution, monitor and control. So if the planning is, whatever the plan is done, that has to be executed. And that has to be cross-checked, whether the things are going as per the plan or if there is any change in the change is happening from the what is already planned. So if it is not happening as per the plan, so we are going back again to the planning stage. So this cycle should be followed, and once that cycle is achieved properly, then we have to close the project. So this is actually a project management process, and any project manager will normally juggle between the cost, the schedule, and the quality and the performance of the project. So these 3 things are very important, and always he will be looking for these things and try to balance these 3 things in a project. So the basic thing in project management always he should keep in mind is he should plan, act, and reflect. So this cycle has to be done at every stage of the project. So if it is, so that cycle has to be completed properly. Then only you will be able to deliver a project, proper project which is in line with the requirements of the client. Then the last triangle is called as a triple constraint triangle in a project management. So that, so whatever we have agreed as a scope in the initiation of the project, so there is a certain amount of time allocated, there is a certain amount of the schedule which is already agreed, and so this has to be maintained throughout the project. Now if in between, in the process of the project execution, if there is a change in the scope, for example, so accordingly there should be a cost increase and a time schedule which has to be fixed. So if we just increase any one parameter, this triangle will not be a equilateral triangle anymore, and that will affect the project and your quality of the project. So let's get into the project management process. In brief, I will just run through this. So initiation process is something which is the start of the project. Now, it can be something like a kickoff meeting in a project. So that can be the start of the project. So what we do in a kickoff meeting or the first meeting in a project. So we just get all the data from the different stakeholders. First is identifying who are the stakeholders. Now we have there is a contractor. This is the first meeting to start a project. So he will try to identify who is the architect, who is the person, coordinating person from the architect side, from the PMCs, from the client, from the other stakeholders. Then in general, we need to know what are the goals of the project, so what are the timelines of the project, what is the budget allocated for this project. So this is the initial the stage set for the project. So this is the initiation process. The next is the planning process. So the planning is always the most important process in a project management. So this has to be given enough time for the proper planning. So there are various, we call it as a knowledge areas. So the other like a scope, quality, human resource, communication, procurement, risk, cost and time. So these are the different knowledge areas in a project management. So the process is the 5 process and different knowledge areas. So each knowledge area is applicable for all the processes. So this planning stage has to be perfectly done. So, and as I told, is the planning, execution and the monitoring and control is a cycle. So we go from initiation to the cycle, then to the closing of the project. So the planning process, so this is something which, as I told, that planning is an important stage in a project and this has to be given enough time. So the more time you spend on the planning, the easier your project execution and your project control becomes more easier actually. So one is the scope. So the scope, you collect all the requirements. That is in the initiation process itself, you get few of the requirements. So you get into the more details and collect the 100% requirement for the project and define a scope. So now the scope in any point of the time through the project, if there is a scope change, so we have a document which says that there is a change in the scope and so maybe we may have to ask for a scope change order or it will be a non-tendered item or something like that. Then schedule. Schedule is one of the important things, as you know, because once the project is awarded, the clients are behind us every day to they in fact ask us the progress of the project. So scheduling is most important and getting the schedule agreed with the stakeholders is also an important step. So scheduling requires 3 steps. One is define all the activities, sequence all the activities and finally you prepare a schedule. So schedule is something which has to be prepared and it has to be followed. Then quality, cost, communication, risk, design. So all these things has to be planned and procurements, of course, it has to be planned. So it can't be planned as an individual knowledge. It has to be combined. For example, a procurement. So you know that there is a particular material in a project which takes more time. So that is there is a time risk in the project. So you have to plan the risk accordingly. Maybe you will have to order that material first so that it has a larger lead time which has to come from a very distant place. So this kind of planning is very important. So planning stage is one of the important thing and then execution becomes easier once you have a plan. So whatever you have planned, you just manage that. You try to execute in a project like whether it's a scope, time. So the project manager always executes as per the agreed plan and he keeps the stakeholders informed about the execution and if there is any change in the plan, if there is a constraint, a new constraint comes up, so that has to be properly validated, communicated to the client and maybe there might be a cost increase or time increase or there might be a change in the design or something, so that has to be communicated properly and tested. So directing and managing a project is an important step. And next is the controlling process. So controlling is something which we reflect what has been planned and executed. Execution is going hand in hand. Now if there is a change in the scope, for example, for something is planned in the scope and while execution there is some additions which has happened or some deletions which has happened. So that has to be properly recorded or documented and it has to be agreed. So it is more of a documentation and the process oriented approach has to be followed. And schedule, as we know, there might be new constraints coming up from the other trades, for example. So your activity is after the other person's activity, so that person is delaying a project, so that has to be communicated and you will have to ask for a time extension or you will have to work out a different strategy to manage the schedule. Then accordingly the other knowledge areas such as quality, cost, communication, risk and design, of course design happens from the in our projects till the end of the project. So closure of the designs before the execution and the completion is very important. Then procurement, controlling the procurement. So we have ordered the materials. So whether it is coming on time or whether it is supplied to the projects on the time, or is there any quality issue. So these kind of things, so that the monitoring and controlling is very important step, and this is something which has to be done. And the last but not the least, a project closure. So most of the time what happens, during the end of the project manager is not there. He is assigned for a new project. So that should not be the case. So the project manager should be there till the end of the project, and he should get the client agreed for the project closure. So normally what happens, if the project is not closed properly, it may come back after 6 months or 1 year telling that something is not handed over properly, some issues are arising. So if you properly close a project with the proper handing over document, the sign off on all the deliverables, so then there is a document to show that you have done your work. And the procurements, you will have to close the procurement. So closing stage has two things. One is the scope closure and the procurement. Procurement is from your suppliers. You close the procurement properly. So all the test certificates, you will have to get it from them, and your warranties, back-to-back warranties from them, and any defect liability is there. So you will have to properly agree, and operation manuals. So that has to be got from them. So all these things is a process of closing of your procurement. So this is something which has to be done. And I have just put everything in one Excel sheet. So this can be shared if somebody wants this, who are more interested in to project management. So my previous slides, whatever I have spoken, I put it in an Excel sheet, and this can be used as a ready guide. So having said that, project management is like, it's not as easy as it is just described in the slides. It requires a lot of experience, so in different projects has a different way of working, different clients have a different way of working. So we have, as a Evermark project solutions, we are a facade consultant actually. So we are 4-year-old company. So we are mostly doing facade design works, and many of our projects we have been appointed as a specialist project management consultant as well for the facades, and definitely it has worked and it has benefited the clients a lot. And we follow a process which I just explained before in the previous slides, and which so if you want to learn more about the project management, and if you want to manage a project in a more effective way, so you can contact us anytime. So this is my presentation. And thank you very much for giving me an opportunity to present. Thanks, everybody. Thank you.
Thank you, Nandakumar ji, for that presentation on roles and responsibilities of facade project manager. It's wishful thinking, but someday all of us will complete our Indian projects on time and within the budgets. Introducing next is Arun ji from Serge Ferrari. He's a South Asia General Manager, and we'll be speaking on fabrics as facade solutions. Welcome on stage, sir. Please give a round of applause. Thank you.
Good morning, Chennai. Vanakkam, Chennai. Really happy to be part of the Zak facade presentation in Chennai. Okay, Serge Ferrari Group, manufacturer of flexible composite materials for diversified applications. We are celebrating 50 years of existence in this world. So I'll go through the presentation. I'm Arun Madappallath, General Manager for South Asia and Director of Indian Operations. Over 20 years experience in the membrane industry. Work across Middle East, Southeast Asia, and South Asia. So this is a small video, a corporate video. Okay, so that was the video, corporate video of our Search Ferrari group. So our CSR approach, we are, into sustainability solutions. Search Ferrari, started manufacturing from recycled materials. The fabric which is used, made of high tenacity polyester and a PVC coating. We recycle these fabrics. We take out the yarn and we take out the polyester and we reuse it for many applications. We started with solar protection now and for the signage applications. So slowly, we will be developing, our R&D will be developing, more and more into such kind of products. So we are into 4 key markets. One is solar protection. Solar protection is a membrane used for internal and external window covering solutions. Then modular structure, wide span tents, warehouse applications, etc. Furniture and marine applications, we have fabrics for that. And the key market, which is tensile architecture, mainly the roofing solutions and shadings and canopies application, plus facade and acoustic solution. So today we will be covering the facade market in all these 4 markets. So why fabric as a facade? Okay, it's an important subject, and we have different parameters of classification, which I'll be going through one by one. One is thermal insulation and visual comfort, outside visibility. Even if you are using fabric as a secondary membrane, your outside visibility will not be blocked. You will have a clear visibility towards outside. Thermal control will have good protection because heat is cut outside the building. Glare control, there will not be glare in your working atmosphere, and natural light inflow. So natural light inflow, we have a world study on this, this subject. So people will be more comfortable, and you can save a lot of energy because of this, and good working atmosphere can be created based on this. So as you can see, protection from glare, there is no glare, and natural light into the building. You don't need, you can save energy because of that. You don't need artificial lighting, solar protection, and thermal control. Unique identity to your structure. This is the second chapter. You have 3 possibilities here. One is LED lighting. You can, highlight your building with different LED lighting solutions, which is common nowadays. Then we have 3 designs. Because it's a flexible material, you can create a 3-dimensional design which is unique for your building. So such possibilities are there. And then textile printing solutions. So you can do printing on this fabric as well, and you will have a different, as per the design solutions possibility. The next one is energy saving. This is an important subject. So we have 2 possibilities of using membrane. One is for the internal as a blind solution, and the second one is for external screen solution. So internally, the energy, the light, or the heat will come with the glass and then come to the fabric. So limited energy is saved when you put a blind inside. But in the external case, when you put the fabric externally, most of the heat, 80% of the heat is cut outside the building. And then it comes to the glass, and then it comes to the room. So you will have a very good energy saving if you are using externally the blind system or the facade, permanent facade solution, rather than putting the blinds inside. So this is a good savings of energy if you are using fabric as an external facade. Heat reduction, light control, at the same time the vision is also not blocked. We have a case study, it's a Sotheby's project in US. So this was the building actually. It was not looking good also, and the air condition was running heavily with this building. So they were facing difficulties, and the tenants were not staying in this building. So we have proposed a fabric solution with this external fabric solution, so that to save the energy. It was after the study they have done this, and then we did this solution. You can see that cost saving of 200,000. Total investment was 200,000 for the complete project, and over a period of 15 years, you can see that they have completely changed the dynamics of the building, as well as a good energy saving for these projects. So this is before and after, and you can see the whole aspect and the identity of the building has completely changed after installing the fabric. So fire, it's an important parameters in all building applications. We follow all international standards. We have two types of fabrics. One is PTFE fabric, which is a fire-resistant fabric, which is made of glass yarn and coated with PTFE, a very tested material and a lifespan of 50 years. And then we have PVC PVDF fabric, and it follows all international standard, which is a fire-retardant material. Lightweight, as you can see, this is just a comparison between flexible material and a solid material, mesh material. You can see the outside visibility is really good when you're using a fabric as an external facade application, and cost-effective comparing to the metal, lightweight, and at the same time, it has an effect on the wind noise as well. So it controls better than the conventional materials. Few construction possibilities, cassette panel construction. This is an Airbus restaurant in France. Large panels and three-dimensional structures. And at the same time, not blocking the light, good visibility towards outside, and better glare control and heat resistance. This is a very good example of a solid membrane. This is a project Burj Al Arab. Most of the people know this project. It's a landmark project in Dubai. The external membrane of the, you can see the white color membrane used is PTFE material. It's more than 25 years. It has withstood all the sandstorms and the harsh climatic conditions, and still the fabric is intact after 25 years. So the longevity of the materials of this PTFE is really high than any other materials. This monolithic construction possibility, project in Shanghai, German pavilion. This is one project which was done for an exhibition, and all the fabric after the exhibition and after a certain time, all the fabric was recycled in our facility in Italy. Retrofit and renovation possibilities. You can see the difference in the aspects of the building after installing facade. Lightweight structure. You don't need any additional reinforcement or possibilities. We can do it directly to the building. This is another project, a complete glass facade, completely renovated, and the look of the building has changed after using the facade, same time providing energy efficiency and light control. Some good design, architectural features can be applied using a membrane because it's very flexible. You can see the complete aesthetic of the building has been changed after installing the fabric. Another project. So you can see the whole stadium is wrapped with the fabric. We have different types of fabric facade. One is breathable mesh. We have it in PVC coated material as well as in PTFE coated materials. Here, it's a mesh fabric. We have openness factor starting from 14% till 50% openness possibilities there, depending on the project and depending on the light requirement and the requirement of the project. You can select the different types of material here. The second one is opaque waterproof. If you want to have the complete privacy and the heat control, normally opaque fabric is selected, and this project is completely wrapped with opaque fabric. Then we have highly translucent waterproof material. So we have material which is again PVC coated, PVDF coated material, which can be translucency starting from 14% up to 21% light transmission possibilities are there. Then transparent. So this is a new innovation from Search Ferrari, a product called STFE. Here, the light transmission possibility is up to 55%, and at a certain height level, you will not see, you will see as, you can see the sky here through the fabric. It is a clear, transparent material which can be used for, light transmission and vision required. This project is a combination of PVC, PVDF material and high translucent material, and you can see the difference in the combination. So we have a lot of service open for this membrane industry, multitude of fabric to choose from, different fabric, We can give color fabric, resistance, low maintenance and cleaning, and resistance to UV, etc., etc. So long-term aspects possibility with Search Ferrari offer. Mesh fabric, I'm highlighting here only the mesh fabric here. We have a PTFE mesh, 21% openness, 52% openness PTFE material, and then we have 10% openness possibilities as per there. And in PVC PVDF, we have 30% openness material product. Both the products what we have for is 30% openness. Then STFE, which is a clear, transparent material, which is a solid membrane. It's not a mesh fabric. Beside that, Search Ferrari Group, support architects and our customers with design engineering support. So we have an in-house design engineer who can help to develop the projects in terms of rendering, design model, GS drawing, and connection details. So Search Ferrari Group offers this service to all stakeholders in the membrane industry. Beside that, you need a system. If you are using an external facade, you need a system to support. So if I sell the fabric or if I promote the fabric, some solution has been given. So we have tied up with a UK company called FTI. Okay, they provide very good systems. Okay, suitable for standard panels or 3D designs. We can have the possibility of a system with 4 square meter in one panel, up to 60 square meter in one panel. There are possibilities of new system called Solar Skin, which can be a 15 meter by 15 meter panel possibility there with Solar Skin. Okay, and all tested system with our fabric, wind resistance up to 250 km/h, and it's a very cost-effective solution because it's an aluminum, very lightweight, cost-effective, and you can really change the aspects of your building with this system and the fabric together. We have EPD declaration, certifications. It's a Green Guard certified products. All the products supplied by Search Ferrari is Green Guard certified. And LEED, we have, you will get LEED points when you use our membrane on certain aspects. Some of the highlight key projects, just to show possibilities of different dimensional projects in this. These are hotel projects across the world we have selected. Offices. You can see each product is different from its own, printed or lighting or three-dimensional geometry shape. The whole, you can see the fourth picture from the right. It's a completely building is wrapped with a fabric. Culture centers, education. We have done PSG college in Coimbatore, done by our Chennai customer, Duo Engineering. And then we have a kids university, the first project from the left. This is completely wrapped with fabric, solid and mesh together. Sports centers, possibilities. Stadiums, all the FIFA stadium in 2022 Qatar, 5 stadiums was done by Search Ferrari Group fabric membrane. Car park, possible multi-story car park. You have a lot of multi-story car parks, but it's not enclosed, so we have the possibility to use as a mesh membrane for such car parks. We are present across the world. We have representative offices and factories across, factories in Europe and across the world, globe, we have, representative offices. Yes, I'm on time. So thank you very much. So I hope, this membrane, it's not new, but still it's new for many people across the industry. We are really happy to, support you. We have a booth outside, and our customers are also here. John from Texas, who is also a good supporter and into facade, and Rajarajan from Duo Engineering. So all these possibilities are there, based in Chennai, and our representative, Mr. Kannadasan, is also based in Chennai. So please come back to us if you have any opportunities for project discussion. Thank you very much.
Thank you, Arun sir, for that presentation on fabric materials available in the market today. Now, ladies and gentlemen, we'll be taking a short break of 20 minutes. Welcome back, ladies and gentlemen. Hope that caffeine will help you through to get us through the lunch break now. Our next presenter, Mr. Gregory Romine, he's from Managing Director of Avante Façades, and he'll be delivering on inspiring facade materials. Gregory, stage is yours. Thank you.
Thank you. Good morning. So it's really wonderful to be back in India. This is the longest I've been away from India in 20 years. So through the pandemic and things, it's really great to be back. I see a lot of familiar faces, but it's been a few years and some of us have changed. Some of us use old photographs like mine. So Axis Façades, now Avante Façades, is really a material-focused consultancy for facade design. So part of that regimen and why it's important for this talk is that we maintain a research center, research and development center, which is to support the research and development of new facades and materials for our client base. So a lot of the things we'll talk about today are a result of that research center. So inspired facade materiality. One of the things that when I was putting together this presentation is there was a lot, I threw out a lot of flowery words, and really what it comes down to is courage. And that is, do we as design professionals, architects, consultants, contractors, and developers and building owners, do we have the courage to reach beyond the typical mundane material and work towards introducing something that will change a skyline for the better? So it is courage. You can call it whatever you want, but at the end of the day, it's courage. So let me touch on some innovative materials that we've been involved in developing along with manufacturers. But we do research and development, and then we turn over information to credible manufacturers that can execute the projects for the clients. So first material I'd like to discuss is FRP, fiber reinforced polymer. So it's a much aligned material because it's a plastic, and so it's a little reticent, but of course if you look at a Lamborghini, you pay a lot of money for plastic, you know, carbon fiber and composites. So what we've done is through research and development, and now we've passed this on to manufacturers for specific projects, is creating FRP in a metallic surface. So this is cold cast bronze on FRP. So the size limitation is exciting for architects, because when we tell an architect they can have an FRP metal panel that is 9 foot by 52 feet, they get excited. And that is the only constraint about the 5 foot by 52 foot is that's a larger shipping container that we can get, which is 9'6" tall by 53 feet long. So that's the only constraint essentially, and with cold cast metal. So this is with copper, and this is actual metal that is suspended in a polymer cast, and then the FRP is cast behind. Zinc. So we talk about zinc panels and the fact that they are typically in sheet metal. So this eliminates that idea, and also curved linear shapes are quite easy to accomplish. So this is a translucent bronze in regular ambient light, and then this is with backlit. So you can imagine the opportunity for, like, for example, large landscape elements, where you want a large lit element that's very subtle. So it's bronze during the day and then it glows at night. This is a translucent material where the architect wanted bubbles. So this was not a mistake, this was on purpose. And so we developed a method of injecting air into the material. This is a prototype project for Airbnb. And so it's cast, they wanted it to be extremely lightweight. So it's FRP with all the window cowlings and doors are all one piece, so you don't have joints. and it's a rain screen and a special texture finish. This is a project where it was cold cast FRP. Originally, the client wanted bronze. So this is a 43,000 square foot house, and it has about 10,000 square feet of fascia. And the bronze, as you can imagine, was quite expensive. It was just short of $3 million for the bronze. So we recommended to the owner that they use FRP with cold cast metal. So that's cold cast bronze. And as you can see, it's a very symmetrical with the corner panels being one shape, so the inside, outside corner panels. And the magic with the bronze is that you have to have with any metal, is you have to have a texture in order to burnish it. But it's especially in non-contact areas, it's a great solution and a great value. So polished GFRC, so our research center spent 2 years developing this material for our client. Ultimately, it was used in 15 Apple stores, including the Dubai flagship store. So the benefit is that it's polished, so it has quite a beautiful luster to it. And we designed and engineered not only the material itself, but the fixing system, and even the method by which they would set the material, because some of the panels are 24 foot tall and 8 feet wide. So, and then because it's a Norman Foster project, the project team wanted all 3mm inch joints. So you can imagine with cast GFRC, that's not an easy thing to do. And this is a cast in handrail. So you can see that travels all the way down the stairs and wraps around the corner. So we designed and engineered sacrificial molds and lineal molds. This is a public furnishing, so sometimes, yes, we're a facade consultant, but sometimes we get drawn into, as I'm sure most of you get drawn into other parts of projects. So in this case, they wanted us to design and engineer and develop a composite for these very artistic curved benches and tables. Oftentimes, because we want the client, the ownership, to understand what it really looks like, is that we put together mock-up galleries. We specify mock-up galleries, and then we use that as a standard of practice for projects. So this is a mock-up gallery in one of 2 fabrication facilities for the polished GFRC. So this is polished GFRC. This is, let's see if I can. This is the polishing line, which is a 200-foot long polishing line. We actually developed the technology for the fabricator to do that. So this is the polishing line that I was referring to. So point to point, so the material's placed on the conveyor belt, and the computer takes care of it, and the next morning they're polished. And you can see how we formed, we specified the forming for the handrail. And then we also specified that it'll all be dry fit to make sure when it goes to the site, we get the 1/8 inch joints. So another unique material, and we've been developing this process for architects for over 20 years, and that is to impose errant and very organic shapes into cast metal. So this is what we call platen cast, and what happens is when you see the material, we want you to see the movement of the material, and architects have embraced this as a really organic and tactile material that they can use as accents or complete walls. This is a white bronze. We're just doing the consulting on a white bronze project in Europe right now. So this is an example of what it looks like in a building. This is a project in Australia. So you can see these are cowlings that are all one assembly, that are done in the factory. And then these are quite large curved panels that are 4 meters by 1.5 meters. This is flat. So you can see the texture. So it's a very organic material, and then it has a patina, and it's relevant to the site because it's close to a very famous statue, and they wanted the facade to match the statue. This gives you an idea of these are, this is the window cowling, one of the ones that on the project. It also looks like a sculpture, I would think. And then you can see how large these panels and the texture involved. Cast aluminum also has the same character. The difference is cast aluminum needs to be finished. It needs to have a coating because it doesn't wear the same as bronze. It develops an oxide pattern which is not as desirable as a bronze material. So the technology is not new, but the way that we manage the technology and the way we specify it, it helps the fabricator understand what the architect wants and how we suggest the methodology to get there. So this is pretty typical sand cast, but then we make it more applicable to architecture, so it's allodyne. In this case, it's covered with a polymer bronze, and then it's burnished, so it reads as bronze. So this is, the irony of this project is this is a project in Newbury Street in Boston, and when the architect approached us, they said this was an Art Deco building in the 1930s, and the owner thought he wanted a modern building, so they took down all of the bronze panels and scrapped them and made it a modern building. When Newbury Street became a prominent street, they wanted it to go back to an Art Deco building. We budgeted for, during the facade design, we budgeted the bronze, and the bronze was 3 times as much as the cast aluminum. So again, you don't know it, you wouldn't know it from the street level, that it's not actual solid bronze. So one of the things that we've been working on with fabricators and clients have liked the idea is to use plate zinc instead of the typical brine zinc, VM zinc sheet material, which it's great, but it has some characteristics that can be desirable or can be less than desirable. So what we've done is we've talked with architects and come up with some ways where they can use plate zinc. So this is an example. This happens to be 3 millimeter, but we've designed up to 13 millimeter. So this is an example of a large zinc plate material. This happens to be a sunshade, and this was in our research center. And so to demonstrate that it was possible. So this was a trial mock-up R&D for a project. And this is nominally about 16 feet by 16 feet. So going on, so porcelain enamel, of course, porcelain enamel metal's been around for a long time. But what we've tried to do is encourage architects to use it by doing something different with it. So this is a shark skin pattern where actually in the lab we overbaked the prototype, and so it fractured. So it was a mistake. It was a mistake that we tested, and then we told the manufacturer, okay, now it's a new product because it works great. It's quite beautiful, and it has somewhat the cracked lacquer look, Asian kind of style of finish. Digital ceramics are now playing a big part in porcelain enamel. So we can do cladding and we can do permanent graphics and things that are highly durable, last over 50 years, won't fade or chalk in digital ceramics on the porcelain enamel metal. Iridescent, so we've now figured out, along with manufacturing, to do iridescence so the building can change color depending on the angle of viewing. And then metalescent coatings, we pushed manufacturers to develop metalescent coatings where this coating will look the same in 50 years, unlike a PVDF Kynar, which is going to start chalking and fading, well, essentially immediately, but it will degrade over time and has usually a 20-year life, where this material is 50 years plus. And again, we can do interesting shapes with the porcelain enamel. One of the things in India, because of the ultraviolet degradation of materials, is the vivid colors tend to chalk and fade quite quickly. So in porcelain enamel, highly pigmented colors help architects keep that vivid color. And again, the durability, we get drawn into different parts of projects, but in this case, public furnishings where it's super durable. Again, more public furnishings. So one of the things that because we do a lot of projects, we're in over 20 countries, and a lot of the projects are in developing countries that have very high particulates and suspended particulates in the air, so they soil the facades. So we worked with industry leaders to come up with a ceramic composite coating. So this is a Uniglow store in Shanghai. I lived there for 7 years, and the air is really rough, and it's a lot of floating particles. So when we worked with the architect BCJ, we developed the facade, and then we recommended this coating. So the facade actually rinses itself quite easily. It's a very slippery finish. So it has a very low coefficient of friction, and when the rain hits it, it just washes off the material. Of course, it still needs to be washed, but not as often. So it's quite brave of the architect to put a white facade, a pure white facade, in the middle of one of the dirtiest air cities in the world, but the building looks great. So another challenge that we've had with architects, and it applies to the Indian market, a lot of times the metal material will be very hot to the touch if it's in direct sunlight. So we work with manufacturers to develop a sensory ceramic coating. So this is before we put the finish coat. This happens to be benches for a large project. And what happens is the sensory coating then mitigates the thermal transmission of the heat from the metal to the touch. And our goal was to reduce the temperature by 40 degrees. So we were able to get to 40 degrees. So if, let's say the material is 140 degrees at touch, we were able to get it to 100 degrees. If someone touches at 140 degrees, it's going to be hot. It's going to be uncomfortable, severely uncomfortable. So this coating goes on the areas that are within touch. There's another project in the Middle East where there are jalis that are within touch, and that material is being used to coat those as well. And so this is the bench. They were just assembling them on this project, and these go throughout this shopping center. I think there are 20 of them. And so the seat surface, which is this area here, is coated underneath the final coat with this sensory coating. So cork's been around a long time, but I think we've all forgotten that it's actually can be quite a nice cladding material. So this is the inside of the cork where it's up against the tree trunk, but it's actually very weatherproof and very durable for exterior applications. So it can be panelized, attached to aluminum substrate, and then a hanger system, typical rain screen. And then this, of course, is the outside bark, which, same thing, can be attached. This is all what we recommend is Portuguese oak. Billet cast glass is just an interesting kind of, people ask us, architects ask us every once in a while if they can use it, and we have a lot of experience with the material, so it's a feature wall type of material. Same with 3D glass, where we have manufacturers install in the inner layer, in a liquid inner layer, the 3D metal. This is an example. One of our clients wanted these for a large flooring area. So these are all molten cast glass. This is kind of what it looks like going into the mold. Okay, that's what we know today. Thank you.
Thank you, Greg, for that presentation on facade materials available today in the market. And our next presentation will be by our presenting partner, Shuko India. I welcome on board Dr. Omkar Ji, Innovation Manager, Shuko, Mr. Kushagra Awasthi, Head of Engineering, Shuko, and Pratik Joshi Ji, National Manager, Facade, Shuko India. Welcome on board.
So, very good morning, no, very good afternoon to all of you. I am Omkar Powar. I take care of innovation activities for Shuko, pertaining to the region of Asia, Oceania, and the Americas. So today I am going to discuss with you all what are the mega trends, especially the mega trends which are pushing the boundaries of our construction industry and pushing us as a product developing company to innovate for these particular things. And I would try to focus on how Shuko we strive to design for all these new mega trends. Any innovation starts with an imagination. So I would like you all to imagine with me. Let's say we have come to a new city. Say Chennai. We have come to a Chennai. What do you see? First thing you will see is vast expanse of population, right? And the next is the concrete jungle to accommodate this vast expanse of population. So this is the most well-known first mega trend, that is the urbanization and high-rise buildings. So I would like to point out that for Shuko, mega trend is the trend which is going to connect to all or each one of you. So that's why I'm trying to ask you to imagine and come with me on to this imagination journey. So this is the first mega trend. So you have reached a city, and you saw that it is urbanization is the first mega trend. Today, around 40% of the energy is being consumed by our building construction industry. And this trend or expanding in this type of fashion is not possible, or the better word is not sustainable. This brings us to the next trend, which is a necessity-driven trend, is sustainability. Okay? So still in the imagination realm, I will ask you to join me with this thought of sustainability. Let us walk towards the hotel. We have come to a city, so we are walking towards our hotel. Soon you will realize that the global warming aspect is so real because of the sweatiness. When you are walking, you will feel that sweat and feel that thing. So, and it's not only limited to the temperature rise. It's about uncertainties of the rainfall, increase in the intensity of the cyclones. So all this is happening, which is driving to the thing of climate crisis, and all our products are to be designed for this particular trend. Needs all the specification, because the water tightness, air tightness has to be designed for this particular new changes imposed by this mega trend. So that is the third mega trend. Finally, you reach your hotel. What do you see? You are mesmerized by the sheer shape or form of the hotel building, like our Sergei Ferrari showed, the boat facing the sea. So that is nothing but the trend of from the architectural domain, which is the free form and the bionic design. And finally, when you go inside the hotel, your wristband will tell you, yeah, you have taken 100 steps or 1,000 steps, 10,000 steps, whatever, for the day. That is the real-time data. and AI for you. So that are the 5 major mega trends which are there currently pushing the boundaries, and Shuko is contributing or striving to contribute in each of them. We are trying to work in each of these mega trends. Today I will be talking about the sustainability aspect or sustainability megatrend. Now this is another challenge. Sustainability is a very hard nail to drive on. One can say sustainability is what happens to the material at the end of the particular use of its life cycle. Someone can come and argue about sustainability is the material which consumes less energy or emits less carbon. So it's very perception based. At Shuko, we believe the best tool available is the life cycle assessment tool. So here what all the stages of the life are being considered, are being evaluated. And literature has already established the stages of a particular product, like into stage A to stage D, there are 4 stages. Stage A constitutes from the mining part, from the product mining process, till it is being installed into the site, building construction site. All the emissions or all the energy consumption happens in this is clubbed as stage A, followed by the stage B. Followed by the stage B, which is operational based, which is mostly worked on. We had many passive concepts in the early morning stages, so that mostly contributes towards the stage E, where the operational efficiency comes into picture. Stage C is the part or the phase of the product where it is being deconstructed so that it can be further reused in stage D. So these are the established stages of a particular product in the literature available. There are also certain terminologies which are used in industry related to LCA, like cradle to gate or cradle to grave. But for us, we believe that the most important or most which engulfs all the aspect of this as a whole is the cradle to cradle approach, and that's what we at a Shuko strive to take an extra mile. We try to bring is the stage D also in our picture. So this holistic way, we try to design our products from the perspective of cradle to cradle approach. So now what to be done to how to be done. So at we have the philosophy of Shuko Carbon Control, which is recently launched at BAU in Germany. And here we have segregated, or we have devised our philosophy into 4 modules, where first module deals with the stage A part, which I explained earlier, where we intend to provide our partners and enable them in the stage of design itself, not start of the product, but at the start from when you take your pen and start sketching your sketch on the sketchbook. So at this stage, we intend to provide all the information pertaining to sustainability at their fingertips, like anodizing takes 10 times more carbon than your powder coating. So all this kind of stuff will be available at your fingertips from our in-house tool, which will be available. The second module takes care of the stage A and stage D, which is about recycling. So on this front or this module, we work on the solutions like providing low carbon or ultra low carbon on aluminum, which are kind of advanced or latest versions of recycled aluminum. That solution to the solutions like hybrid structure, which I will be discussing more on my upcoming slides. So that kind of things, plus packaging management, which is the systems which are more pertaining from the sustainability aspect, how the packaging can be done. So that comes in second module, build to decarb. The third module is operate to decarb. Here we try to cover onto the stage B, which I mentioned earlier. The operational efficiency to increase our products, try to increase the operational efficiency in this particular module. We have the products like smart and automatic will increase the nighttime cooling, provide nighttime cooling, or integrated sun shading devices. So all that comes into the module and onto operate to decarb. And lastly, but the most important module is recycle to decarb, which is as I explained, the stage C and stage D. We are trying to correlate here how we can bring in the futuristic idea of urban mining. For that, we need the data to be known where that particular material is, what stage it is. So our IOF tag, which is Internet of Facades, will be playing a crucial role in this particular aspects. So this is how Shuko tends to work on the holistic approach and not only one particular globe from the perspective of sustainability. So today I will be focusing, as I said, on to the hybrid structures, what are the innovative solutions on this hybrid structure side. And what a better material than wood when we say hybrid. Okay? So when we compare wood with all the building construction material, it is the only building construction material which has negative embodied carbon. Basically, during the process of photosynthesis, it entraps the carbon, holds in it for its entire design life out of the cycle which is going to be there. So this is because of the sequestration process which takes place during the wood. So, and it gives a unique advantage for wood than any other building material. Now the question comes, after the carbon, can it be engineered that to take the loads or for performing? So any building, any material starts its phase from being used as a aesthetic material for aesthetic purpose. It starts walking, then jogs to become a secondary load-bearing structure, and then finally starts becoming a primary load-bearing structure. So what is the stage of wood currently? The various latest developments which are there onto the CLT or glue lamp type of the woods which are there are already started running. They are already being used as a primary load-bearing structures. And these latest versions of wood bring along with the additional benefits like CO2 entrapping, which I said, they are recyclable, they are light, reduce the weight of the structure. So all that has been brought along with the structural capability. Wood basically, due to its original cellular structure, has the property of being anisotropic material, taking the load more prominently in one direction. But these new glue lamp and CLT are being designed in such a way that they can be taking multi-axial loads as well. So examples are bespoke design like this industrial structure. It's not that somewhere in some one-story or residential building is being used. The wood is CLTs are being used in the industrial complicated structures. This is one of the example in Frankfurt. This is a Schuko project, which has the timber as the primary structure. Here you can see that almost 40% of the material capacity was brought down and 80% of the CO2 was reduced. So this is the impact. This is another example. This is a landmark 20-story tall building, 80 meters high. This is the inside or the interior part of that particular building. We can see a part here, not only primary structure, but the secondary structures like handrails are also being made up of wood. So now, why I am driving this, it went into a turn where it becomes primary structure. Why I am saying this? I am driving it to say that it's not far from when the architects will want the timber to come into facades. And Schuko has sensed this requirement, driven by the mega trend of sustainability. And hence we have the product of AOC 50 Ti, where we can accommodate efficiently the facade wood or timber into facade. It can have the face widths of 50, 60, and 70 mm, can provide you variety by giving you glass thicknesses from 6 to 70 mm range, can carry the weight of glass up to 1,100 kgs, so that much of weight can be taken. So this is what we have sensed. There is a need from the market and we have designed for it. These are the products, how we come up with the innovative products. So to wrap up, these are the mega trends which are there, we discussed them, and Schuko is trying to contribute in each of these mega trends, and we are striving for that. And now I hand over to Mr. Kushagra, my colleague, who will talk more on to the free from and bionic design. Thank you.
Thank you, Omkar. My name is Kushagra Awasthi, and I represent the engineering division of Shuko India. Omkar explained the megatrends, what we are seeing right now. I will be focusing more on the freeform and bionic design. He spoke about the sustainability aspect. We will see how this freeform and bionic design is affecting our industry. And Shuko is at the forefront of innovating these megatrends, as rightly said by Omkar. So what we are doing, we will see from the architect's perspective first, how these designs are coming into reality. So for the past 40 years, we have seen that architects use basically the drafting tools, initial drafting tools, and they mostly had to go back to the drawing board to create any idea or any design. And then it was very tedious for them to do any change, right? Because the actual experiment was done on the site. The materials were experimented on the site, the designs were experimented on the site. So there was no chance of them to change anything because the process itself was so tedious that they had to go back to the drawing board to change anything, right? And then comes the evolution of computers, and then we got to know about different kinds of geometric forms, right? And these geometric forms have gained a certain design trends in these days. So we see buildings where a basic floor plan is just extruded. So this is a trend now that most of the buildings that you see will be, just extruded with the same kind of a floor plan. It goes up, right? And then we have buildings where the floor plan remains the same, but it is, rotated or tapered up, having some different change in the floor plan and then goes up. Or maybe reduce the size of the floor plan and then goes up. Then we have this twister or tordos kind where the entire building is twisting, right? So this is the trend that we are seeing right now. And then the last form is the free form, right? Where there is a design principle here also, but the creativity level is so high that anything and everything is possible. So in general, the architects, what they prefer to do is use certain tools and experiment with them. And when they are experimenting, they are visualizing also. They are creating some experiments which is practically not possible, maybe. So they do some analysis, and then they go back to the design, and then they rework if anything is required to change. The next aspect I would like to show is the modularity which is happening in the current architectural world. So this is a parametric tower exploration by Nor Nicholas, where the generic principle was to have a certain module, and then these modules, they populate themselves, right, in certain spaces to utilize the spaces better. So this is what is happening right now, right? So this computational in architecture is actually driving unique designs these days. And that's Market City Tower in Toronto. And this is what these architects are challenging us, the engineers, to implement these designs. One question is how actually they are doing it. So if you see, architects also, they have become like programmers, right? So Python is one language, C#, C++ are the other languages where architects are mostly using and becoming more like coders to use the computational power better. There are Grasshopper scripts also, where you get to see they do different kinds of modulation. They play with the design, they play with the fluidity, they play with the spaces inside, and then they try to optimize, right? So this is what is happening for the past 6 to 7 years, I would say, and this is happening all over the world, right? And this is the future, which is under, it's building. So the AI is also helping the architects in visualizing the different forms, the free forms, and the fluidity is increasing even more. So we at Shuko, we also realized this, and we saw that there has to be some way to incorporate these designs into reality, right? So we have a product called G2S, which is I mean, you can call it a skylight or you can call it a facade. It's a free-form, geodesic design, G2S, that's the product name, that allows us to achieve any shape that you can imagine, right? And it's self-sustained. You don't need a subframing or you don't need a steel system behind it to support. It's a free-form, computationally developed. Of course, we also are using the same kind of tools like Grasshopper scripts, and we also have to go back to Rhino to design it. And there are other structural analysis that we have to do in order to have this self-sustained geodesic design structures, right? So this is on the inside, so you can see any shape is possible here. And we can discuss more about this on the outside. So this complexity, what we are talking about, is already reaching Indian shores. So this is one of the building which is already executed in Ahmedabad. It's IPL, Indian Potash Limited office. So here the complexity was the different angles, and that has to be integrated with the facade system. Then we have this another example, Hilton Kathmandu. This is a hotel that we did. Here the challenge was double convex facade. It's a double convex facade where the concavity and convexivity has to be addressed with the same profile system. So it was really challenging for us to optimize this kind of a design and still have that fluidic structure. This is one of the projects which we are under discussion with the L&T team, which is right here, which is the New Delhi railway station, upcoming New Delhi railway station. Here it's a geodesic dome. So there are two geodesic dome which is converging onto two eccentric points. So these are the challenges that we are facing right now. So I mean, whatever the architects are visualizing, we are helping them to realize the same with our designs. So architects have the computational horsepower, you saw, to innovate for these megatrends. What we as engineers doing, right? So we here at Shuko, we see the complexity from a different perspective, right? It's not that things are complex, we need to just think about the complexity first. So we, basically what we do is we break down the complexity, or we decode them into smaller subsystems. So there are structural systems that we need to address, there are thermal systems that we need to address, there is a glazing system we need to address, there is drainage system we need to address, and so on, right? The whole thing is decoded or broken down into subsystems, and then we basically attack those systems. So just to give an example, this is a basic optimization method that we use for any project to start off with. So we start off with, say, what like the floor-to-floor height has to be known, and we have a target aluminum costing, because every project has a different costing, right? So we have to optimize the cost. Then we go into the stack height definition. So stack height, when I say, is basically the distance between the fulcrum of the bracket to the fulcrum of the stack. So that's the stack height. So we need to optimize that. So we see that there are different stack heights that is available, and we go and optimize the right stack height for that particular project. However, I mean, this is most of the time predefined by the consultant or from the architect side. But we still, when we are optimizing, we have to optimize right from there. And then we have a huge range of profile systems where we get into element analysis and see which part of the profile system needs what kind of thickness, right? So that level of optimization we go into when we are supporting any project. This was just to give an example, like the same Hilton Kathmandu which I was referring. So the concavity and convexivity with the same profile system we had to develop, and each and every part, each and every note, each and every element was designed to perfection, so that the stress values are within the limit, the deflection is within the limit, and we get the desired output and the desired aesthetics from the profile system. The other complex part is the drainage. So I am just taking two examples to show what systems and how we work into. So you see there is an inclined facade. There is an inclined facade. So it's a 6-degree incline. Since it is inclined, so there has to be a proper drainage system. So in order to provide so, we develop different gaskets, right? These gaskets are in turn inclined by 2 degrees so that there is a slope and the water goes out. Then we solve all the complex geometries of drainage, using modeling, and we visualize and see how the water is flowing. We need to have this controlled flow of water. That is why this is, again, like a subsystem which is focused depending on the complexity of the project. And then in the end, what we do is when we have worked on different subsystems, then we completely integrate into one. We also help, architects and the consultant visualize like how actually it will turn up. So we help them with all the possible solutions first, and then we help them to realize, like visualize, so that this is how actually it is going to look. So this is a couple of examples that we have already used and done and implemented also. So that was just to give you a brief on how we at Shuko are attending the freeform and bionic design. My colleague, Pratik, will now take over and will explain about what we have executed in these freeform and bionic design. Sorry, it's 30 seconds left, but unfortunately I had to.
I always have to finish in a minute. So thank you, Kushagra, thank you, Omkar. So as my colleague Omkar explained about the innovation, Kushagra explained about the engineering in the complexities. I am here to present you just a case study out of most of the projects. So I am Pratik Doshi. I am responsible for facade business in Shuko, India. So I'll directly get on to the project. Okay. Okay. So while we have a lot of complex projects solved around India, I have picked a project which is a bit different and is a kind of a technology which a lot of people have, but is not in use. The project is Surana 101. This project is at Surat, and the kind of a building was a textile market office. And the challenge is how we solved is the building had glass, Korean, and glass fins. The problem was that this is a textile building. That in a textile building, you have a big floor height, an attic where the people, the stitching and cutting goes on the top and the attic, and then you have a sales office at the bottom. So for the facade line is actually on the chhajja. It's not on the floor line, so it's farther. So the builder also wanted something a white and a blue look always, a white Korean, blue glass, and linings of blue. So we had to solve something. They wanted a capped look on the facade. They wanted the white lines. The easiest thing for us was supposed to give a capped unitized facade, but they wanted a groove as well. So we say innovation is something like thinking what's coming, thinking what's around the corner, taking the best ideas and putting them in practice. So what we did was, the kind of look the customer expected was this kind of a unitized facade. This is a project from Europe, where you have a unitized facade and it has a cap, it has a groove. So we had the product. On the left side, if you see, there is a product which is giving you a capped unitized look. It doesn't have a silicon bonding required. It doesn't require any bonding with silicon. It is like glazing bead holding the facade completely. On the right side, you see a glazed male-female facade. So to reduce the price as well and to give the best solution which the fabricators can execute, we came up with a solution, and this was developed by our engineering team. We came up with a solution, a male-female facade, doesn't require silicon. The glass is mechanically, holding by the glazing bead itself. So this was a 3D rendered image on the left side. On the right side, you see the actual project completed. And the second challenge was to give a side hung window, giving you a kind of a glazed look from the outside. That also was solved. The side hung was also where the side hung window was too far from the floor line, so we had to give an inside side hung and also giving a glazed look on the outside. This is how you see a typical unit of the floor, that you have an attic, and on the right side you see a side hung, the facade, the kind of look of the glazing bead, and the fins are installed by the fabricator. These are few references in Chennai which are already done, and we are looking forward for more. As we showed the process, like how the innovation, complexities, and implementation on the ground is handled. We have our stall outside. You all can see the samples and get back to us if we can be of help. Thank you so much. Thank you. Thank you. Yeah. Sorry.
Thank you, Shuko. I think they equal sustainable innovation very clearly. Next on stage is Ravindra Kumar ji, Director Head Design VA Group and Principal PRA Group, who will be speaking of future of facades. Welcome on board, sir. A round of applause, please. Thank you.
Good afternoon, ladies and gentlemen. I think as most architects, we want to bring in a lot of innovation and avant-garde in the kind of work that we want to do and present what we want to do. And the world is a very changing space, a very changing, joyous planet. So it's very important for us to become more responsible, more conscious as to how we build and what we can do to the kind of architecture that we do. It's no more the aspect of how experiential architecture can be, or how a person would actually envisage and be in a space as a part of the building and then look at it as an inside-outside space or as a transition. It's becoming very, very recognizably sort of an idea of iconic presence. People want to make an expression of the building to become very loud, like Pablo Neruda told his girlfriend that I want to do to you what the wind does to the cherry trees. So it's that sort of a surge that we all want to kind of shake and do something spectacular in every little piece of land that we have. And in opposition, when you look at Aldo van Eyck, a very famous German architect, he says that a most beautiful house is when a passerby doesn't even notice it. You know, that it has to be so well merged with the landscape, with the genius loci of the land and the surroundings that you don't even look at what it happens to its own existence. And that's when it is beautiful. So we have a very dialectic kind of work. We are a spectacular group of around almost 240 architects. And we work together, and I lead design, and I'm presenting some of the projects which bring that conversation into perspective. Most architecture and sensibilities for us grows from the inside out. It is more the idea of material, or what is the idea of space, and what does the geometry of that experience envisage to bring about the kind of nature of reciprocation that we need to bring to a place. We do a lot of structures which are all timber. For example, this is a large resort, almost 125,000 square feet in Coorg, which is all completely made out of timber with no steel, no metal, no nails. Everything is carpentered, similar to CLT, but locally manufactured as CLT elements. And it's very important to draw. It's very important as architects or as also aluminum consultants, fabrication consultants or glazing consultants. I've worked with some of the most best consultants here in India, and I'm very, very fascinated to see some of the specialists who know how to draw, because that's when you can actually visualize and bring about the ideas and change. And architects actually is the most smallest occupation that we can ever imagine in the art of detailing and technology. We do great buildings, we do very tall buildings, we do very large edifices and complicated services, engineering structures. But if you look at, you know, a ship building, you know, a huge volume of a metal element just floats on water and it survives the test of time for hundreds of years. Or an aircraft. I mean, the kind of engineering and the detail that goes into making something like this is spectacular. It's not just about the architecture or the making of it or the services or the engineering aspects of it. So we must feel very, very humble and very austere in our position and our experience, both as aluminum fabricators and as part of the construction industry as an architect. So there are more technologies that we have not even visualized or understood or learned as parallels. You know, for example, today you see a lot of elements and structures and details come from, you know, the aerospace engineering. We learn from them and then we bring that element back into our work and architecture and structure. Like even the simplest concealed kind of a tower bolt comes from an aircraft. And it's been extensively used in aircrafts, and then we imbibe that and it becomes part of our hardware system. So therefore there's a lot of learning. So when you look at architecture, there are various methods and innovations that are happening around the world. But the aspect of the accurate idea of how do we make very large spans, or how do we reuse materials, how can we come up with new ideas becomes imperative and very, very important. I present a few case studies of projects that we have done and what are our experiences in doing something like that. This is a project which is in Bangalore, which we built for Wipro. It is a 4.5 million square feet, one facility where Wipro wanted to integrate all their offices in the city to come into one position and one place. So when we started working with the clients, and we realized that just after the structure, we wanted everything to be prefabricated, everything to be an assembly. You know, just 40% of the whole exterior wall. So the whole of the external skin, after the the main principal structure is completely assembled. Even the concrete panels, the glass elements, the catwalks to maintain these wall elements, the horizontal terracotta trellis that envisages the whole building, the concrete panels or the concrete columns which also act as external clads. So we could manage to actually reduce the glazing to almost as low as 32%, 31% on the upper floors and maximize it on the ground where we could see a lot of landscape and the surrounds as the perimeter. Everything was simulated in the sense, even the thermal equilibriums of the exterior and the interior in terms of what should be the daylight, what should be the access of the light quality. So the facade is no more just an aspect of an engineering of an idea or how the face of it should be or how the intensity of the trellis should be or how do I like as an architect for it to look more terracotta than it should be as a building. That does not become the primordial aspect of how the facade actually should find itself as an expression of the exterior. But what happens is all these analyses sort of read for us the aspect of each facade being completely different. If you look at the north facade, the east facade, the west, everything changes. And if you look at it, La Corbusier in a project, sorry, I don't know how to go back. In one of the projects in Paris, was very impressively presenting the same idea in the 70s and the 60s. And he was talking about how the window systems and the concrete wall panels can actually create the idea of less transmissibility to ensure that the building envelope is not extremely heated up. So these are some of the diagrams that go into making such an idea. Very complicated sections and analysis help us to read the aspect of what the external glass can be and what the facades can be and what is the amount of reflection and transmissibility that the building can experience in every facade of it, so that we create a success ratio for its thermal equilibrium and experience of the building itself from the inside. There are no blinds, it's maximized daylight, the windows can be open in good weather conditions, it is underfloor air conditioning, there are no ducts in the ceiling, all the services run in the floor, everything is ceiling express, and it's spectacular for us to see that it is salubrious and it experiences the kind of architecture that you would actually see in the tropical world as just normal time and space. Every drop of water is reused completely, and it becomes again, as a part of the sustainability agenda, very complete. It is also important that as architects or as fabricators, it's important to invest in this kind of technology, where you can analyze the building, you can analyze the envelopes, you can analyze the quality of daylight that you can allow, the kind of radiation that the building experiences, and what is its effect effectively onto the air conditioning systems. We could manage to reduce the whole air conditioning load by almost 33%, because we could use these advanced softwares to analyze the building. We, in fact, appointed specialists, parametric analysis specialists from Delhi, just to analyze the building so that we can do a peer review and re-verify the quality of the service engineering that we can incorporate. I'm just running too fast for us to understand, just to say that there is an example, there is a case study, and it is possible for us to do what we can do with this kind of an element and as a technology. And it doesn't have to not have art, it does not have to have the experience of texture, it can have the kind of landscape and the experience of the iconic nature of architecture that we all want, always to incorporate in the making of the building without having to do any compromises. Now, that is a very pure concrete terracotta, soil, earth, a very earth kind of an idea. When you jump off to another method of an experience where we had a client and we were working 60 test cell laboratories. This is for Cummins, where their locomotives and aeronautic engines are actually tested for 1 million cycles before they are mounted onto an engine. And that testing happens here in India. It only happens in 3 countries, Russia, India, and it also happens in Schenectady. So we were very happy to see that this possibility was happening out of Pune. So the client, John, he was quite an amazing guy. Recently, at the age of 71, he got married again. And he's super energy man, super energy man. And he would actually sit with me and ask me to draw with him. Not that he could draw, but he would ask me to draw. And he would actually want to work with me in my workshop to see what can be done. So this whole building is actually done with VS1 technology, and it is the largest secondary walling system that is existing on the planet. It also is recognized in the Guinness Book of World Record for the horizontal, external facade element. So there is almost a 1.8 meter to 2 meter gap between the first layer of the glass and the second layer of the glass. You can actually carefully see it, and it actually sits in landscape. Though some parcels of the building has a lot of glass for its reflectivity and transmissibility that we want to experience in the night space, but otherwise the whole building breathes. Literally, there are gaps, there are no sealant lines which block the wall, and the whole space between the primary glass and the secondary wall glass actually completely breathes. Therefore, all the offices and the general spaces, such as the dining area, there's a potential to actually open the windows and actually have fresh air that we can experience within the spaces of the building when required be, and can feel the temperature and the weather of the joy that even Pune gives you at times when in some parts of the year where you can actually feel better weather. These are the internal atrium spaces which actually again act as venturi effects for evacuation, the common office spaces in the lobby and the spaces of arrival, and how the building starts reverberating for a night space, and it becomes a very, very picturesque kind of a structure sitting in landscape as a very iconic element. So it is possible for us to even do with a lot of glass and elements of terracotta a very different nature of our architecture, using the same principles of ideas but completely changing the nature of making. We went into another project in Bombay, this is near Thane, where we decided to use very, very simple, austere kind of materials, such as simple as bricks and stretch metal elements. So this whole wall panel acts as a secondary walling element, again, primarily shading the primary glass. We don't have to do triple glass, we don't have to do double glass kind of technologies, always to try and see how the envelopes can work for a building, but it is possible to create another layer of shading element. And this is not new to India or not new to the world. People have done this from time immemorial. From the earlier ages, we have seen these possibilities of technology, but how do you incorporate in making this a success story into a building becomes another part of the experience. Now, when you look at this, this is a completely twisted brick, which is actually woven, just like the way you hem glass beads, or you make a necklace. So these are bricks where we burrowed through the central line of the brick and actually wove them together and created, this nature of an external skin. So what happens is that, the whole building at the proximity of the window is just hardly around 600, 700 mm space, but when it starts twisting on the perimeter, it becomes a spectacular, iconic assembly, and as a part of the experience, you start seeing that as a wall of the building, as an external skin of the building, and also it becomes a shading element, and it gives lesser amount of radiation to the inside of the building. Now, the same building, unfortunately, or fortunately, UPL wants to make it as an iconic symbol for their own fertilizer manufacturing facility, and is being built in 7 countries, replicas. This will be their corporate and lab facilities, and we are actually working with them in 7 different destinations to build similar kind of structure with just a little variation of the plant based on what they want. This is a project again in Pune, where huge amount of transparency, where you use a lot of glass. It's actually simple as a large glass pavilion. This is a G+2 structure. It's not a very tall structure, but we envisaged again 2 layers of glass separated from each other, and we started seeing that the trees and the landscape does not grow beyond the 2nd floor or the 1st floor line. So we started putting GKD mesh. There are very deep timber louvers, timber fins that actually provoke as shading devices from angular kind of incidence of light. Plus there is a parasol and there is a trellis form, and on the upper floor, where there's a lot of heat ingress, we decided to make the building very, very opaque with only 18% of glazing. So using this technology of sustainability and an idea of how we iterate the building, it is possible for us to demonstrate the facades can take a more responsible nature of architecture and expression. And the landscape here, we intended to make it very spectacular, very experiential. People feel at the ground floor and the 1st floor that they're sitting in a garden, even with this sense of transparency and working as part of the garden as an extended space for their office areas. There are fountains, and people tend to want to come outside. These are laboratories and their corporate functions and international marketing office for Lupin. So, but it is possible for you to create a facade idea, which grades itself into a making where people can experience the outside. The architecture becomes both inside-outside joyous, but at the same time be very, very accurate in its expression of responsibility. These are some of the lobby pictures and some of the drawings and sketches as how we progress in making this building, and some of the day shots and the water features. These are very thin water elements, again, using recycled water, and some of the iconic elements which form as part of the interiors, both as staircases and flying buttresses and elements as that in similarity. Now, and it's incidentally, when we finished the whole building, the principal has a huge collection of artwork, and he decided not to exhibit any of his artwork here, because he said the stairways and the lobby spaces themselves were so spectacular that he didn't want to distract anything with more art. So it becomes very sculptural as an interior expression of joy. So there's nothing that they wanted to exhibit as part of the interiors, because the way the material and the structure itself affords itself to present the making of that kind of an architecture. Here in this particular slide, you can see how there are 3 layers of shading elements that can perpetuate the nature of transparency and still create the shading. These are some of the labs and the experience of arrival. Now, these are architectural elements where there's a certain scale and there's a certain possibility. When we were working for speculative office space where the budgets were restricted, it's a real estate kind of a development. We don't know who the vendor will be. But the client was very impressed. I've been working with this client since 2002. And thank God I've not been fired as yet. This is 27 acres of land right in the heart of Bombay with all the competition and the best of the architects who know how to make super iconic buildings in Bombay. We were quite successful to impress the client, against even architects like RMJM, who are like 800 architects on the planet. And we won the competition in 2001. We started working with him in 2002, and we continue to work with him, and we are the only architects the developer likes to work with. And we have tried and again focused and presented to him the idea of terracotta. So these are various phases of building, and recently we finished this 4 million square feet right in the heart of Bombay near Gurgaon. Now, this again is now taken over by JP Morgan Chase as a one-shot purchase idea to the whole making of the architecture. And here we could impress the client to do 12% and 13% glazing. The extent of glass, but it's not that there is no technology or no possibilities of what people can do using a secondary walling element, such as terracotta wall panels. The whole thing is a shaded glass, shaded wall, which means to say there's a primary wall and there's a secondary wall. The secondary wall is primarily made of large terracotta panels which completely shade the external wall. And this gives us the potential to shade the heat ingress tremendously and allows us not to have the air conditioning systems as what we would generally envisage in an all-glass building. We could manage to reduce it by almost 40%. All the water that comes as waste from the building is recycled and becomes a huge water feature. The owner was so fascinated with the landscape and the courtyard that he decided not to get married at the Oberoi, but he got married in his own garden right next to the sewer water, which is recycled and reconditioned to become a great fountain space. So it is possible with an idea of such kind even in this part of the world. And how do we do that intentionally and exercise with specialist consultants? There are 16 consultants on board. For every vertical, we make sure that we analyze and evaluate the way we would bring about making the architecture and the change. So these are various diagrams which understands the nature of every facade, every element of skin, every element of what the exterior will be, what is the south wall, north wall, east wall. So each becomes a part of an idea of its making in different nature of its architecture and how the facade eventually presents itself to the exterior and its making and some of the pictures. We also pull back. These are the ground elements and the ground features of how the landscape responds to the building, and also a lot of elements in certain sort of urbanity that we added as part of the gathering potential that the building can have in its perimeter. And also we pulled back some of the old structures. These are, the old chiller plants, which actually his father is no more, who wanted it to be resurrected and kept as positions of memory. So it became a large restaurant, and we started creating the same idea of 3 parallel walls, how to shade these buildings also to bring it back into the nature of making and keeping it very, very tropical. Some of the lobby experiences and the outdoor spaces, indoor spaces, services spaces, and the whole building is completely has a secondary walling element. Now, using the technology of aluminum and fabrication, is it possible only to do an exterior idea? We were, commissioned to pull down a structure for Bajaj in Pune. This is almost 3.5 lakh square feet of an old shed. And when I was talking to the principal, I suggested to him that the basement structure, when we did an ND test, it's a large basement floor slab which used to be used for storing materials, and they used to make fabrication elements on top. We said the structure is absolutely spectacular and we should pull it back together. And he was quite surprised that we said that we should not destroy the building, but actually gouge the whole building from inside out and create the first innovation center where they were working with some collaborations with Italy to create a new car and a new electric auto rickshaw. So this is the space where the think tank works. And it is, we decided to use elements of, again, aluminum, perforated sheeting with fabrication elements and creating triple layer wall effect and create an architecture which is pretty iconic and experiential to make what we can do within a large volume of a static space. This is a huge volume, and it's all Again, radiant cooling, one of the first structures of radiant cooling that was done in Pune, super successful. There's only a fresh air pump that comes up and pops up here and there within the whole area. Otherwise, there's only 2.5 meters of that habituated volume, which is air conditioned. The rest of the top volume acts as a venturi effect and is vented out. So you actually feel that the whole architecture and the experience inside is like a tropical world. And it is possible for us to use technology of fabrication and prefab elements to make that to a space which is also an interior and does not have to be restricted to making of that idea to an exterior or a facade of the building. So there is a technology innovation that we can bring about for new ways of how we experience a building. Some of the buildings where we started looking at reconstruction work, where we use technology again back from your bone to see what can be done. This is a building which we are still under construction. You can see how the terraces and was actually ordained to look like a large shaded roof element throughout the perimeter of the building. The central part of the landscape is resurrected. It used to be a big shack and a mess. Even the client was interested to actually pull down the 120-year-old building, but we put it back together, and it's a great heritage space, and ASI has recognized this as a monument today. This is the Bowring Institute in the heart of Bangalore, and it's a great lounge, it's a great outdoor space. Again, now we did radiant cooling, we did floor air conditioning system, and we also added for increasing the accentuation of the AC, some of the DX units in the ceiling. All the walls have 75 mm gaps between what they are as principal and as the perimeter, and the joints and the wedge lines of it weeps the AC, and we also use embellished elements to articulate those particular junction lines and the interiors and exteriors. This is the lounge bar, and this is the common hall space where people enjoy the theater work. This is a large timber structure with brick, which forms a very large single element structure, which is like a show kitchen where every person can go and ask for the quality of spice and salt that they want and the food and be served. And as part of a fabrication element and industry, we hired an aluminum fabrication company to help us to erect this kind of a structure, which can actually be dismantled and re-erected within 2.5 days. This is an 18-meter large pentagon umbrella bar. And this is right now erected at one point, but the same thing can be dismantled, including the counter of the bar, including all the services elements of the bar can be dismantled. Everything is just assembled at the site and can be pulled back and put back together within 3 days. This was erected at one point as a position in the master plan. Hopefully it'll be in the same place, but as we are working on an 11-acre parcel, we don't know where it's going to move and how it's going to work. And again, I stress it's very important to manually draw, to think, to analyze and understand how you make these kind of structures, to see how they become eventually to the form that we would want. Some of our experience in terms of structure has taken to build timber. This is my own studio where we built a 5-floor structure, and we built it all out of timber, re-engineered wood from an old warehouse which was dismantled, re-engineered all the timber, used adhesives wherever required be. There's no nail, there's no hammering, there's no screw. And we used very, very thin, only 2.5 kgs per square feet amount of steel for tensegrity. It was very important because it was a tall structure. We didn't want it to fly off from the wind. So, and also it has a huge amphitheater on the roof. It has a capacity of 150, and it's an RCC slab, folded plate slab sitting on top of this structure on a timber steel element structure, and it is possible for us to demonstrate this kind of an experience. And one of the clients put a challenge to me in 1997 or 2002 as to whether I have done this for myself when I tell other people that we can build timber structures using re-engineered timber or old wood. And that's when it became a challenge, and I took 2 houses which was built pre-independence. This was built in 1942, 1941, and we pulled it back together, reinforced their foundations, and actually created an RCC beam and plonked this timber steel structure on top of it. And the joy is because it's timber, it's very lightweight, it's not concrete. So therefore, it could actually sustain the kind of strength of an old building, and we pulled back the old building back together as show spaces within the ground, and it still survives the test of time. Completely, we ripped off the plaster. This is a lift which has been used for the last 85 years. We put it back together to show how you can recycle. Even that horse is made out of driftwood. So it is a potential as how we can explore these possibilities to see reuse and recycle as a method of making. And we used fabrication elements, just how you do structural glazing system and elements of structural glazing technology. Similar kind of elements was included in the making of a timber steel element structure. The joints and the edge lines was detailed out exactly as how you would do a unitized system of glazing. It is possible. Another smaller project that we did for the Experience Center in Bangalore, HMG, where we actually used the blades of cutting steel, the blades which cutting stone. He's a HMG, he's a stone manufacturer, so he had a huge amount of scrap steel with his own yard. So when I was walking around his yard, I said, let's make a building out of it. And we actually used all his scrap steel to complete this 5-floor structure, which is his experience center, where he shows and presents his marble. This is right opposite Windsor Manor in Bangalore. All the external fins, they all look like sort of metal slivers, like knife edge, and they act as a shading device, as an element to shade the whole building facade. And it is possible to create an all-glass facade with one's own waste and create an idea which can be a bit iconic. Thank you.
Lovely work, man.
Super. Hi, nice presentation. Yeah, take it. Can I take this water bottle?
Thank you, Ravindra, for that presentation. Our next discussion will be a panel discussion, which will be happening on the status quo of high-rise buildings in Chennai. It's a personal one too, because in Chennai often we don't see many high-rises. So I'm glad this topic has been taken up today. And let's see what challenges are being discussed and going forward. So I may now welcome Mr. Shripal Munshi, Principal, Shripal Venkatan Architects, and our esteemed panelists on the deck, please. Sir, after you. Thank you. Round of applause, please, for our panelists. Thank you.
Please. Yeah.
So good morning to everyone and a warm welcome to the last part of our morning session, which I hope is going to be a very exciting debate on the status of high-rise in Chennai. We have today on the dais a very amazing, very accomplished, and a very distinguished guest list. And it is my humble privilege and pleasure to invite each one of them, colleagues and fellow creators in our beautiful industry of architecture. So first off, I would like to invite Amrit Ramanujam. Please come on the stage. Amrit is the CEO and MD of Ramcons. A big round of applause. Ramcons is one of the leading constructor developer companies. Amrit's eye for detailing is exemplary, and he inherits his father's legacy. He has very successfully, if I may say so, filled in a very tall pair of shoes. And he continues to do so. His quality control, his project management, and just the overall appreciation of what the design and the client team require is just really, really encouraging. And I'm hoping to see many more landmarks in our city. Next is Gokul Murli, who's heading the Chennai team for Edifice. Edifice is a very, very strong, very diverse company, design company with project typologies, and I think you just have to look up their website to see the range and the diversity of the projects that they've done. Great stuff. I think the vastness of the scope of work that they are doing is testament to the fact of our vibrant economy. And that's really something to be proud of. There's something to be, I think it's a way forward for many of our design professions.
Thank you.
Biju, partner from Architecture Red, multiple award-winning firm, Pratt Institute alumni, and fellow colleague and contributor to many design and many architecture-related functions and events. Biju Kuryakos, very, very gifted designer, very sensitive, very down-to-earth, and great sense of humor. So it's a pleasure to have you, Biju. K.R. Suresh does not need any introduction. Avante Façades, and we're lucky to have him on the panel here at a short notice. So I'm sure we're going to get some very insightful inputs from him on the various issues that we're going to briefly touch upon in today's. And the last panelist, I believe, is
Rohit.
Rohit Ravi from Appaswamy. Appaswamy does not need any introduction in Chennai. They've created some of the most amazing landmarks, beautiful compositions, beautiful additions, very sensitive, very responsible, and I would say it's one of the few companies that have, in a very short span of time, left a very indelible imprint and continue to do so in our metropolis. So a warm welcome to all of you again. Thank you for this. So without much delay, I'll dive straight into what we're going to be looking at. The cover page is a collection of various images. The extreme top left is a project called Serene in Thane, done by Edifice. The one on the right is a project in Trivandrum, done by Architecture Red, Biju's office. The one below is 38 in Banyan, another residential project, very different, very iconic, and very, I would say, climate responsive in Bangalore. The extreme right is one of our designs for a project for a super tall in Mumbai. It's an unbuilt work, but we are hoping the client will come around. And with that, I move on to the curtain raiser in terms of what we're going to be talking about. So this is India today, a living laboratory of extremes. You've got unending swathes of land which are slums. Every time I land in Mumbai or I land in Delhi or Jaipur or any of the other cities, and it's shocking, it's painful, but it's a hard fact, you see this horizontal sprawl. And then on the other hand, you've got towers like Imperial 3, I believe. It's 396 meters and soaring, designed by Gordon Gill and Adrian Smith. This is the third of the towers coming up in Mumbai. The best, comparable to the best in the world in terms of design, construction, execution, everything else. And it's navigating through the whole construction process and the bureaucracy, but I think it will see the light of day. Just as how a few years back I thought World 1 by IM Pay Corp Fried and Partners by Lodha was a pipe dream, and they just proved everyone wrong. And today it is a reality, and it has essentially rewritten the National Building Code for high rises. So things are possible, and things are very much happening today in India. So here's a quick, just a very, very cursory summary in terms of where we stand in India as far as the high rises are. 390 meters and pushing, Mumbai is leading with 3 towers straight away under construction or in the last stages of build out. 360 West is where the old passport office is by the Oberoi. Minerva is Lokhandwala, overlooking the race course, and there's a very, very quirky story about that. When they launched the project, there was a Lodha Bellissimo behind, and anyone who bought in Lodha Bellissimo thought they were getting the race course and the sea view till Minerva started building. So here's what you call collaborative agreement. And today, Minerva blocks all the bedrooms of Lodha Bellissimo, but both have crossed 300 meters and whatever else. I'm not sure if anyone here was involved in that, but this is my observation, being a Mumbaiker transplanted in Chennai. Delhi NCR, Supernova, Spira, 300 meters, Raheja Revanta, 190, Bangalore Presidential Tower and Mantri Pinnacles at 160, and SPR in Chennai is, I believe, going to be 161 meters. And this is the background in which I go to the next slide. This is the Lodha Park side. The image on the left is right from the 4-acre or 5-acre urban green oasis which they've crafted in the middle of Lower Parel, what was formerly the Milllands, which Charles Correa foresaw decades ago, this spurge of phenomenal building activity. And the images on the right are the IMP designed or the Pay Corp Fried designed towers, the World 1 towers. So, simple question, is this a bane or is this a boon? Because you're shooting up with incredible FARs, you're creating this space below to add amenities and to create an entire new lifestyle for a new generation, but at what cost? Here are some other images of private, personal vegetable gardens, 1 acre swimming pool with all kinds of different facilities so that you're completely spoiled in terms of what you want to do with leisure. And truly, these places are fetching rents of 1.5 lakhs per month for the smallest unit, or maybe even more, even though the maintenance cost for each of these apartments is upwards of 25,000 or 35,000 rupees per month. So we are not talking small money. Super tall residential, freedom or prison. This is from the 69th floor of a 79th floor building. Hermetically sealed, windows which function beautifully, but will allow exactly 2 inches of air. That's it, nothing more. And the dark band you see, those are louvers. Those are very intelligent louvers. When you flip a lever and you get high intensity winds coming in, and that's about the only thing. You cannot open anything more, obviously because of safety reasons, but you get air and light, you get light and you get the view of a lifetime. And is this the new lifestyle that we are aiming for? Is this the new lifestyle that we are aspiring for? These are the questions that I'm throwing open to the panelists. What high-rise also does is it opens up the road ahead for a new design language. And this is a project in Thane designed by Edifice. This is called Serene, and it's a cluster of towers with a very iconic architectural language, with also a very iconic planning, where the series of units are interlocked and stacked, and so they create a vertical crevice, which then starts functioning as community spaces, as green spaces, as light wells, and these are the very sort of, I would say, innovative design features that merge and create a new paradigm and a new prototype for residential high-rise. This is the view that you see as you drive in from the sea link, and this skyline keeps on changing. This is actually representative of the new India and the economy and the entire new resurgence in what I would say is an identity for the nation. The building on the extreme left is the 360 West by Oberoi Constructions. Next to that is also an Oberoi unit. Now, yes, make no mistake, these are super luxury, super expensive, 30 crore, 40 crore, or maybe even more per flat. But there are people. And then the 2 towers next to that are the Foster Designs Omkar. Omkar 1973 or something like that was called. Once upon a time, 25 stories or 20 stories was considered the tallest, and today that is just completely being dwarfed because just like you see a cross-section of a New York skyline and you see history in the making or history in front of you, this is what you see every time you drive down the sea link. You see the lower buildings and you see how we started in Mumbai, and now you see what's happening at the rear, and I'm sure someone's even planning something even much taller than that. These are studies that our office created for a location for a building in Prabhadevi. And wonder of wonders, the floor plans were already done, the building submission plans were done, and then the client comes to us and says, now elevate and come up with a new design and come up with something. We did that, and then they realized that the floor plans were not selling, so the entire plan had to be redone. But nevertheless, we've given them multiple options, and we are trying to take them to an entire new narrative. As one of the Shuko presenters spoke about, using technology, parametric designs, creating an entire new language of design and components which can be looked at. So these are some of the attempts that we've done. Form follows geometry, and form follows fluidity. And this is one of the design explorations that we've done for that same tower. Chennai and the south, a contextual response. SPR, 161 meters on the left, and Hiranandani, which was about 140 meters on the right. This is what we currently have, and I'm hoping and I'm sure that we'll be able to do something much better than that. The next series of slides is what Biju's office has done, architecture red, and some very sensitive, very beautiful, very balanced compositions. This is 38 in Banyan and Bangalore. Biju will share the story behind, I believe, the banyan tree, the existing tree, was one of the precursors to the design, and very interesting use of a fenestration system that addresses the both inside-outside threshold. So you've got a shelter from the sun, but you have the connectivity outside. You have the privacy if you want it, and it's not a very complicated, expensive detail. At the same time, it lends a very clear presence and identity to the building. This is an affordable housing by the lake. Again, the compositions was to create a low-cost, low-tech, but very effective and very striking housing urban nest, wonderfully staggered cantilevered forms. Hats off to the structural engineering team for even entertaining something like this. This is what this is a dream come true for every architect, to actually arrive at all this and not having to deal with rainwater pipes and what will happen when that collapses and where will be the ship deflection and the shear. This is poetry in motion. I would say poetry in frozen motion. More these things. Institutional School of Aeronautics here, life sciences. Again, what can be done in terms of bringing air, light, and still have a very, very clear identity to the building, making sure that the building works from outside to in as well as inside to out. School of Law. This is the Council of Architecture. This was an award-winning entry, I believe, and now it's going to go into the construction stage. It's going through the approval. And this is a commercial corporate office. Again, testing and displaying various strategies that can work, keeping in mind our climatic conditions, keeping in mind our lifestyle, keeping in mind our people preferences as Indians. And humor always helps. So on that note, I'm going to throw open the discussion, and the first question will be for Rohit sir. How do you see Chennai going high? And where do you think where do you think we stand in terms of making things happen, where we can cross the 160, 200 meter, and maybe even more?
Hi, good morning. It's great to be here. I think for us to reach those kind of heights, I think Chennai, we have this the issue of the airport being in the city. So half the city, we're not able to build above a certain height. And we also have the building code with the setbacks. So there are limitations in plot sizes. So I think, that's really curtailed us from really going vertical. However, in OMR, like you showed, we're able to go vertical. We're also doing a tower that's 135 meters because, and luckily we are just in between both runways. So, there are these rare opportunities where we have to get all the NOCs and the setback, we have the side shape to achieve all this. But definitely, I would say that this is welcome. Home buyers love the high-rise living. And even in our building, which is 40 stories, which is under construction, we've got great interest. We've sold all the higher floors. And so people are gravitating towards wanting a better view, wanting that lifestyle. And on average, most of the buildings that we do are 18 to 20 stories and very well accepted. For last 1.5, 2 decades, we've been doing a lot of that. So that's very well accepted. And I think the key for us to really make this a success, I think, is for all developers and architects to have a very strong vision to create a product with the customer in mind and to think about the customer experience. Because only if there are good experiences by people who have bought homes, they'll, I think it will be more advocated to the others who are looking to buy homes, and I think the concept will spread. So I think many people need to have the good experience for this really to pick up and go to the next level. And I think it's going pretty well, but I think we need to be more innovative and create better experiences because we're building these concrete jungles. We need to create roof gardens, amenities that are rich, that kind of embrace this high-rise living.
That's very insightful. I've been reading in various design forums that we are going to expand the Chennai metropolitan area into several thousand kilometers, and there's also a new airport in the making. Do you actually see the creation of these satellite areas with last mile connectivity, which can go vertical and offer an entirely new different lifestyle? And do you think there is enough room for a public-private partnership there?
Yeah, absolutely.
So that firms like yours, in line with the right kind of support and encouragement from the government, make that happen, because it has been done in the past in other parts of the country.
Absolutely, and I think to create a twin city concept may not be a bad idea. Chennai is 12 million people. It's 1.5 times Hong Kong. It's 1.5 times New York, and it's super dense. Our company, as a developer, we focus on building established areas because we focus on a certain ticket size, a certain premiumness in our developments. But I think going forward, right, with the shortage of land here, as long as the infrastructure is able to support a twin city and kind of make the two work together, maybe an airport in the center, maybe a high-speed rail, maybe the metro extending up to that. So we need a variety of these things to all fall in place, and it's going to be at least a 10, 15-year journey, but it has to start somewhere. And I think it's definitely a good solution for a city like Chennai, because 12 million people, and I think there's just not enough space for everybody.
You're absolutely right. Chennai is one of the few cities where you actually still see the horizon. You're not just looking at concrete jungle. You're not looking at avenues. And roads of congestions and whatever else. And you do see the vista. So moving on to the next thing, Amrit, how do you see the user comfort in these residential towers directly being affected by glazing and the kind and the location and the types of glazing? And what's your personal experience having built so many interesting buildings and of such high quality and detailing?
Good afternoon, everyone. So I think Chennai has a varied customer base, right? So we have different affordability levels. What we are seeing here, I would say, would be in the higher end of the spectrum. But glazing per se starts from your UPVC window, which is a 4x4 in a multi-storied apartment, probably towards the end of OMR, to phenomenal glazing solutions that developers like Rohit do with projects like Azure, where the entire wall is glazing. But it just boils down to what the end use is. You don't want a complete glass wall in your kitchen or in a space where you want to put your wardrobe. So I would say occupant comfort comes from utility, which varies from building to building. It also varies based on the neighborhood that's there. You don't, again, want an overdose of glazing when your neighbors are not great and them looking into you from a privacy angle. And also the maintainability of it. More the glazing, more the maintenance. So I would completely say it's dependent on end use and user profile, which varies building to building and location to location.
In the years that we started Skydeck and now, I mean, that's literally more than a decade, do you see a change in shift in the end users' preferences? Do you see an expansion of their mindset? Do you see the fact that they're more open to suggestions and new directions?
Absolutely.
And from the time that you've come back from the US and
Absolutely. So when we see phenomenal designs like this, I think every user aspires to have that in their home or their development. But then you have to get to numbers also. Suppose you have complicated glazing systems, it comes at a cost. You have screen walls, it comes at a cost. So I think customers are caught by surprise when they realize what numbers this cost to make this dream a reality. But definitely there's huge interest, there's huge acceptance, and everybody wants the best across the board today.
And so that's in your view, a good thing?
A very good thing. We can build more, so definitely a very good thing.
And you see that is actually going to have a direct impact on the quality of the building, because a better glazing means better waterproofing means a better life, and so on and so forth. Right? And obviously the thermal comfort which you get for the residents inside.
I think apart from the initial boom of real estate, post 2010-12, quality is a given. I think every end buyer or end customer knows what he wants and is very finicky about what he wants, and that's why you see only quality developers or quality builders survive in this market. So I think quality is a given, and nobody is going to compromise on that.
Do you see a change post-COVID? Pre-COVID and post-COVID, what's your experience?
I was just discussing with Rohit. Post-COVID, there's a boom across the board. I think people want better living spaces. The housing market per se, be it individual houses or the developer market, is booming. And people want better product, larger products. And that's why you're seeing so many buildings come up now. And I think this is just the start. I think there's a lot more to go.
Thank you. Gokul
So you meant individual houses, people were looking for?
We make large format independent houses, yes.
Okay. Yes.
Gokul, that's your project in Thane.
Yeah, good.
Can you
Maybe
share?
just I'll brief out what is the concept design on that, but then we'll later on talk about the Chennai locality. So this is in Thane. So it's a 100-meter high structure, residential completely. And what is generally a mind thought, as Mr. Rohit was even mentioning, so it should be user-friendly. Everything you design should be focusing towards the end user. And again, as a human being, we always try to live with the nature, seeing in the ground plane. We always hesitate to see a sky, we always see at the eye level. And we love to be things in the eye level everywhere. So if this design, if you see, we have got the terraces at every height, even at the 90-meter height, you have a landing terraces which can be used, accessed and viewed. So your trees are still being visible. The one photo that you have seen a couple of slides before, in a 60-story high, you see just the sky or the other buildings. You don't see any greenery there. Greeneries are all below. So design thought of this is to bring the greenery at every level. He was mentioning about the terraces, landscape terraces, which is not at the terraces, it's also a part of your floor plate. So every building, every unit has a view to a tree. So you can have a greenery scene across your windows. And it can't be again a stack effect. So when you do a multi-story building, you always have a stack effect, copy paste the same unit top. So it's easy for you to structure. But on a practical basis, on a look-wise also, it may not be aesthetically pleasing. What we did this is, we had a typologies of units, A, B, and we just oriented it, stacked it this way that you get a good facade and you have a good multi-pitch stackings in this. In between, you introduce the duplexes, which gives the double height effects, and you have the podiums, which is like 4 or 5 stories high, which give a full height. And you give a balconies which is internally. So the balconies are not only facing outside, you have internal balconies which you can see and you can enjoy that. So it's in the heart of the city, again 5-acre land, very limited land parcels. It is worth for metropolitan cities where you have a land scarcity. So this is Mumbai, and you know how the land value in that. Coming to Chennai, so this is the design basic brief of it. When we started about the Chennai's expansion. Yeah, it's right. Chennai is expanding horizontally, not on vertically. Moreover, there is a historical impact also in that, because culturally we all plan to live together. Mainly South Indian culture is the joint family culture, and people need more space. They want a courtyard culture is what the traditional we had. We had a courtyard connecting with all the units together and the land together. People are giving more value to the land, more than the UDS system, which is in this kind of multi-storied building. They were hesitant to build, as he was mentioning, 2 decades before. People are not interested to, maybe not relying on a UDS system. They didn't know what is UDS, whether it will be worth it. Tomorrow something happens, where is my land? So that is the intent that every South Indian basically has. And that is because part of the culture. And we live, as I was mentioning, a joint family. An apartment is always 3 BHK, 4 BHK, do play maximum. So not to accommodate everyone. And again, they wanted to have a easy moving out. So they want to have a land level connectivity, not a high rise to come down. If elevator fails, that was a point when in 3 decades before, that was when the elevators were coming in. They were saying, well, it's a power supply fence, how can I climb down so many height? All these were the concerns when we started on. And actually, those are good points. Like, these are logical points, as we were mentioning on the end user friendly. So these are the points that end users will think of when he is buying at a 60-story height. He is getting a good views, okay, fine. But in case of emergency, how is going to come down? If something is happening, something is in panic, so how is going to come down? How is he going to respond? Or who is going to help him? So it's all interdependency that basically it's a mentality that we had. And the culture is now, it is developing. So as you said, like the Western influences have come in, and it has come in fast. Like the history, South India is always hesitant to take the influences. We always live by our culture. We will try to actually motivate the culture our own, and that's why we're behind Tamil still. We want to have it, our culture to be renowned one, and we will try to spread that also. That doesn't mean that you should not have a high rise. So that is good that policies also matters. Now the government has given a good policy of expansion, the master plan. This way your expansion is horizontal. That means your congestion is stopped. So if you see Bangalore, even Mumbai, the issue they are facing is the traffic and the infrastructure failures, because everything is concentric. And when you boom it in the one specific location in an infrastructure, definitely you can't handle it. Your carbon neutrality we are talking about, it will be, you will see a polluted landmass and you will see a completely different landmass on the other side. So definitely that is where we need to think for, and that is visionaries. So we have a good visionaries from South who done the master plan, and I appreciate them. That should be a horizontal development for now, which will actually create satellite spaces. So we are working out now towards Chengalpet, where master planning is happening over there. So we can even work to the down south, down north. So everything has to be planned in a horizontal way now, and then the plans, satellites can be then converted into, with the FSI restrictions limited, being freed up to have the high rises. So that will help you on a infrastructure basis of master plan of 2070. So always visionary should be too far. Don't be restrictive like in next 10 years I should be having a multi-rise here and it should be developed. That is too short visionaries. We should have generations of visionaries. 3-4 generations after how will people be going to live. So that way I feel Chennai is going on a right track. And we also as architects also influencing that, also suggesting that. And that is also, there is a leverages now, the FSIs have been increased and everything has been potentially done. And people's culture as generation, second generations are now ready to accept the high rises, and they are going to going above the levels that we are looking for. So that's what the future is, what I could see now. We'll definitely have a good high rises. Yes, you had
these vertical green volumes.
Correct.
Were there a response to that ubiquitous refuge floor?
Yes.
Is that how you navigated the refuge floor?
These acts as refuge floor too, for those 7 floors or 5 floors height that we needed for it. So commercial spaces, again, we are concentrated on the residential now. That is also a commercial high rise, which is working out well in Chennai, rather than the residential high rises. Because commercial high rises need that refuge spaces is mandatory. Residential says even the balconies can be a refuge. But over a period of time, the balconies are encroached and it is not being actually used for that. So that is where the reasons where we give refuge terraces even in that. And now the authorities also insist on.
So just looking at the form, right? When I'm looking at the...
Right.
Did you encounter from the client or any of the decision-making teams a response saying, why have you broken the building and then joined it together? Because it's a very, as a design response, it's very interesting, but building tod diya, yaar, building kyun tod diya? So did that even feature or come into any conversation?
No, there is that. Those conversations do happen. This is actually cracked facade. The concept of this, it's a cracked facade design. Starts with it like where it is split. You will, again, human mentality, you don't want a common wall, you want it to be everything different. So here if you see those portals will deviate from that side, this side. So you will not know who is on the other side. It's not a common wall effect. And that is a privacy, basically. And residential, privacy is the main thing. And user ka puchenge, so they will say like, I should not see my neighbor. I don't know. From inside. From outside it is different. So all that concept worked well in this.
Great, lovely. My next question is for KRS. Looking at these facades, can you share what, in your technical opinion, are the challenges for creating edifices like this? So and obviously the second most important question, is this appropriate for India?
For India, okay. So actually Mumbai, 15 years back, there were no tall high-rises which are above 180 meters. That was just starting up, right? So then the code started changing. The local code started changing in Bombay. Like the CFO norms changed, everything changed. Now if you want to build a high-rise, first is your, your aviation height. That is one concern which you already have. But then it's also openable windows, which Western countries, like if you go to US, you don't have a window in the 70th floor. Here it's like you require it. I need a balcony on the 70th floor. That's what people want. So your marketing team is restricted to thinking that they need to have that. Otherwise the customer is not going to buy it. So the limitation is the hardware, because your hardware has got some warranties. So it fails. After 15 years, then you start having issues in the building. You'll have leakages, you'll have issues, panels falling off. So that's what
but each of these towers is using the world's best systems, and it's at par with whatever
you... System has got a warranty.
Right.
So anything openable, any hardware has got a warranty. So if you look at US and if you look at the tall structures there, there's no openable window. There's a breakable glass.
Right.
for evacuation because your fire tender cannot reach the 100-meter height. It can't go above 100 meter. Especially Bombay, they've got a 100-meter tall fire brigade, but it can't penetrate the roads, which is basically congested. So you won't reach when the fire happens, first of all.
So you're entirely dependent on firefighting systems for each of these towers?
It's compartmentalization. That's what the whole point is. So you have a refuge floor is also never in the Western countries you don't have a refuge floor. Here you have. So that all these things will change over time. So I think Bombay has experienced it before. Chennai will experience. They may come up with a new idea. It may happen. The codes may change based on that when other cities are developing.
So hasn't this changed virtually rewritten the National Building Code?
It has changed. That's what I'm saying. So it is basically what is going to happen is now if you, in Chennai, right now you've got double skin. Now in Bombay, if you want to do that, you can't do it because the CFO will ask, where is my openable window? How do I evacuate people? So you can't have a double skin which envelops the building. So in Chennai, it is happening because it's only 5 floors, 10 floors. It's all are happy
but
with that.
How is the firefighting crew going to reach 200 meters?
You can't.
So then where's the question of evacuating?
So that's the point. But the norm is saying that. So your CFO norm in Bombay says that I want a side-hung window on the outside and inside. And your NBC 2016 has got the same norm, saying that I want a side-hung window which is opening with a fall-arrest system. So it doesn't happen. So what I'm saying is this will all change in Chennai. Maybe when Chennai starts growing, things may change because everybody is going to retaliate and say, how can I have a window which is a side-hung window on the 200-meter level where your fire tender can never reach? So
the Omkar 1973 charged every square inch of the balcony spaces, which was more than the usable spaces of the flats. I did a detailed study when they launched because we had some client who was looking to, and so they asked us for a comparison between that and the Oberoi.
Right.
And Lord Foster's design ensured that you paid more for the balconies than for the real estate that you're using. And the kitchens are an absolute apology. They're just ridiculously small galley kitchens, if I may use the word, literally galley kitchens. But how is all this receiving public support? And
because that is the market. Everybody wants a balcony. In India, everybody wants a balcony. They want to stand out.
Yeah, but no one in Mumbai knows Norman Foster. I mean, he's got a retrospective going on at the Pompidou Center right now. But to a Mumbaikar,
but that's a client's design brief. How can an architect say no?
Right.
So I think that is the concern which I have with all the high-rise buildings. It's not about only Chennai, it's all over.
The peculiar specialty for Indian high-rises is that it ends up being a composite structure, unlike a complete steel construction as you would see in New York City.
Right.
So there's this wonderful Instagram page called Yimbigram, which is documenting every single high-rise which is coming up and down Manhattan. And it's just a visual treat, apart from the fact that there's so much of knowledgeable information. How do you see that panning here with relative interest to the windows? Because when you have a steel construction, then your entire fabrication is modular and it gets connected and engineered back to the system.
Right.
But in our system, where you've got a concrete floor, maybe a deck floor, gypsum walls now, because finally the people have accepted the fact that you can have a non-masonry wall, which is acoustic, so-called, though in my view it's not really. Then what happens to the glazing?
No, glazing is an exterior element. So basically you have the slab, you're connecting it to your slab and then having fire stop and sealing the slab. So there's no issue there. It's a non-load bearing structure.
Yeah, but in terms of engineering, deflection,
that's taken care in
wind
the design
loads,
itself.
I mean, Mumbai, you're looking at monsoon.
Right, that is taken care in the system itself. So you do a performance test based on the parameters what has been derived for the design. So that is not an issue.
Where do you see the whole embodied carbon narrative going as far as India is concerned? And do you think it's going to be sustainable with the new generation? I think in Bao I saw this hydro, which is entirely a new this thing. Do you see that? Do you think India will have takers for that, and we'll be able to?
I would say we have a long time to go. It's all in theory right now. We are not following it. Even though we have got calculations, everything is software related. It's not actual. We don't know what is actual.
Right. Right.
That's the challenge.
But then that is something that is a direction forward that we can look forward to.
For example, you're importing all the stuff. So where does the embodied energy go? You know, it's all air freight or it's all ship or whatever, you know. So you don't have that, the calculation is not there.
So how far are we from manufacturing it here?
It's soon. I think there are many companies who are actually getting inspired by, you know, because there's a requirement now.
You look at the market.
It's a huge market. It's a huge market.
Tier 1, Tier 2, Tier 3, and it's huge. 1.4 billion people.
So there are a lot of technology transfers happening. You know, the machinery, the technology, and the materials. I think that is happening. Like glass companies have already come into India. There are 4 companies. 15 years back, there was only 1 company who used to manufacture glass.
No, Ahmed had agreed to come for a lecture a few months back at Mohammed Satak along with me, and he showed a beautiful slide of the first Apple store and how many glass panels that were required for that, and the latest Apple store and how few and how tall. And that slide, that visual depiction or the chronology or the progression or literally the evolution of the Apple store is testament of engineering and glass technology.
So it's not about money. It's about people involved in design and trying to take it to the next level. So I think that is what Apple Store has done. They have taken it to the next level every time. So,
which is why it's a $1 trillion company today. One of the only $1 trillion companies on the planet.
True.
And that brings me to the last part. Biju, how do you see your work and the way forward for a metropolis like Chennai, keeping in mind, not just Chennai, I would say South?
Thank you for having me. I must confess that I'm not an expert in this subject, in the idea of facades, etc., because we are a much smaller practice. We work very intimately with the projects that we are involved with. And so a lot of our work is also sort of, at some levels, it's tried to offer a certain kind of resistance to what's happening. And what I mean by that is that I'm also an urban designer, and to a large extent I feel a lot of how we build is also starting to create a certain sense of placelessness in the way our cities are growing, in the way we talk about development but we don't talk about progress. And so there is, as an architect and as an architecture practice, what we tend to do is to kind of try and look at building as places. And for every project we do a lot of large scale projects, but every project that we do, we look at it from the standpoint of how do we create a place out of it. And so whether it's facades, whether it's articulations of many of the things that we do within our buildings is a response to, with that intent, to kind of achieve that intent. This is a project in Bangalore which we just recently completed, where we went into the site and we saw these wonderful old banyan trees and rain trees on the site. How do you negotiate density? And then there's a client who wants to do 2.5 FSI on that site. So how do you, and these are the challenges when you go into
this is a 2.5 FSI.
This is a 2.5 FSI building in just off of Indira Nagar in C.V.Raman Nagar. But the site had these clusters of banyan trees and rain trees, and how do you kind of negotiate that? And these are the, we talked about growing the city, etc., but we also need to talk about what is the identity, of these buildings, and what are the kind of memories that we create in these buildings. And so a lot of our work is to kind of try and look at buildings as places. So this is a building which is it just carves around these trees, and we had to, of course, map all the trees, map the roots, extent of the roots, etc., and try and kind of design the structure. Extremely complicated building in terms of its structure, although it looks very simple. And everything then, sort of respond to that idea of, not just the idea of preserving tree, but how do you make that tree part of your day-to-day life? We talked about, sort of moving towards the future. How do we live in the future, right? So how do you take some of these things along with us as you kind of transition into a new way of living in many sense, the idea of trees, the kind of memories that it creates, etc. And so make it part of our day-to-day life. And so we look at design from that standpoint, in the idea of making places more than just making objects. And highly engineered buildings in many ways make me very uncomfortable. And if you look at these details, I've never worked with a facade consultant. It's a wrong thing to say in a facade conference. And it's not because I have anything against it, but what I'm trying to say is that India offers this tremendous amount of jugaadness, and I think that is where our sustainability comes. You showed that first slide, and truth lies in somewhere in between. We can't continue to operate in these extremes. I think sustainability happens in that balance, and trying to achieve. I mean, these louvers are, we work with a local fabricator, we work with them to kind of look at wind test, wind load, etc., etc. But if you look at the details, it has a typical tower bolt, it has a hinge which just opens like a traditional house, right? There are balconies behind it, very crude details, but it is able to kind of achieve a project which in many, these are not very high premium projects. I mean, this is still built in that 2,400, 2,500 rupees a square foot projects, And so how do you kind of try and achieve and communicate certain things that you want to achieve within that? And I think it's very important that as, Korea used to say this, it's not how high a building goes, but what goes into that building is more important, So as we build more and more, I think we need to look at what is the kind of identity, what is the kind of language that these buildings create, and what does it want to communicate more than just the idea of the facade itself. So that's, this project will start to demonstrate. So when we work across the country, and we do work across country, we don't have too many large clients, but the clients whom we work, we do a lot of work because, our sensitivities match and we kind of work. So for example, this client in Bangalore, we are doing close to 4.5 million square feet project of different scales, and there's an affordable housing project here. The same client, once we do this, he threw us this challenge and said, I have to sell this these are affordable housing projects, smaller units, how do you do this? And so, but we had the scale to deal with, and what you see in those thick white bands are all wardrobes. And so we kind of articulated that building to kind of, or the language of the building. There is no external elements other than just pure block work and windows here, There are punch windows, and that is where you see the depth, so it creates that second layer because you have that wardrobe coming out and the window being punched. But the idea, I mean, what is fascinating for us is to really kind of take up these challenges and explore, sort of beauty through them in many sense, in the idea of how do you deal with an affordable housing project. When I first presented it, he thought I'm putting all these louvers onto it, and then we had to go into the plan to see the plan is actually what the form and the facade is a response to the plan. So the plan has to be worked out to kind of create a facade like this. And so everything kind of worked together in that sense. So, I mean, this is the other end of that. And then there's a project in, I think the last project, you can maybe just scroll down. Yeah, this is a project in Trivandrum. This is again residential project right at the heart of the city, opposite to the Raj Bhavan. How do you deal with density? Kerala has very high FSI. It has almost 4.5 FSI. How do you kind of deal with this density and try and achieve all that within, with just still make those buildings light and contribute to the fabric of the city? I just want to show that last project in these slides. These are some of the institutional buildings that we are doing. But this one, I mean, go to the next slide. This is, no, go back, sorry. So this, no, go back.
Back.
So that's this is a, go back, one more. So this is a national competition we won. This is actually a center for architects. And here again, when we went to the site, we were inspired by the red soil of the site. And you can see that facade, the buildings start to kind of communicate that and really kind of develop that jali system based out of what we got inspired and what we felt that place should hold. And in the process, try to kind of create places through the projects we do. And I think when you look across the country, we feel this is what is more needed in the idea of critically looking at what we call as development and how do we continue to kind of sort of look at buildings as places. I mean, at the end of the day, cities are about people. And unless we develop our cities to call it a home, and I often say this, that, when you traditionally, when you used to, nobody migrate to a city for housing. People migrate for work, and then they make it their own home. So traditionally, if you go to Bombay, you become a Mumbaiker. You go to New York, you become a New Yorker. But if you look at how we live today, I mean, a lot of it is also to do with the way the economics is driven. But if you look at how we live today, I may have a job in Gurgaon, and if I lose a job, I'm ready to pack the next day to move to Bangalore because it's no more my home. But if I was a Mumbaiker, traditionally, if I lose a job in Mumbai, I look for another job in Mumbai because it's already become a home for me. And so it's very important that as we develop our cities, we don't lose sight of the fact that we also need to develop social infrastructure along with it, and all these buildings and how the building respond. Any public buildings as well, or a commercial building as well, how do you deal with the ground? How do you create places? How do you negotiate that relationship to the city, and how do we kind of create, how do all these buildings add up to become what we call as a home, and as a city? And I think that is what is, as a practice, a lot of our exploration is about that, is to kind of try and find that. And I think that is what we need to critically look at as we build more and more.
Super. Thank you.
Good afternoon, ladies and gentlemen. I hope you had good lunch. Welcome to the post-lunch session of Zak Chennai. We'll be starting off with Chaitanya B.K, Associate and Studio Head, CnT Architects. He'll be speaking on context, scale, typology, and facades. Welcome on board, Chaitanya ji. And round of applause, please, ladies and gentlemen. Please keep the enthu high. We have another 3.5 hours.
Hope everyone. Hope everyone's settled down. So CnT is a legacy practice, and more importantly, we are a non-personality centric practice. Like if you walk into our studio, you'll see various projects being discussed, and people brainstorming, and we welcome ideas from everyone. For this particular presentation, I'll be focusing on the more recent projects of CnT, and I'll be taking you through a few examples as in case studies. Not really doing a very deep dive into any particular project. I want to talk more about the process through which we design and execute it. We try to have an aspiration in every project, and we document this aspiration using a proposition and a diagram, which is very specific to the project. And most of the time we do this along with the client and other stakeholders, so all of us are on the same page. So few projects. The first project I want to talk about is MSR Tech Park in Bangalore. So the Tech Park is located, so this is the Manish Kumar Tech Park, and right next to it is this MSR site. So it is a very squarish site. So we did not want to start the design with having a square footprint, because you don't really have good light penetration, things like that. So we started off by trying to have a flow of landscape within the building, and looking at the north, we looked at having the south and the west more solid, and we looked at having office space, more linear office space, which opens out towards the east and the north. And we also looked at having how to integrate the other amenities along with this. So in these diagrams, we have again documented the principles we talked about, and since it's a leasable office, how efficiently it can be divided up into even further office spaces were taken care of, and what sort of views we are achieving towards the city. So this is again three-dimensional extrusion of the diagrams what I just spoke about. So as you can see here, the southwest, which is actually the road-facing side, is where we have stacked up all the cores of the building, and it opens towards the north and the east. Even at a site plan level, so this is the flow. So when you enter, you don't enter into an enclosed space, rather the backdrop to the entrance space is the plaza which opens out. So again, some of these points we put forth to the client using some tools, but these are mostly intuitive, and it's not that these tools made us do the design this way. It was a means of checking back. So these are the two distinctive faces of the facade. You can see on the left, which is the road facing, more solid to block the sun, and the other side is on the right. The entry plaza leading to the building. And this is the plaza, which is the backdrop. So this is a bird's eye view of the completed project. So again, leasable offices, so there were some very hard constraints from the clients in terms of what sort of systems and how much cost we had to go ahead with. So the next one is a residential project in Hyderabad for Myscape Group. So this is an under construction project. So this is a upcoming, this is a financial district. It's an upcoming neighborhood close to high-tech city, a very, very high-dense neighborhood. So after some brainstorming with the client, we arrived upon, it's a compact site, so we were looking at 2 units per floor. So, in continuation to the high-rise discussion we had just before lunch, so we were looking at, and this is also almost a 100-meter tall building. So we were looking at what sort of breakout spaces does it require. So few things we did was, one thing, we did not look at the balcony as a linear balcony which is just on the periphery. So we were looking at more enclosed balconies which feel more like a room, and they are well protected from the elements, and you can use them more often, especially in a hot climate like Hyderabad. And we also looked at having 2 of these balcony spaces for each unit. So what we discussed just now, if you literally put that into the building, this is the sort of massing you would probably end up with. So what we did is we did a flip of the balcony. Since the balcony is also like a room, we flipped that with one of the bedrooms. And mind you, Hyderabad has very rigid rules when it comes to what can be done and what cannot be done. So the result is this, where we have a very strong a building with a very strong silhouette, and it's very well defined. As you can see, the buildings all around, there are a lot of elements. So we try to give this building a more striking form, and it is true to its function. Where what is a balcony is expressed as a balcony, what is built is expressed as a built. And of course, to pull off something like this, we had to work out a lot of sections in terms of what happens when the balcony comes on top of the bedroom, or vice versa. So we did some sort of working out along with the structural and landscape architects. And we also try to incorporate a lot of sunken slabs, so that some amount of vegetation can be grown in it instead of just relying on potted plants. So the project is under construction right now, and this is a sort of expression what it has. Again, in terms of the materials and all, we have, as it is a residential building, we have gone for materials which are going to be, less maintenance. So in the same street, next to Myscape Otomo, is this project Weave, just across the road. the proposition is again simple. So we looked at using the refuse space. There's a refuse space which is required as per the law. So we said, why not have the amenities like the gym or the cafe along with the refuse space, and it also acts as a break in the building. So singular mass is actually given a break, and it's emphasized more by giving some double heights. And in terms of the expression of the building, we took a very varied stand and said, the top floors, since they're more prone to solar radiation, they'll be treated more in comparison to the lower floors. And for the lower floors, we started out with this sort of a wavy louver system, which we called it a weave, to give the building a more dynamic, and in general, whenever there's a play of sunlight, it leads to some interesting shadows. So the client liked that idea, and we ended up calling the building itself Myscape Weave. And even in terms of how the building was marketed, it was a very central theme in it. So these are some of the visualizations what we did. And the refuse space, which acts as a break in the facade along with being an outdoor space for the building amenities. So this is the drop-off plaza. You can see the louvers on the side. So the building is in the final stages of finishing. For comparison, this is the picture taken recently on site. We'll probably get the project documented. We're just waiting for the completion of the building. So this last project, Aurobindo Pharma had invited us for a design competition for their headquarters and offices. So we did a project pitch. So first I'll run you through the project pitch, and after that I'll show you the finished product. So this is in the heart of high-tech city, just opposite IKEA, for those of you aware of Hyderabad. So the thing was, there was a huge road. It's a very narrow and long site, and unfortunately the longer side was facing the south west. So I mean, it's a very massive building, some probably 2 million square feet of offices. So we started out with scaling down the entire mass. So the way we scaled down the mass to how we articulated the podium. So we anticipated some sort of amenities and commercial which happen at the ground floor, which will be stepped up. And then the entire mass of the building itself is divided into three. We have 3 cores and 3 dividable office spaces. And we also looked at some kind of relief for each of these office spaces. And looking at how it was the southwest, we looked at a second skin, which is a system of fixed louvers. So in terms of a diagram, to simplify the entire thing into a diagram and a functional map of the same. So, I mean, we did propose a lot of systems with respect to how being in Hyderabad and facing southwest, this project can incorporate through design a lot of features of sustainability, not necessarily through performance glass or something, but because of the way it is planned. So we looked at having a gap in between the DGU and the louvers, so which will probably act as a heat sink so that the air raises up. And in the podium levels, we looked at incorporating staircases which encourage people to walk up instead of always taking the lift, and other measures. So this is what we anticipated. So as you can see, there's a huge difference between what it would read as a single tower to what it actually reads when it is expressed as 3 different towers. So for various reasons, the project underwent an extensive redesign. And as you're aware, there's nothing like a area cap or FSI cap in Hyderabad. So anyway, for reasons beyond the scope of this conference, so we did a lot of further development, and it's actually a precast building. It's in fact, one of the tallest and largest precast buildings in India right now. And from 3, we came down to actually 2 cores also. So, and we got away with the system of louvers. So what we actually, in the end, finalized on was a system of diagrid. It's an aluminum diagrid system, which is extruded and then perforated. So again, we along with the facade consultants and vendors, we worked extensively on engineering this, and we designed this system so that it can be extruded and easily fabricated. And we also have provision for providing LED strip lightings behind the extruded system. And for the lower levels, we went for a semi-unitized system, not necessarily the DGU. So the expression of this is a little different. So we then detailed in various capacities the higher and lower floors. And in addition to this, a lot of detailing went on in the podium level, because of the level differences, we were not getting enough landscape onto the podium. So then we made use of these planter boxes, which are extruded up, which act as plantation, so that the plantation actually comes on till the ground level. And this is a visualization of how the main entrance is going to work. This is the facing the IKEA side, and these are some completed images of how it turned out. Again, in all these things, we worked very closely with all the stakeholders and various vendors to make sure things come out well. So some more images. And one of the challenges was, since the amount of parking and podium we had, getting some amount of landscaping was a challenge to us. So wherever possible, we tried to maximize whatever space we had. Again, the site was literally, except the building, everything else was literally the fire driveway. So we did get a little less space to work with, but we try to still maximize what we could. So yeah, that's about it. Thanks for patiently listening to me. Thank you from our team CNT. Thank you.
Thank you, Chaitanya ji, for that presentation. Next up on stage will be Ron Hull, Global Director, High Performance Products, Kurare. Welcome, Ron. Round of applause, please.
Hey, I'm Ron Hull. I'm the Global Director for the Kurare High Performance Products. I'm based in Florida, and I thought Florida was hot until I came to Chennai. You're definitely hotter than Florida, at least at the moment, but it's wonderful to be here. I do want to thank the Zak organization. We've been partners with them for years. They do a great job putting on events all over the world, so it's an honor to speak today. All right, so my topic today is laminated glass applications with advanced interlayers. My agenda today is introduction. I'm going to talk about structural glass applications, 4th century and ballistics, and then the Carrari sustainability goals. Carrari makes interlayers for a lot of different applications, like from safety to recyclable, but the two things I'm going to focus on today are structural and security and recycled and sustainability. I assume sustainability is a big topic in India, just like in the United States. All right, so glass is a fantastic material. Some of you may recognize some of these buildings, but sometimes glass breaks. So there's really 3 types of glass. The first one is anneal glass, also called float glass. When it breaks into these sharp shards, and it's very dangerous. You don't want to be anywhere near these shards, or it'll cut your skin. And then there's tempered glass, which is 4 times stronger than anneal glass. And when it breaks into very small pieces. So tempered glass is much safer and much less likely to break than anneal glass. And then you have laminated glass. Laminated glass can have either annealed or tempered glass. And in my opinion, laminated glass is the safest glass out there because if the glass does break, it sticks to our inner layer versus falling off a building or flying it in the air. Okay, what is laminated glass? It's pretty simple. It's 2 pieces of glass with a film in the center, and sometimes it's called an interlayer. The 2 main types of films are polyvinyl butyrol, or PVB, and the other is ionoplast or century glass. And a quick comparison between the two, century glass is 100 times stiffer and 5 times more tear resistant than PVB. And you'll see this in some of the videos coming up. Okay, now we also have 2 structural interlayers. One is called century glass ionoplast. The other is called Trosovil extra stiff. It's a stiff PVB. And this chart kind of summarizes when to use each and what are the strengths. So century glass is a structural interlayer that has structural properties at 50 degrees C and above. Trosovil extra stiff is a stiff PVB, but it starts losing its stiffness and structural performance at around 30 degrees C. And once you get to 50 degrees C, the stiff PVBs and structural PVBs are the same. They're both really floppy. So century glass also has excellent exposed edges. So if the edges of the glass are going to be exposed to the environment, salt, humidity, rain, sunshine, century glass has 25 years of data now with excellent weathering. There's many sealants out there. So century glass is compatible with most sealants, so the sealant can touch the inner layer without any issues. And then transparency. And one reason that Apple uses century glass in all of its buildings is because they want the best transparency out there, and it just has really nice transparency. So Trosovil extra stiff, it's still a very good product, but we recommend if it's exterior, you have the edges covered and not exposed. And if you're going to have a project indoors and you want a structural glass, it's a great product. And so one reason to use the extra stiff PVB would be to lower your cost. All right, so now for some of the applications. I'm sure some of you recognize this. So really the whole structural glass revolution started by Apple, and here's one of the first projects in New York City. It's called the Cube. Their store is actually under the ground, and this cube stands above it. What's interesting is this project has been renovated 3 times already. So the goal is to increase transparency, so every time you have a metal fitting, that blocks your transparency. So today, this building looks much different. Also in 2005, this was one of the first glass railings or balustrades installed where it was only supported by the base of the glass. So, and it's also about 3 meters tall. So this is a windbreaker. It also protects people from falling off the building. And I was up here 2 months ago, and the glass still looks great. All right, next is also in the United States, the Grand Canyon Skywalk. I think people who are afraid of heights would never design something like this, but it is pretty cool. It's the cantilever goes out, and it's 220 meters above the Colorado River. If you're ever in the Las Vegas area in the United States, this is a short drive, and if you're not afraid of heights, it's a great event. And then the Four Seasons Hotel in Mumbai. This has a beautiful glass railing. It's very similar to the Top of the Rock in New York City, just the glass is not as tall. And here is an interesting project. Someone decided to make a glass box and put it on the top of a building and have people jump off the building and slide down. So this is in Los Angeles, 300 meters in the air. And I'll show you a quick video. So I've ridden this a few times, and it's pretty funny. And actually in Dubai just installed something very similar to this. Okay, next is a suspension bridge. This is a bridge that kind of moves when it's windy. Also a glass floor. You can see this bridge, you can drive a car on it, very strong. But there was an extra piece of glass, and they decided to break the glass on top of the bridge, just to show you how strong the glass is. So in this case, the glass is now broken, and they jump on it. So this just gives you a reassurance that if the glass did break and you're out there, you don't need to jump off the edge. You're going to be fine. All right, and then in Thailand, here's a great project. You have this huge cantilever deck. And then the last one I was going to mention in New York City, this is opened up about a year and a half ago. It's the highest observation deck in the Western Hemisphere. Has a nice glass floor on it and glass railings. Okay, next is force entry and bullet resistance. So this map here shows in red, you'll see where terrorism has occurred since the year 2000. So you can see in my home country, United States, we have a lot. I do see some red in India, so it's an unfortunate consequence of our society. There's also, in some cities, some civil unrest, people breaking into buildings when they're mad or to steal things. So our inner layers are used in many different security glazing applications, and I'm focusing on these three. Okay, so force entry has many different definitions, but really it's there to keep someone from breaking into a building, or it's there to keep someone from breaking out of a building, so like a prison. Or bullet-resistant glass is where you shoot the bullet at the glass and you don't want the bullet to go through. And then there's bomb blast and explosion. Unfortunately, I don't have time to focus on that today. For glass force entry standards, there's three. There's one in the EU, one in India, and one in the US. And then for the window system itself, there's a EU standard and a US standard. And the X right there, this is called the X test. This is very popular in Europe for force entry. And the United States, they have a force entry test. It's just a series of different tools, and you keep hitting on the glass or window until you break through the glass. So this is from the United States during some of the rioting that occurred during COVID. You can see this is an actual crime going on. So someone has an axe or a hammer trying to break in. Now, if this had been tempered glass, the glass would already be broken and they would be in the building. So this was laminated with something. You see they're trying to break in, and they don't. So what we've done is created a test where first you shoot the glass 5 times with a bullet. The bullet goes through, and then you try to break through the glass. So on the left is a 1.52 millimeter PVB, and on the right is a a thicker Century glass. So here we go. You shoot the glass 5 times, and then you throw bricks at it. So PVB already has a hole in it. And then you try to kick it, just like the video that we just saw. So in this case, the PVB did fail. And then the Century glass material, so now he had a 2x4, now he has a wrench. And there's literally 12 different tools that you do in a sequence. And then as soon as the glass fails, then you get a certain rating. Okay, so that's for 4th century. For ballistics or BRG, there are many different levels. This is the EN standard. There's 7 different levels. So in general, when the level is a lower number, the bullet is smaller and moving slower. And when the level is higher, like a BR7, the bullet is bigger and moving faster. So that's an easy way to explain it. And then the United States, they have two standards, very similar. So what we call traditional or conventional bullet-resistant glass is shown here. What we've done with our inner layers is created some new solutions where actually the glass thickness is thinner and lighter. And this just shows here, in this specific case with the NIJ, it was between 12 to 15% lighter. So we have a product called Spall Shield. It keeps the glass from flying into the building when the bullet hits the glass. So in this case, so here the bullet hit the glass. And now we're going to show the other angle for what the glass looked like on the other side. So the glass broke, the glass deflected, but our Spall Shield product kept the glass from flying in the building and hurting people. And so what we did, we created these cubes of just our inner layers, no glass, nothing else, and we shot bullets into them to see how far the bullets would go in to each inner layer. And so here's pictures showing the bullets. And the summary is that polycarbonate, our Century glass are very comparable, and then the PVB perform much worse because it's softer. Okay, so next, last thing, I'll talk about Kuraray sustainability goals. Everyone knows that the climate is warming, the ice is melting, the sea levels are rising. That's why we're all trying to be sustainable and reduce our carbon footprint. But this chart here shows CO2 levels going back many, many years, and really, just in the last 20 years, you're seeing a major spike in CO2. And I like this chart here. This chart shows which countries or regions have the most CO2. So, of course, China and the US are the leaders with CO2 emissions. Our company set a benchmark in 2019 to reduce emissions by 30% in 2030. And by 2050, we want to be net carbon zero. So that's our goal, and we're looking really good for meeting the 2030 goal. Okay, we also created some documents. These are popular in architecture, life cycle analysis, and environmental product declarations. So for our products made in Europe now, we have an LCA and EPD for both of them. And if not, they should be on our website already, these nice reports. But what we found was that PVB has 4.45 kilograms of CO2 per kilogram of film, and Century glass was lower. Century glass had 3.2 kilograms of CO2 per kilogram of film. Now, we have a product that's 100% recycled PVB. It's even lower than these, and once we have the data, we will let you know. All right, this chart just shows, PVB is good, structural PVB is better, and the Century glass is best for structural and carbon footprint. So the last thing, my last chart I'm going to show is we're trying to work with many different companies globally to separate the inner layer from the laminated glass after it's no longer needed. Because we want that inner layer to recycle it. At this point, there's too much glass still sticking to the inner layer, so we can't reuse it. But our goal is someday to When glass is no longer needed in the building, laminated, we'll recycle it. The glass will be recycled, and then we'll buy the inner layer and recycle it. So that's all I had.
Thank you, Ron. I think we'll all make sure we use laminate glass for our homes from now on. Next up will be Manish Kumar, Director TDS. He'll be speaking on design principles of sustainable facade. Please welcome on board Manish Kumar. Thank you.
Hello, everyone. Thanks to all being here. And thanks to Zak to invite me here for presentation as a speaker. So here I'm going to talk about design principle of sustainable facade. As we facade consultant, we can assist to the architect and developer to make the facade design, and that can perform efficiently in climatic conditions and can provide the cost-effective solution to the client. And can be ensure to the comfort and safety to the occupant. Here I am going to show a few slides about parameter of facade design. There's many parameters we can consider during the facade design, but I'm focusing only few. There's a key factor which we need to consider during the facade design and development, so that we get to know how is performed in a climatic condition and efficiency as well. And by this analyzing studies, we get to know the some value which can help to the finalized system as per the building requirement. Here some factors let me break it down for you, like daylighting for visual comfort, thermal performance for occupant comfort, and energy efficiency for reduced HVAC load, solar heat gain control, and structure stability. These are the factors we can achieve by these studies, energy efficient facade, and we can cut the cost of the project without deviation any specification of the material. Daylight analysis, this is one of the key factors of the parameters and principle as well, and by this analysis and studies, we get to know how much glare and light comes into the building through the facade line. Sorry. To the facade line, and how we can regulate and control that the glare, because of course it's gives a discomfort to the occupant as well. And here you can I'm explaining again this is our project is Annex 1 Noida. This daylight analysis we have conducted for this project, and we get to know after then what with the building orientation and how which facade surface is most exposed to the sun, and how we can control this, and some kind of value is provided by the ECBC and Graha as well. So that value we have to maintain and maintain through this analysis, and we can help to the select the glass specification for that particular project. Thermal analysis, again, this is the most important part plays when we design the facade and development here. So here's a few examples. You can see some few simulation we have done for this project, and this name is Chanpak Jaipur. This is Platinum LEED certified. Generally, the thermal analysis we use OT like OTTV value, overall thermal transmission value, so that we can match the digit with some kind of lead agencies over there. And however, the glass people's arbitrary report can provide the all specified value as per the building requirement, but we cannot rely completely on them. We need to calculate itself and we can provide some kind of remedies and solution and provide because the local system we can take here, because there's a not a high volume of the facade, so we cannot take, and the cost concern of the client as well. So, and through this analysis, we get to know the how the thermal how to know the heat transfer to the inside of the building through the facade line, and how we can cut the U value and down that one, and how we can optimize the facade system so that the help to the selection of the material, it will be the long laster for the building. Solar radiation analysis. Again, this is a continued part of the energy analysis. This is one of the very important part when we do the facade development here. As you can see by the simulation, this is for example for your reference here. And left side of the building, you can see the most exposed the sun facade. When we do this exercise and studies, we have to do the sun path analysis and solar analysis, so that we get to know the orientation of the building and get to know the most exposed facade part of the towards the sun. And as you can see the this figures we can calculate from there, BTU, brittle thermal unit, and when it is cross the limit which is provided by the ECBC or LEED certification. So we can go back to the architect and ask with the solution like horizontal awning and vertical fin or second skin facade and horizontal fin, because this is the aesthetic concern. So architect decision is the most important part play here. So with the hand-to-hand discussion and with the architect, we back to the simulation with and you can here see the how does it drastically down where we put the fin over there. So there 4.8 and 2.6 watt Kelvin square watt square Kelvin, and BTU thermal unit as well. So, so by this exercise and simulation, we can cut the cost or the HVAC and HVAC and Amernath guys can design their chillers in very efficient way by this values and all well. OTTV analysis. This is a example only the generally used for the LEED certification project. This is the manually calculated the OTTV overall thermal transmission value, and we can optimize glass and aluminium and cut the cost for the project as well, and this is the requirement of the building. Wind analysis. When we finish the all energy efficient studies, so we we need to come on the wind analysis so that we get to know the structure stability for facade and how the wind behave on the structures as per the height and the typology and the effect on the typologies and the geometry as well. And I'm continue this with my case study here. This is BHEL corporate tower, which is being constructing over there in at Noida. This is a purely steel structure building, and when we do the facade design for the steel structure, again face the complexity over there. Yeah, continue the wind detailed wind calculations like during this detailed wind calculation, we it define the structure stability facade for the whole structure. This is the 90-meter high structure, and we have calculated over there the 3 kPa full. So we have apply here the zoning, that's wind load in zoning path, and we don't need to take the higher wind load on that affecting on this that structure. So we have to we need to calculate only the wind load, mean wind load, so that we can finalize, we can design uniform system which can go from bottom to top of the structure, and wherever the structure, wherever the aluminium can over the limit of the mean wind load value, so we can have such kind of the reinforcement into the aluminium system, so that we can control the cost and cut the cost of the aluminium, and it's again this is the deflection concern, and we need to stiff that section by the reinforcement or stiffener, and as per the building code requirement. I'm continuing this by another case studies here. Here you can see this is hexagonal panel facade. This looks very elegant over there, and this is not a rigid panel. When we do this rigid panel over there, so it will be after some time in the climatic or weather condition, it will be distortion. You can see here, because if we do the rigid structure, so in contraction and compression and seismic, by the seismic movement is will make distortion those. But we provided here for this project here unitized panel with some kind of expansion gap over there, so easy for installation, and we put the high engineering for this. So so what happened when we do this unitized panel can accommodate the contraction and expansion during the climatic and weather changes, and can accommodate the movement of the seismic movement as well. Yes, structure stability we have checked here by beam modeling, because this is a complex structure as you have can seen over there, and the curve we need to maintain when we maintain the hexagonal curve panel. So there's again was facing complexity over there. So by this modeling we get to understand how we can control this curve, and how we need to, and which degree we need to cut during the fabrication time. And again when that kind of complexity project, so we need to check that in the structure analysis in the 3D as an ANSYS we have used for this, checking the formation check and all that, so that we can get the precise value and be more confident when during the extrusion, for the extrusion and the installation at site. Here, this is a few example what we have checked here. This aluminium mesh, we are checking a deformation and stress checking over there for the unitized panel, as you can see there. This detailed drawing. When we finish the whole exercise, when we check the model in 3D and we have done the stability check and all that, and then we have to go on the path of the fabrication drawing for the shop floor. They can make all the things with as we have model and what we have structure check, and what we are going to the installation. So this is a very important part in between of the installation and designing the fabrication drawing. And again we cannot defining like that, because as you can see over there, what we have designing at this at the time of installation time depth, it vary over there. But here you cannot find any discrepancies between the designing architectural intent and the site installation. As you can see here, the site mock-up over there. So this is possible when, because from the beginning and end, the facade consultant didn't work proper way. So we can get that kind of finishing and stability and energy efficiently, and all kind of possibilities we can provide for the facade. Here the material selection, this is again one of the important part. Once we finish and gone through all exercise like energy studies and structural analysis. After then, we go to the value so that we can define the material selections like light transmission and internal reflection, solar factor, U factor, shading coefficient. So after then we can get to know very easily, find out the value which is very which is very good to and will work efficiently for the facade. And again, this color is concerned to the architect decision. So the architect decision is the most important in terms of the color selection. Here again the material selection. This is when you see here the left side of this, a high level of internal reflection causing mirror effect. When you see the night time outside the room and the reflection will, you can see the reflection of your, this is the obstruction, again the discomfort of the view. So there's many factors which we need to consider during the selection as well. Here the reflection and absorb and transmission. So when I conclude this all in one word, so when we done the energy efficient studies and the structural stability and by the material selection for the last longer things, so we can maintain and provide the energy efficient facade for the social. This is our current projects we are doing. NCRTC stations, this is a parametric project facade over there, and we have the corporate BHEL corporate tower Noida, and Raghuveer COVID hospital in New Delhi. And as you have seen earlier, Annex 1 Noida and Business 18 Jaipur and MK Shiva Market, as you have seen earlier. We are TDS Courteous Private Limited. We are in facade consultancy, and our aim is provide the efficient facade for this society. Thank you very much for listening to me.
Thank you. Thank you, Manish ji. Calling next is KR Suresh sir, Regional Director, South Asia, Avante Façades, and he'll be delivering on fire hazards, my personally favorite topic. Welcome, sir. Round of applause, please.
I have got the issue for the future, because now nobody talks about fire in Chennai. In Bombay also nobody used to speak about fire. Now they started speaking about fire and all the norms and codes and all that stuff. Yeah, where's the point? Yeah. So I have a very short presentation. I think the panel discussion can prolong then. So it's very simple. So you've got integrity, you've got insulation, which is very fair in terms of, if you have a fire in a room, it should not travel to the other floor. That's the basic principle. So the NBC has already taken that. NBC 2016 has all the norms, but I think the parameters in terms of the testing is not considered in the NBC in a very very elaborate way. So what I'm trying to do here is I'm just trying to evaluate all the codes and come up with a very summary of what is required and what needs to be considered. So if you look at resistance to fire, the slab, the RCC is 2-hour fire rated based on the structure. So any projections where there's a curtain wall has to have a 2-hour fire rated system. The glass will crack in 30 seconds maybe, because of the heat. So there's no issue there, but the fire should not travel from one floor to the other. So these are 3 ways the fire can travel. One is basically from the gap between the floor and the curtain wall or any facade element. The second is through the the spandrel, and third is a frog leap, where if you don't have a spandrel of a certain height, your fire can travel to the next floor and it can keep on traveling towards the floors. So one of the projects we had a problem where it basically it was a high-rise building, and the high-rise committee told them to put a railing because they didn't have a railing. They had a tall glass, full floor. So they had a railing which was put in later. So the contractor basically took the spandrel insulation as the earthing. So the GI sheet was taken as a earthing, and the whole glass wool, the rock wool actually, burnt. So that was an incident which happened, which you don't know, that is not in the code. So that is a problem. So I think we need to be clear on what we are doing in a building, as an architect, as a consultant, and as a facade contractor. So this was what it was 20 years back, like in all over India, I would say. I've seen all the projects like this. They just put an aluminum sheet, a GI sheet, sprinkle some rock wool or glass wool, and they just leave it. This is my fire stop and smoke seal. So then, over the years, I think everybody's been aware because of the fire hazards which have happened. And then people started thinking what will happen in case of fire. So this is what happens. The whole system, any facade system will start moving. There will be movement because the aluminum will basically soften up and it will deflect when there is a fire and when there is pressure in the building. So then the insulation, the gap between the slab and the curtain wall has to accommodate that. So then I think, what happened was, then there was a very theoretical system, a good system which came in, which it's a wet seal, where you have the insulation which was actually compressed and put into the floor with the GI, angles, brackets, and then they used to put a acrylic sealer, which is a fire stop. Now, this was a water-soluble solution where you spray on the insulation. So this again, it's again depending on the supplier may be fine, but depending on the applicator. So then we started stressing on the applicator. The applicator should do a good job in terms of thoroughly inspecting it, and the supplier should give a warranty on it. So we used to take the warranty from the supplier for the project, not from the applicator. So then this is how the system is. Basically, you compress the insulation, you put it into the cavity, and then you put the acrylic sealer, which actually overlaps the aluminum frame and the slab. So in case of fire, when the curtain wall moves, when it deflects, it actually accommodates that difference. Excuse me. Yeah, it's okay. Then came, you have got dry. There are two systems. One is a dry system and one is a wet system. So what I showed before was a wet system. This is a dry system where you basically have it compressed already, the insulation. You put it into the cavity, and basically you put wherever there's a joint where the smoke can travel, you put a aluminum foil, which is sealed and it's already tested. So now these are the two tests which are normally done, where all the codes follow this code, which one is the ASTM and one is the EN. So one is an open chamber and one is a closed chamber. So what ideally, this is a stringent system. The closed chamber is a stringent system which is applicable more for fire stops. And this also is applicable, but it's more for, I think material combustibility and all. So now this is one example of if it is not done properly, if it is not sealed properly. So that's the reason I'm saying applicator is very important when you do such things. Now this is what the end result would be. This is a 1970 image, but this is what any city it can happen if you don't do a proper fire stop and a cavity barrier. So fire can travel from any floor. It can just travel based on the combustibility of the material and what can burn. Next is the reaction to fire, where you got all these materials which are combustible. Like we use non-fire rated ACP because that is what is cost effective. So all your projects, I think the client or a developer needs to be aware of what materials can be used in a building. See, these codes are irrelevant unless you are aware. If you try to reduce the cost, you may just use any material. So I think every material should be, you need to give a thought to it whether it is the right material to use or not. Codes is something which is only governing it, but nobody controls it. So in India especially, we just use any material because there is no recourse. Like, nobody is going to sue you for $1 million or $2 million. So it's not a problem. Now, in the code, in NBC 2016, it says a building above 15 meters is a high-rise. That is what is the code. And here we have got a norm where, it's basically you have a openable vent, which is every 10 meters, you need a 1 meter by 1 meter opening. So whether it's a 15 meter or whether it's a 200 meter or 300 meter, it's applicable for all the floors in all the cities in India, because the NBC, if you follow the NBC. Now the problem in this is, like, if a fire tender, like what we discussed in the panel discussion, a fire tender can't reach 100 meters. You can't reach. So what are you going to do when this window is 100 meter up? You can't evacuate people from there. So what we have in some of the projects in Bombay is that we have a breakable glass, which is for evacuation, and that could be a window also, which could be basically a openable. We could have an actuator, which is the second screen, where it opens up in terms of when there's a fire, when there's a smoke alarm, it automatically opens up. But then it's expensive, so that's the reason why it doesn't go for all the projects. Third option is the openable window, which is always used nowadays. For the past 3-4 years, we have been using side-hung windows for some of the projects. Now the handle, we try to make it architecturally appealing by having an Allen key and trying to do all the jugglery to make it look good, so that the architect likes it. So the window which you have there, the side-hung window, on the third slide. So that's what happens. So a breakable glass is the right option in terms of it is inexpensive, and it's the right, because you don't have any hardware. So there is no warranty on the hardware. So the third option, where you see a side-hung window, it has got a limit. It's got a warranty period. So in maybe 5-6 years, the hardware is no longer warranted. So if there is in case of a cyclone or in case somebody keeps it open, the window is going to fall off the building. And that's happened in Bombay. So this is the Beaumont Tower. Now the second topic which I want to talk of is a cavity barrier, where you have a metal cladding, and in India I don't think even 1% of the project they use a cavity barrier. It's generally they just clad the building, they just finish off, and it looks nice. So what happens is when it is not done, when a cavity barrier is not done, the flames can just travel from one floor to the other, especially for residential or commercial. So if it is a window opening in a staircase, or whether the cladding can actually burn. So there are materials which don't propagate fire, but when there is a source of fire, it will keep on burning. It will not stop. So that is the problem. I think we don't need to wait for the video. Yeah. So this is the basic principle of a cavity barrier, where you have a metal cladding. So initially what used to happen is, this is what used to happen. You used to have a cavity barrier, you used to have the metal cladding touching the cavity barrier so that the smoke or fire doesn't travel. But then the problem was ventilation. So you used to close all the barriers on all floors. So that used to be the concern here. So now what has happened is there are systems available where you have an intumescent sealant in front of the barrier. So in case of fire, general condition, it just travels. The ventilation happens in the system. But when there is a fire, it actually bloats out. It seals the gap when there is a fire. So it compartmentalizes that area. It doesn't allow the fire to travel to the other floors. Yeah? So these are the tests which are done for cladding, for fire-rated FR grade, fire retardant ACP, or aluminum sheet, or any other material which is coming into the market. And these are the testing system certifications which are there, which are already available. I think that will happen in India and plus everywhere. It will just happen because of the projects which are coming up. So these are the product certifications. So this is my last slide. I said it's going to be very quick. So failure is good as long as it does not become a habit. So I think in India, because of the cost, we do these failures. It has become a habit because of the cost, not because of anything else. Thank you. Quick.
Thank you, sir, and we have also caught up on some time. Next, we'd like to call T.S. Aditya from Fundamax. He's the Vice President, Sales Application Engineering. Please welcome Aditya on the dais. Thank you.
Is my voice audible? Yeah. Good afternoon, one and all. I'm Aditya. I take care of sales and application engineering for Fundamax. I have been associated with this company for more than 10 years. I would like to start my presentation with a small video.
Change. Change is our constant. A journey over the last 130 years. We are rooted in change. Change is our way. And we are doing it again. We are changing. We think freely. We think ahead. We are Fundamax. We live perfection. We love design. We respect individuality. We complete what nature gives us. And we know where our journey is taking us. We are open for new ideas, for inspiration, for tomorrow. Open for you. And open for you to create. Fundamax.
So today's topic is going to be fire behavior and unique facade applications. The key important thing that we're going to showcase is what is the key criteria to select a material, especially a facade material, and what should be the right systems, and a few unique projects as well. So I'll not get into depth, but fire is a rapid oxidation exothermic process which emits heat, light, and other byproducts. Slower oxidative process like rusting does not qualify under this category of fire. We would have heard about a lot of materials which are classified as Class A material, Class B material, but not only materials, even fire can be classified. For example, depending on the point of contact or the material which is getting in contact with, fire can be classified as A, B, C, D, and K. For example, if fire comes in contact with materials like wood, paper, or fabrics, then the fire is classified as a Class A fire. In the right side column, you can see the methodology by which you can extinguish this fire. Similarly, if the material comes in contact with fire, the classification of material is something like flammable liquids, gases, oils, then it classifies as Class B fire. If the material is electrical live equipment, it is called Class C. Metals and metal alloys classify as Class D. There are a lot of flammable, combustible materials in the kitchen appliances as well. You have animal fats, edible oils, which also classify as Class K. If fire comes in contact with these kind of materials, it is called Class K. So we have understood what are the types of fire. Now we'll understand how do you classify the products based on how it reacts with fire. For that, we need to understand this graph between temperature and time. Every material undergoes certain phase of this process. So generally, the process is that you have the ignition first, then it goes into a growing fire stage. Then between the growing and the fully developed fire stage, there's something called flashover potential. Any material which crosses the flashover potential, the rate of combustion is very fast, and then the material gets burnt in a very speed manner. So if you look at A1 class material, something like concrete, brick, stone falls under A1, which means that no component of the material can catch fire. So entire component should be non-combustible. There are very few materials in this category. We would have heard about A2 class materials where partially few components can get thermally degraded. Now what do we understand by that? For example, we have something called an Hemlock panel, which is made up of glass fiber with a decor paper on top and bottom. So what happens is that the decor paper can get completely burnt, but the core remains intact. If you take, for example, something like glass wool is integration of a lot of glass fibers with some adhesive. So when the material is under combustion, the glue can get thermally degraded, and then the material can get weakened. But at the same time, it does not get completely ignited. So partially, some of the components of the material can catch fire. So when you look at a Class B material, which means that the moment you apply a point of contact of flame at a certain portion of the material, it burns at that area, but the moment you remove the flame automatically gets retarded by itself. So the material has a flame retardant kind of property. Any material which can retard flame on its own as soon as the point of source is removed is classified as a Class B material. Now, as you go in the ascending order from C to F, the time taken for the material to go from growing fire stage to the fully developed fire stage, crossing the flashover potential, the time period will reduce drastically. So, in general, facade consultants and architects generally prefer materials which are A or B class because C to F, the flashover potential time is very low and the material can get burnt very fast. So far we have seen types of fire, materials categorized as from A1 to E. Now we'll try to understand what are the different codes available. You have the European norms, you have the British standards, and you have the ASTM standards. Now how do we correlate? Because someone says it is class A as per European standard, some other person says it's as per British standard, and someone says that it's as per class 1 or class A in ASTM standard. So we are trying to correlate all the three codes and trying to justify what exactly is equivalent to what. So we have, so far in the previous slide, we have seen the different classifications based on the European norms. Now if you try to correlate, A1 in European norm is equivalent to a non-combustible material category as per British standards. A2 is limited combustibility, B is class 0, C is 1 and 2, D is 3, and E is 4. Our building norms generally is as per BS 476, or NBC is as per BS 476 part 7. So now this is how you can equate a European code with a British standard. However, if you look at ASTM standards, slightly different. When you look at ASTM standards, they talk about something called flame spread index. Flame spread index is nothing but the amount of fire by the length of fire. Now, what do you understand by length of fire? Any material which comes in contact with fire, the fire propagates in two directions. One is vertical, second is horizontal. Vertically, fire spreads because of the natural phenomenon, because of a lot of concepts available like rear ventilated facade system, rain screen facade system, which can give a leeway for the fire to propagate vertically. Horizontally, fire spreads because of the material property. As we are discussing about different kinds of materials, so horizontal spread is purely because of material property. So if you look at any material like class B, for example, a high pressure laminate typically falls under the category of class B. Or if you look at an M-look panel, it falls under the class A2. A1 to B, whatever be the class as per European norms, is still classified as class A as per ASTM norms. So generally, if you look at a high pressure laminate, the flame spread index is between 10 to 15. Since it is falling in the range of 0 to 25, so most of the B-class materials also classify as class A as per ASTM norms. So similarly, if the flame spread index is between, it can be anywhere between 26 to more than 200, so the classification is as B, C, or unclassifiable. Anything above 200 is completely not recommended for any kind of application, irrespective of what is the scope of usage of this material. So now we have looked at the codes as well. So what do the European norms say, what do the ASTM standards say, and what do the British standards say? We'll try to look at the various facade materials typically used for Indian applications and also probably some of the international applications as well. So we have something called aluminum, which most of you would be knowing about it. Suddenly in the last 5 to 6 years, this material is being used very dominantly in the market. 2 mm thick aluminum solid sheets are being powder coated or PVDF coated or anodized and are used in a form of a tray system for facades. So aluminum is a very good conductor of heat. The heat conductivity is almost 4 times that of your normal MS or GI. So it's extremely reflective material and it melts at around 600 to 660 degrees centigrade. This falls under the category of A1. So when you look at ACP, ACP is an aluminum composite panel. So what is an aluminum composite panel? It has 2 thin sheets of aluminum with an insulating core. Depending on the nature of the insulating core, the material can be classified into various types. Let us say if you have the core completely with polyethylene, then it can burn just like that and it is classified as class D. But if the core has a mix of polyethylene with a fiber mineral core with certain proportions, then it can be classified as class B, which is a flame retardant material. But if the core is completely a fiber mineral core with minimal traces of polyethylene, then it can be classified as class A or rather class A2, which is typically called as a fire-rated ACP, which gives you certain time period for the smoke and heat to come onto the other side. So stone. stone, Indian market, we are all stone lovers. It gives a different kind of aesthetic appeal to the project. There are some disadvantages in terms of increasing the dead load onto the facade and then having a high-cost substructure. However, you have different kinds of stone. For example, you have something like granite, which can disintegrate and explode easily in case of fire. Limestone also gets easily crumpled even with basic small traces of fire. But however, sandstone is something different. It is highly compact, and it can withstand fire to a great extent. However, irrespective of how they react to fire, they're all classified under A1. Then you have zinc. You have other materials like zinc, copper, and other things. Nowadays, you have solid zinc, and you also have something called zinc composite panels, again with a polyethylene core with 2 thin sheets of zinc. So solid zinc panels are classified as class A, and if you look at zinc composite panels, they can be classified as class C. Before starting the presentation, we started off with a small video, and we were talking about change. Change is something which is constant. It's very important to evolve and then understand and acclimatize to the requirements of the architect. We always have to be in trend, and we need to make sure that it is a sustainable and a safe facade. So if you look at this product called MLOOK, which we have launched about a year back, this product is made up of glass fiber flee. So it has 14 different layers of glass fiber flee. We have 12 different layers of gray colored glass fiber flee with 2 white glass fiber flee with a decor paper on the top. The reason why you have the white color glass fiber is because the impression of the gray color should not, again, imprint on the top surface. That's the reason we use a white glass fiber below so that the color of the decor paper does not get lightened. So this is completely a non-combustible material. Only the decor paper on top and bottom, the blue color one, what you see, gets burnt, but the core remains intact. This is a 7 mm thick panel, and so this is classified as class A2. Now coming to the product, I will not specifically talk about Fundamax, I'll talk about a HPL. HPL generally has 2 categories depending on the core of the material. High pressure laminate, nowadays you can call anything a laminate, but if you talk about specifically a high pressure laminate, it should have a paper-based core. So if you talk about a paper-based core material, it should be class B. If you have a glass fiber core material, it can be classified as A2. Irrespective of the product used, the rear ventilated facade system is a very important mechanism which is adapted in most of the facade materials. There are 3 basic criteria for a system to be qualified as a rear ventilated facade system. One of it is the gap, the cavity between your wall and your facade panel should at least be greater than or equal to 2 centimeters or 20 mm. You should leave a ventilation gap of 20 mm on top and bottom. The reason is hot air enters through this cavity. Hot air being less denser, it has a tendency to rise up, and you push out the hot air to the top vent. So by this mechanism, you allow circulation of air behind the cavity, and this in fact helps in a lot of ways. It increases the thermal efficiency of a building. It ensures that you maintain your ambient temperature towards the interiors. And thirdly, the third important parameter is the framework should be vertical. Until unless you have projection from the wall so that there's free flow of air of 200 centimeter cube per square meter, it is not called a rear ventilated facade system. Now, this is the main criteria for shortlisting a substructure to be a rear ventilated facade system. However, it has a lot of other advantages. It avoids diffusion of water vapor. The framework acts as bracing. It will also strengthen, and it gives a better life to the building. It gives you better acoustic properties, and it keeps your facade healthy. So we have seen the standards. I would just like to again reiterate that our NBC 2017 is as per BS 476 Part 7. The material high pressure laminate is called Class B material with standard of BS2D0. S means smoke index, D means droplet. So it falls under BS2D0. Now we have improved it and we made it BS1D0. And now the MLOOK panel is categorized as A2S1D0. Again, class A2, smoke index 1 and droplet 0. Irrespective of whatever kind of material you use for a facade, even if the material is completely A class, it doesn't really matter if your substructure does not support it. So it's very important to ensure that your substructure can also take the fire. When there's a fire accident, it happens because of some kind of short circuiting or some kind of mishap of an electrical equipment. It might be because of some faulty wire. It can be because of some kind of performance of refrigeration unit. It can catch fire very easily. So the point is, you need to compartmentalize various substructure components so that in case of fire breakage in one compartment, it should not allow to go to the other compartment. Secondly, whenever there's an opening in a dead wall, it's very important to arrest the opening wherever it's coming in contact with substructure by using materials like fire stop, so that the fire does not spread from the dead wall cavity, because the system what we're adapting, which is the rear ventilated facade system, actually increases the speed at which the fire can spread. So rain screen facade with compartmentalization can be an optimal solution. These are some of the projects. We have done this project, which is a kinetic facade suspended on stainless steel ropes, perforated panels. You can see this. This is done for a school project in Bangalore. This is integrated with a semi-unitized system. You can see glass and Fundamax alternately. This is for a station in Czech Republic, where we have done it on stainless steel, using stainless steel rivets on MS substructure. This is using M-look panel, and M-look panel is mandatory to be used, that is A2 class material for a height more than 22 meters. So if you have twin towers connecting with an interconnecting bridge, generally the bridge is cladded with M-look panel so that the fire breakage in one tower does not lead to the fire spread to the other one. Generally, I don't talk about the aesthetics of the product because that comes at the end, or as the topic gets diluted. Fundamax is actually started in 1890, and we have started operation in India in 2007. We have executed more than 15,000 projects in the last 15 years, and we operate through our channel partners. We also have other technical competencies. We do shop drawings, we do basic structure analysis. Of course, it has to be vetted by veterans like facade consultants and structural consultants. We also do 3D rendering. So we provide complete end-to-end solution for any kind of facade requirements. So our corporate office is in Bangalore, and if you're interested, please do visit us at our booth, which is there adjacent to the exit door. Thank you.
Thank you, Aditya, for that presentation on high-pressure laminates. Next, we will be having Faizer sir from Viva Composite Panels, and he'll be talking about ACP cladding and solutions for modern building facades. Faizer sir, your stage is yours. Please give a round of applause. Thank you.
Vanakkam, Chennai. I get some better response, please. We're just 20 minutes to the coffee break. Come on, Vanakkam, Chennai. That's better. Good evening. Feels great to be back home. And thank you, Zak, for allowing me the stage to present in front of my home crowd, predominantly my home crowd. I'm a Chennai guy, so special feeling standing. Not nervous, I would say a little more conscious because my crowd is here. Okay. The presentation today is ACP, a cladding solution for modern building facades. This is a series of presentations we've been doing at Zak to create their awareness about ACP as a product. The presentation is not focused on building a brand. It's basically to create your right perception about the product, break your myths about the product. That's what we want to do. Before I start into the presentation, a little introduction about Viva, the brand I represent. We are in this business for the last 2 decades, out of which the first 10 years was into importing of ACP, 1mm laminate, substitute to laminate, and the last 10 years has now been into manufacturing of ACP. Proudly, we can say that we are a Make in India brand, and we have a plant that is completely indigenous. It has the entire manufacturing capability right from paint formulation up to the final product, and today we make 9 million square meter per annum, so averagely around 30,000 square meter per day. We can extend warranties between 10 years to 30 years. We have 500 touch points in terms of branch offices, warehouses, distributor points, dealer points. Very important part of the presentation is going to be focused on fire retardant, and Aditya also did the same, which is, I guess, is very important and the need for the day. So we make all the fire retardant grades, class B, A2, A2+, and 8 state-of-art production lines, which I will expand later on the presentation. And Very importantly, we have 300 plus shades and textures. A quick look back at ACP as a material, the history of ACP. ACP was basically founded in the year 1969, which was a collaboration between Alusingen and BASF. So ACP was not meant to be an architectural product. It was basically a product that was created to be on the signages. In 1980s is when people started perceiving it as an architectural product, and it found its way into architectural cladding elevation purposes. In 1990, the usage of ACP became very rampant. From just being a normal panel of ACP today, we can see that parametric facades are created using ACP. We have 3D panels that have been shown in this project here, which we did at Nasik. So ACP has come a long way. It is now a popular cladding material, which has gone through its own, I would say, cycle. It has gone through its ups, it's gone through its downs. I should be strong enough to admit that. But then anything that is overused is also abused. So we all would agree on that. So it just got a little abused, and people didn't know how to handle this material. But it today finds a diverse application into various fields, not only architecture, but it also finds its way into shipbuilding, aircraft building, a lot of other fields, railway coaches building. We do a lot of work with ICF as a client, where we supply for railway coach, we supply the fire retardant A2 grade. It's come a long way. If you see that ACP used to be solid color, metallic color, champagne, white, silver. Today you can see we have shades like stone. We are moving towards the metal composite paradigm, where we have shades like tarnish, we have oxidized copper. So it's come a long way as a material, it has evolved. So as I rightly said, there's a flip side. When something is used extensively, you tend to get a little bored and monotonous with it. So you stop people getting, buildings getting repeated, people getting a little bored with the material. They are saying, okay, the same shades, every building looks the same, what new? So there was a challenge in front of all the ACP manufacturers. The whole industry had a challenge. Now, how do we counter this challenge? We interact with people like you, stakeholders like you, and we try to understand what do you want to see on your facade with ACP. And we got to know that people wanted to see stone alternatives, we wanted to see metal cladding alternatives, and that's how we came up with this new shades and textures today, which is constant R&D we do with our department in the plant, with interaction with all stakeholders like you, architects, consultants, and developers. So you can see this is our natural stone series, which is one of our more popular series. This is our metal abstract series. Moving further into the metal composite paradigm, we have tarnish series, real metal finishes with 15 years warranty. And okay, that's a little brief into what we do. Now coming to the real agenda. This is a building which you see in India which caught fire, where non-FR ACP was used. Core was polyethylene PVDF, obviously. So when fire happens, this is what exactly happens. ACP participates in fire, that is non-FR ACP, and you can see droplets of fire and a lot of smoke being emitted. So these are the two critical areas we need to address in ACPs. How do we stop the propagation of fire, and how do we stop the propagation of smoke as well? Please understand, in a fire incident, what kills is not the fire, the smoke is what causes the majority of the problem, because people get suffocated, entryways, exitways are blocked, fire tenders can't get in, so we need to work on the smoke part as well. So this is a small experiment in our lab, where you can see a non-FR ACP being subjected to fire, and you can see immediately it would start combusting, and it will start having droplets of fire come out. You can also see the smoke that comes out of it. So this is the exact problem. Okay, we don't need to speak on problems at length. Let's come to the solution. Now, how do we address this? If you take the construction of ACP, the top is an aluminum, the bottom coil is an aluminum. So aluminum is non-combustible, that we agree. But the problem lies in the core. Now, if we can replace this core with something that is non-combustible, then we end up making a fire retardant ACP. So a fire retardant ACP basically is nothing but a magnesium hydroxide and an aluminum trihydroxide core, a mixture of both, which is called in common man language mineral core. So this is the content of the core in a fire retardant ACP. Now you mix it to different ratios to create different class of ACP, like your class B and A2. So the primary class of ACP that is fire retardant is class B, and that is nothing but 70% mineral core and 30% virgin core. Now, this class B is not a nomenclature that has been given by any manufacturer. It is a nomenclature that has come from the EN standard. So EN 13501-1, the standard says that if you have a class B product, it has to be 70-30. Then you move on to make a more non-combustible product called the A2, which is 90-10. So 90% of mineral core and 10% of virgin core. So this is a small, again, a lab experiment, what we did at our lab, to show you the difference in performance between a class B and a class A2. So you see there is a very negligible amount of combustion. There is no, fire is not, it's not lighting up. There is a very small amount of smoke that will come due to the 30% virgin core that is present, which is negligible. It is not toxic. It's not going to harm the inmate of the building. In A2, you see the same thing, that there is absolutely zero combustion. So this is class B. So here a light amount of smoke due to the 30% virgin core. In A2, you would not see anything. It is zero combustion. It is completely non-combustible. It's a non-combustible fire retardant panel. This is a very important slide. This slide is the crux of the entire presentation. As stakeholders, you need to understand that when you use a cladding material, you need to ask your vendor for something called testing and certification. Please understand, testing is the best sample I put forward to get a desired result. So there is a chance of manipulation there. But when you get into a certification, you have a factory production control. That's an audit system by your certifying agency. In our case, it is Thomas Bellwright. So we've done all our EN certification, NFPA from Thomas Bellwright. Thereby, it gives us a factory production control. That means in a year, 3 times the people from Thomas Bellwright come to our plant. They audit the entire process, right from procurement to final product, to see whether the right amount of core has been used to make the ACP. And this is completely checked. It's a foolproof method. So this is very important. As a stakeholder, you need to ask whether the product has been tested or the plant is under certification. This will take away a lot of risk that you ride on a critical material like an ACP, which comes in huge volume on your product, on your project, sorry. So this is your EN 13501-2018 certificate from Thomas Bellwright, and you can see there is an expiry for it. There is the name of the company is mentioned, the brand is mentioned. So this is also available on the Thomas Bellwright domain as well. This is the NFPA 285, which is the fire propagation test, which is again a very important test to check the flame height and flame spread with the entire assembly of ACP as you fix it in the building. So this again is from Thomas Bellwright, and we have this for the class B, A2, and the A2 plus as well. So this is the real screenshot of the test that was conducted at Dubai and Thomas Bellwright. So these are the conditions that need to be cleared for an NFPA. I'm not going into very detail about it because time constraints, but I'm just keeping you posted. These are the 8 conditions that has to be cleared for the test to be a pass. Okay, now we got the mineral core going. Now what innovations do we show in ACP? So we moved ahead and we got the aluminum coil is there, but the core can be substituted with an aluminum core. So this is an aluminum corrugated core replacing the mineral core. This product is technically called aluminum corrugated core panel, and we brand it as A2+. The reason we branded it A2+ is because it performs better than your A2. So this is an innovative product that we have brought into the market, which is an ideal replacement for solid aluminum sheet. This is the construction of it. And if I do a small lab experiment, you will find it performs just like an A2 because there is nothing that can be combustible here. It's 3 layers of aluminum. So even if there is a fire, it is absolutely safe. The product is not going to participate in fire. It's an ideal replacement to solid aluminum sheet. The reason being because all 3 layers are aluminum. It is light-weighted product, easy to install. You can install it like a tray, and you get a single point warranty for 10 year, 15 year, 20 year from a single manufacturer. In this case, this is Viva. And it also has acoustic properties as well as thermal performance as well. We also make 12 mm and 25 mm honeycomb, which is a high-performance cladding material. All this magic is done here at our plant in Umbergaon, which is Asia's largest ACP plant other than China. The reason being, we have a PVDF mixing unit where we do the entire paint formulation. So all the paint that comes to us as components, and we create any shade and texture at the plant in collaboration with 5 top paint manufacturers. This is our first coating line. This is 4 years old. This is a single coat, single bake line that can coat up to 4 feet. This is a 5 feet plus line. This is a 3 coat, 2 bake line that was installed 2 years ago. And for the first time in India, we have the 3rd coating line from an ACP plant, and I'm showing the photograph first time at Zak Chennai today. And this is our 3rd coating line, a state-of-the-art coating line, which is a 3 coat, 3 bake line. So this is a very advanced line, and that has been just now commissioned 10 days ago at our plant in Umbergaon. So we are the only plant in India which has 3 coating lines, so that production capacity has gone from 20,000 square meter to 30,000 per day. These are the 4 lamination lines for Class B. This is our line that makes a corrugated core panel, FR-A2, and 12 mm and 25 mm honeycomb. Just a quick snippet at projects we've done in Chennai. This is the most prestigious project which we did in Chennai with CRN. This is the CMRL headquarters here in Nandanam, just on Mount Road. And it was a project where we had to customize a shade, and this is 16,000 square meters of fire retardant A2. Thanks for CRN for giving us this opportunity. So it's an iconic project. This is CTS Chennai, again 15,000 square meter on OMR. The consultants were Colliers. This is one of our large projects in Hyderabad, Phoenix Centers for the Phoenix Turner Group. Again, a customized color with FR Class B, 25,000 square meter. The beige color you see is customized by us. This is a project where we replaced solid aluminum sheet. So the original spec was 3 mm solid aluminum sheet. And due to value engineering, where the budget was a constraint, we got in a big saving, and we had almost 16,000 square meter plus installed in this project. It's a 30-story building. So the entire paneling you see is with corrugated core panel. This is a very interesting project which we did in Hyderabad, which is the walkway bridge. It looks beautiful in Raheja Madhapur High-Tech Park, High-Tech City. It's a customized wooden shade. A few projects which we are doing in Qatar. We're doing a lot of more projects in US as well. We're doing projects in Sri Lanka. We're doing projects in Middle East, Africa. And this is a very interesting case study with which I would like to finish my presentation. This is what we did for Al Khor Zoo in Qatar, where we had this opportunity from big architects, Belgium, where we had to customize bamboo panels. And we came up, this was a spec that was given to us. And we came up with a prototype. In spite of not having secured the project, we invested resources into it, and we ended up creating a product like this. So at Viva, we welcome challenges. We like to do things differently. And the Make in India policy is our prime focus. And thanks for being a great audience, and looking forward to interacting with you at our booth. Have a great evening ahead. Thank you.
How's the Josh? How's the Josh? Good, good, good. Our next presenter on stage will be Amernath.A from Amer and Ani Architects. He's a principal architect. He'll be talking about form and function in architecture. So how are you guys liking the session so far? Insightful, knowledgeable? Awesome. And my speaking, is it okay? This is the first opportunity okay, just boss man has told I'm okay, so that's fine. Okay, guys. So have a good Friday evening ahead, and before that, we'll be having a few more sessions and a very interesting panel discussion, and we'll be closing the day after that. So thank you for your time once again, and see you on the other side. And round of applause, please, when Amernath ji comes on. Let him come on. Okay, he's coming.
This is the mic. Yeah. Good evening, all. Very happy to be present for the Zak Façade Consultants. I'll just go through the kind of projects what we do. The form and the function in architecture is actually a general topic which will apply not only for architecture, it's also apply for any designer, any product in this one. How we withhold, how we withstand that ethics and the form and function in architecture, how it conveys is what we practice in our field of architecture. Amernath, myself, and Aditya is my wife, she's a structural engineer. We both formed this Amernath.A Architects. So first I'd like to introduce this project. This is a residential complex. It's an apartment for a developer called Kushagra in Chennai in Manapakkam. So when they first given this project, the brief was very general. As usual, the builder used to give this much of FSI, this is the unit size, this is the ticket category, this is what we have to sell and all these things. This is what we worked with the many builders, many developers. But most of the developers' briefs is almost similar, like this is what the FSI, this is what the numbers. But as an architect, what we are going to give them, we have to think in the perspective of the end users. What do the end user apartment really needs? That and the brief of the product of what they given from the real estate developers, this should marry each other. We should not over-dominate with the builders as well, and we should not compromise on the end user also. How we balance both. So that's what we try to attempt in this project. This is one of our... So always for an apartment, it is a dream of any buyers or any home buyers. It's a dream of owning an individual house is almost ultimate dream to having an individual home. But in an apartment complex, how to bring the individual home feel is what the challenge which we cracked it in the apartment complex, which is not existed and so forth. So the two elements which comes into the mind for the individual home feel is, one is the double height. Any individual house is the double height within the house. Another one is the courtyard. Double height is not a unique concept in apartment. It will be happened in many apartments. Because of the duplex, it will happen in the last two floors. Because of the structural flexibility, they will cut the last slab, they will connect and they will make it as a penthouse. That is very much possible. Another one is they will bring the double height in the balcony. That is also very much possible. But how to bring the double height from the first floor onwards to the last floor, which is quite challenging. So we inspired this concept from the puzzle car parking. When I went to the shopping with my wife in my shopping mall, I was waiting in a parking lot. She took a lot of time taking as usual as a wife used to do. So I was waiting in the parking lot. We just inspired this concept from this one. So what we did is, they removed one of the car park all of the sudden. I was waiting there. They removed this one of the car park and the top of this one. The whole section looks interesting to me. This whole base goes and connects like that. So we visualize each car as a bedroom, kitchen, dining, and this will become a double height. What happens if it go to alter into the first floor? So first floor, this will become a bedroom, living, and this dining will become double height. So I took this photograph, I drawn on the tissue paper, I went to the studio, I developed from the sections how each unit of each floor looks like. This is exactly how this section is derived from. So with these conditions, we juggled it. We just juxtapositioning one above the other, we positioning in such a way everybody will get this double height effect. So how in the plan form, how it will work? Say for example, if it comes in the living area, straight away living, foyer, this whole area will become a double height in the first floor. So 1, 2, 3, all three bedrooms will happen. If you go to the first floor, second floor, this will become a wide, this double height will move over towards the second bay. This will become a double height on the second floor. So third floor, this bay will become a free, the bedroom will be introduced, this bedroom will become a double height and third, and the fourth will move towards that side. So we just a simple juxtapositioning of the moving the bay towards one another complex, we achieved this kind of effects. This is the kind of sections which we evolved it. A first floor guy will have the double height within the house, second floor guy, and third floor, ultimately the fourth floor. So all these guys for 80 lakhs, this is 80 to 90 lakh square feet of, 80 to 90 lakh is the budget of this house, to getting the penthouse and individual house will within the house, which is quite interesting. So this is how the sections it works for the apartment. So this is the feel of the house. This is actually a built one. If we go inside the house, this is living and the dining. The facade of this whole apartment is the expression of this is a double glazing, almost 20 feet high. In any regular apartment, it's a conventional apartment, this kind of window, it is just unconventional. We used this kind of glazing. So that it almost looks like an individual house. So allows every apartment like this. So this is the feel of this one. This is a planned one, this is actual. This is the rendered image, this is the actual image of what they constructed it. So form and functions, how we evolved the form, how we expressed. So the form and the function should synchronize in the same way, like whatever the form we can create, but it should convey the message as well. So in this project, we achieved these two. So after finishing the project, I was walking through the campus, I was asking some of the feedbacks from the customers, those who are living there. They are telling one of the clients, many of the clients, they told us, I almost feel like an individual house. I canceled a couple of apartments at the rear side, what we booked it, and we booked it just because of getting the feel of individual house. So architects can create any kind of concepts, any kind of narratives that they can put it across. But at the end of the day, the customer has to feel, they have to speak the language of what architects has created. At the end of the day, they spoke the concept, I felt like individual house. For any architect, almost this is an ultimate award. What architects trying to create, the end user has to speak and they have to feel it. This is another interesting project for ISKCON temple. We are developing an ISKCON temple in ECR. So this is a competition project. We won this competition. This is a closed competition. It was floated to many international architects. We won that competition as well. So for Krishna, for ISKCON, any temples if you take, if immediately comes into the mind is the Sudarshana Chakra. So that is so dynamic within the form of the Krishna. That form, we just took that form and we abstracted it, we rotated the circle into the different forms, and then the abstract will become like that. So we mixed all the 5 elements of the nature, comes in the center, and the center will become the rising tower. That's become the temple complex. So these are the sketches we made previously to that, how we have to interpret how the walkway has to be, how the tower has to be. So all the fire, land, water, all put together. This means wherever the pathway we are taking, before entering the temple, you will experience all the 5 elements before going to the center program. So once from the approach of the temple, it looks like you will see the sky and the earth in between Krishna. It's nothing but between the sky and the earth, the Lord exists. So you will feel the 2 elements, the sky and the earth. When you're moving forward, you are going into the narrow, and it is a wider pathway, and it's a narrow zone. You feel the funnel effect of the air. You feel the 3rd element as the air before going to the temple. And the next one, immediately go inside. It is like a climax and suspense. If you just go inside through the narrow path, it opens up to the huge OAT, and there are a lot of, these are all the commercial activities happens here. So you immediately ends up with the heating, the intense heat of the sun, so that the heat you will feel. After that, you will cross the water body and then go to the temple. So before entering the temple, you literally feel all the 5 elements of the natures, and the form looks so dynamic. It's the form why we followed like this, the torsion towers. So whenever we move across the torsion look gives always the movement. The pathway is rotated in the eccentric way, so that tower is always live. The Lord exists always. This tower is not in a fixed position. It gives more dynamic. It is alive as well. So another project, this is in Gindi Kattipara junctions for agriculture department. Has a beautiful 7 acres of land. They want to develop a park. This is not a regular park. The government wants to initiate the awareness about the agriculture, about the city peoples, because many of the kids asked which tree paddy comes from. That is the awareness they are having. The agriculture comes up with a proposal, so they want to create a prototype of various crops. 0.5 acre of paddy field, 0.5 sugar cans. So they'll create a park just like that. And then with what are the uses of insects like butterfly museum and all these things. So I was asked, initially this building was designed by PWD. They came up with a small regular boxes kind of thing. So they asked me to design this one. So what as an architect I'm going to do, this park is going to be an educational park. As an architect, what my perception is going to be like, my building should convey some kind of messages to the public, so those who are coming. They should learn something out of it. So we followed the circular forms, this one, the complete circle which comes into the ground floor is all the stalls of the agriculture materials which is going to happen. If we go to the first floor is in the center is the insect museum, which is going to happen, the butterfly museums, all of the offices and the OIT and all these things. Upper floors. So the facade, what we did is, we maintained the facade in such a way like those who are coming into the park, they know about what is agriculture, what is the importance of all the insects and the importance of agriculture. What my building is going to do, I just conveyed the message like green can be used in the facade element also. Facade can be used as a green, how to incorporate green in the facade without complicating things with the simple shrubs, how we can use it. So in that way, it will help, like say for example, this is an office which has happened inside. This is the first layer of the glazing. This is the second layer we introduced with the trellis and stretch grills. And that is we are given the small provisions for the planters. These creepers will run across to the second element that will, from the harsh sun, it will It will protect the air conditioning efficiency also, it will improve. And from the inside to the outside, if you look at from the inside to the outside, you will always end up seeing with the green. You won't believe this is in Guindy. The site is almost like a forest only. That's quite a good piece of land. That's how we envisaged. So how the hot air comes and cools out. This is, even without the air conditioning, the building will still work. So that's how we worked out this whole facade. These are the various sections. This is how we envisage it. The whole form of the building should look like a tree. It should not look like an odd man out. It has to camouflage with the green what it already exists. So it has to give the feel of the tree which is existed already, because there is also a tree which was there. So this was the one which is yet to finished, where there is a Kandepara junctions, which is yet happening. So these are the trellis. They planted some kind of planters over the creepers are yet to happen. So once if it is done, so the whole green looks like a green facade one. We won't see the glazing at all. This is for the government of Tamil Nadu. So initially this was designed by PWD, so they want to do something out of it. So they invited me in special case to do this. This is the insect museum which is going to install now. So this is another interesting project for government of Tamil Nadu in Tamil Nadu Yerkad in the hilltop. The hill is almost like a two-sided, two slopey, two terrain under this one. So how we have to follow the form in the mountains and what they got. Doing the building in the mountain is actually, you have to play with the levels, you got to handle the levels. In this case, this is going to be institutions, so only 5 classrooms. If you remove the 5 classrooms, the whole thing looks like a resort only. So I want to take inspirations like this it's a two-sided slopey like that. So Namakkal is near to the Yerkad. Whenever I pass through Yerkad, this fort is always fascinating me. I just took the conversions of this is the form which I just want to give to the top of the mountain. This is one of the quite interesting form in the mountain, how the mountain, it's become a crown in the top of the mountain. How we can incorporate these kind of concepts in the design is what we trying to figure it out. This is in Rajasthan, Jaisalmer fort. So the whole city is crowned with this kind of fort. So this form is so inspiring to me. So just thought of getting concepts out of it. So these are the zoning. I just enter over here. This is the OAT, the walk across and go and exit out of it. These are all the 5 classrooms, which looks like a fort. And if we climb up, this will become a huge OAT, and this will become hostels, and this will become quarters of this one. So how we juxtapositioning of all these blocks is the way how it look. So we took the concept of the Jaisalmer. It is almost in the top of the hill. It should looks like a crown for the whole area of this one. So if it comes center towards this one, this is the OAT and the classrooms. These 5 classrooms is the one which gives the definition of this building as institutional. If you remove this will call it as a resort or hotel. So I want to give the dynamic expressions of the fort, what they already we inspired from that. So in the previous government, this was again designed by PWD. Then again, the previous GM, the chief minister, who called me and personally he tasked me to design this one. This initial sanction amount was 25 crores. After designing, after seeing these designs, the previous GM gave this 65 crores the sanction, which is never happened in any government. 65 crores they sanctioned from the 25 crores. And I was not participated through the tender also. That was quite complicated for the government to appoint me. So the CM given as a GO's work order. This is the first time an architect I'm getting a GO from the government as an emergency order. So this is the one of the expressions what we did. So from the from the bottom of the mountain, if you see, you feel like it is in a mountain. To scaling up of mountain is the toughest job. See, we can't scale it up. See, the mountain is quite a huge and massive number. What is the kind of form we are following it? How to express it? How it is going to be done is what. This is how the form which is expressed it. So from the top of this one, you feel like a fort. So almost we followed the same materials what which is available locally. It gives the bold expressions of. The windows also flows with the form of this one. It's more organic. So they bisect towards the shortcut, the auditorium of various aspects, which is going to happen. 5 classrooms. So once if you evolve to the form, rest of the forms evolved automatically, because this is the main thing we attended to that. So automatically, which is everything is complementary to this is the auditorium. This in between the corridors, these classrooms. So from there, if you step up, the top of this one is actually a YAT. See, this took us a lot of time. What kind of placement we can put it at the topmost of the peak of the topmost of the site? We came up with an idea of putting a principal room or putting any important conference room or anything else. After that, I just gone through the Jeffrey Bawa's architect's works, his sayings. He said in one of this article, where to build is part of architecture, where not to build is also part of architecture. So that comes into the mind. Here, we should not build anything else. Let the public enjoy all these things. Those who are coming from the classrooms, they'll come and go and sit in the YT. They'll get the view of the 360 degree of the mountains. They enjoy this space. So I just left it like that. Where to unbuild is also kind of part of architecture, which gives an idea. We scaled it up with the two kind of tunnels. This is actual image of the mapping. These are the hostels, which is followed the functions. Sections we followed up where the hostels have placed it. This classrooms over there. This is my own house. This is my farmhouse, which we designed. So what we did is we experimented with this kind of form. There are only 2 bay houses. One is so up to the 2 houses, we followed one bay as a living and another bay as a completely open. Again, we mixed it with all the 5 elements of latches. Once if we come inside the house, fire, air, water, all these 5 elements will experience within the house itself throughout the day and throughout the time. So only 2 bedrooms, 3,500 square feet. So once you go across left, if you go across, you'll end up with the whole thing is a double height. It's a bridge. If you go to the first floor, this is the bridge which connects in the first floor of the living and the bedroom and the next terrace. This is living, dining, and the kitchen, and this one. This is completely open. So both of them is complementing each other, open and closeness, open and closeness. Juxtapositioning of these 2 spaces always marries each other. You can't segregate where is exterior, where is inside. So the climatically it will works like the air will always comes into all the directions of this is getting opening. We extruded it over the hot and hairs. So this is the jolly. So what can we do for the facade? This is in the remote area. So we tried to work it out of the AAC block with the staggered with the patterns, with small openings. Once if the hot air passes through the small holes, it will become cool downs. So the whole house is always cooled in any kind of, even if I recently visited the house, it was cool like right now. I never realized the temperature which is inside and outside. Because of the air which passes through the small holes automatically cools down. Even in the rainy seasons, the whole jolly is opened up. This, in the edge of this, we given a small perm like a kind of thing. Even if it rains, this is drain off outside exterior automatically. No neighborhood. This is from the living, how we'll do. You're always connected with the nature. That is an introverted concept. Not extroverted, it is introverted, but still connected with the nature throughout the day. So this house is the 2 dimension. One is the day effect and another is night. Day, it gives the different dimensions. Night, it will give the different dimensions. But always staying connected with the nature as well. It's a small swimming pool. This is a bridge which connects to the first floor. So many times the birds used to come inside the house through this one's a rat and all this, it's become a problem for me. So the night, even if you put the one small bulb, the whole house is littered with these jollies. The facade is expressed in the one simple jolly work. One light will give the expression of the whole. Everything is subtle in nature. Thank you very much for...
Thank you, Amernath-ji. Glad to see that Tamil Nadu government is taking such initiatives for parks and other facilities, especially educational institutions. Schools today are looking nothing like the schools that were there when I studied. So kudos to the government for taking these initiatives. Next up is a company that keeps innovating with hardware. Kinlong, may I welcome Tony, and he'll be speaking about concept of reality and some very interesting products as well coming from them. All stage is yours, Tony.
Thank you. My presentation is on screen? All right. So, good afternoon, everyone. And I think the caffeine that we had will keep us awake. This is the last presentation, and after this, we'll go for the panel discussion. So, it is an honor to represent Kinlong in front of the aces and kings of our industry. My name is Tony, and we go into my presentation. So today I'll be talking about four topics. The first one is a little bit brief about us. Next is the concept to reality, what we are trying to achieve. That is to bring us as a one-stop solution provider. We'll discuss about the LED transparent displays and also the dynamic facade. So we are the pioneers. We Kinlong, we consider ourselves as the pioneers in the construction and building accessories products. We do the design, research, manufacturing, and the sales and marketing of construction hardware equipments. This is our 150-acre industrial park, which we have, where all the manufacturing and research happens. So we have around 16,000 employees globally and around 67 subsidiaries. So Kinlong was founded in the year 2003. We came to India in the year of 2013. We have pan-India footprint right now, and we have 5 warehouses throughout India. We have 300 Indian employees right now in our company in India. So this is our global footprint, and this is where our offices are located in India, 16 offices. So our workforce, it's basically like just 40% is for the sales and marketing. We put a lot of emphasis on the design, on the technical aspects, on the service part, and also on the IT, on the information technology part, which I will come in the later stage. Because everybody will be thinking, what is an IT guy doing in a hardware company? So we have a state-of-art laboratory and manufacturing facility, and we are seen as approved, and our certifications are come with the same. Now, we follow 3 standard procedures. One is the test reports from the National Test House, Government of India. The another is the CNAS, which is in-house test reports. And if required, we go for the third-party ones. Now, coming to the topic, the concept to reality. Whenever a building is put up as a thought, a small house or a big building or a mega structure, it first comes as a thought, then as a sketch. Then the architects, the pioneers, the architects, the consultants, they start working on it. And then the builders come in, the construction experts come in, and they make it a complete product. Now, the performance of this product, I'll say the product, the building, entirely depends on the hardware that are used. Multiple examples has been given today regarding the fire safety, the performance after 5 years. So everything depends on the quality of the products that we use. So if you are taking a facade as an example, so there are basically three-point considerations. One is the aesthetics, the second part is the core functional part, and the third is the budget. I have put a photo of Mumbai International Airport, which was one of our projects. It's a very old project. The latest one, that airport we are doing, is the Port Blair International Airport. It's a bidirectional curved facade with a single clamp. A single clamp will have 2 vertical, 2 horizontal, and 1 diagonal cable passing through it. And we are proud to say that it was one of the, we were capable enough to do that as an organization. I have put this because this is my favorite facade, which I have seen. Now the core functional part. Now this is Meenakshi IT Tower in Hyderabad, and it's a single cable vertical structure with a curvature. Now, this is 61 meters tall, this the highest cable structure in India. Now, the core functional part, aesthetically, they just need a curvature and maximum transparency. But the hardware, the cables, the clamps has to be incorporated to maintain the curvature and also to get that complete balance system on a single cable. Now, the budget part. Now, we in our market, since I am in the hardware industry, I can almost say the first thought that we come in our mind is aesthetically it should be perfect, functionally it should be the best, and budget-wise it should be the cheapest. And if that doesn't happen, then we think reverse. We first put the budget and we go to the reverse engineering part. So I'll cite one example here. It is an identity twin towers which we did. It's one of the best apartments complex in Kerala. In Mumbai, my speakers were telling 30 crore, 100 crore for an apartment. In Kerala, 6 crore is a big amount for a single apartment. So this is some kind of that apartment. But they wanted, the budget was a little bit higher for the SS316. So, and they cannot go for any grade below. So what we did is we put the submarine grade SS2205 pillars, which is a much superior grade of material. And we reduce the thickness. The metal used is much less. So we were able to supply the same product with better performance characteristics at a lesser price. Now the hardware challenge that comes to it, when the journey between the concept to the reality. Now you take any building, there will be like 100 different hardwares to be used, right from the door and windows to the facade part, to the shower cubicles, to the lock hardwares, A to Z. Now, there will be multi-specification, wide variety of hardwares to be used. You will have to deal with the negotiation with multiple vendors. You will have to work on design optimization with multiple clients, multiple suppliers, all those things. And once it is completed, you will be forced to deal with 10, 20 hardware suppliers for the after sales and things. Now, this is a challenge that we are facing right now. Now, for example, if you take an airport, the hardwares to be used will be on the glass facade, the railings part. Okay, this railing is designed by Balu sir over here for the Lulu. Then the shop front, the parking, the restrooms, the fire doors, the lift glazing area. The list goes on and on and on. Now, the question that I have to ask is like, when you go to buy a car, would you buy the piston separately, and will you buy the seat separately, and will you buy A to Z component separately? Or will you just prefer to go to a showroom, sign a few documents, get the delivery of your car in your hand, and the service will be taken care by a single point person, everything. So similarly, the hardware to be used, what is my point over here? Starting from the spiders, the showers, the bathroom hardwares, the lock hardwares, the safety equipments, door and windows, the railings. We take pride in telling that we will be able to provide the single-stop solution for everything. And we are, as an organization, working hard to reach that point. See, the advantage of being a single service provider is the wide product portfolio that we have, and the design and the technical assistance that we can give you. The advantage of the pricing part, when you do value engineering of a multitude of products, the package, and also the friendly payment terms and all those things. When it comes as a cumulative package, it is always much better. So there comes down to 4 points on dealing with a single service provider. That is, all the products will be a single point contact, and it will be a time-saving, efficient process, and a cost-saving one. And finally, the service will be a single point contact. Now, this is the second phase. As I told, around 10% of our employees are IT professionals, which we took from Wipro, Infosys, and all, like a hardware company like us. So we are developing a platform. Mostly in 1 or 2 months, this will be ready to roll out. For the past 1.5 years, we are working on it. Is to put the customers directly, to give our entire portfolio, including the technical services, everything, directly to the client. Now, the second part, the dynamic facade part. Now, this, you would have seen in our booth some films, plates hanging. So this is what it does. This is the art, and that is the artist. So all the small films, when hung together, this is what we are aiming at. So this is a wind-activated dynamic facade. So the whole, it gives a very eye-catching aesthetic to your building. And this system is completely customizable, the shape, the size, how much movement you want, everything. Now, this is a project which we did in Marina Bay Sand, that is in Singapore, the entry area. So the whole motion brings into life. I mean, what if it's a brick panel, or like, what if it moves? So we can do the support in two ways. One is a cable supported way, and the next one is a steel structure supported. So it is not a very technologically funda thing. It is just the wind doing its business and creating art. So there are three types of panels that we can use. Unique plate, which you can bend it in any shape that you want to create the art that you want. I will say art, not the facade. The art that you want. There is perforated plates and there are regular plates. Now we have wide materials to be used: SS304, 304, 316, copper, zinc, and plastic. Any finish, any size is possible. Now we do everything in this. From the design part, we will take care of it. To the installation, we will assist A to Z of this process. Now the third part is a transparent LED display facade. This you would have seen in our booth, a small LED display. Many would have wondered how it looks like. Now, this is in Saudi, and this is the entry point of a bank that we have done. So it's entirely transparent. It creates a sense of dynamic. Now, these are two videos of the same building. One is in the daytime, and another is at the night. So this company, Kinlong Next Novo, was founded in 2011, and we are the inventors of this technology. It can be dealt in a number of ways, like commercial buildings, shop fronts. I mean, you dream about it. If you have an artist inside, you can create art using this. Now, these are our LED mesh technologies and areas where it can be used. And see, this is where the entire thing comes in. See, to commercialize a glass pane, when you walk into a mall and when there is the glass that is running around in railings and all. Now, this is a money-making area which can generate revenue using advertisements and also create a very dynamic ambience inside your structure. So we supply the hardwares for it. We also do the software configuration part for it, and we also do the service. So it comes as a package. We already have started with four showrooms in India. It's not in Chennai, of course. I would like to see one in Chennai, but we have done it in Pune, Mumbai, and Delhi. Now, my final sector is the society part. Now, Kinlong as a company, we have a very different way of working, even in our office, how we work. The company culture is a little bit different. So we believe in getting even our employees working together, and that is very evident. Last year, we gifted all our zonal managers 27 cars registered in their names, not in the company name, 27 cars. So that is how we love to treat our employees, and that is how we will treat the society as well. So we have done Kinlong Hope Schools in the past. This was inaugurated last 2 weeks back in UP. So this is a school which we sponsored, we built it, and then we have been doing this since 2007. And this is a Kinlong Hope School in which I was very lucky to be part of. We did this during the COVID lockdown time. And for me, it gave me better satisfaction than doing around 5 different airports in the last 5 years. More satisfaction in doing this school. And this is a Kinlong Hope School which we are doing right now in Punjab. It is under construction, and that one is getting inaugurated in Bangalore in June 15th. We are hoping to have one in Chennai, in Tamil Nadu, not in Chennai, because we always put the Tier B cities where the attention towards the kids, like even if we are able to make a difference for one child, it makes a lot of impact to the nature of business that we do. So Next year, in 2024 end, we are aiming to have 10 different Kinlong Hope Schools in India. So that's it. I think I'm right on time, and it is an immense pleasure and happiness to share this podium with you all. Thank you.
Thank you, Tony, for that presentation. Next up, we have the last and final finale panel discussion, and this will be by Sri Krishna Gindeji, who will be chairing this session. He's a lead facade L&T construction, and the topic is any engineer's favorite topic, facade value engineering. So please welcome on board the panelist and Sri Krishna ji as well. Round of applause, please. Thank you. And this is the last session, so please wait after this. We'll have a vote of thanks as well, and thank you.
Hi, good evening, everybody. Ladies and gentlemen, welcome to this last session of this wonderful event of the day. And thank you so much for your patience that you have waited for so long. I'll not waste or take too much of your time. I will immediately start with the invitation to our eminent panelists on board today. Can I have the panelists on the stage? Ms. Sunaina Subaya, please, from Dias Design Consultants. She's the director. Welcome, ma'am. Good evening. Mr. Rupesh Kumar from L&T Constructions, the DGM, and my dear colleague as well. Mr. Devi Prasad, he's the Senior Associate Director and City Head from Cushman & Wakefield. Hi, good evening, sir. Please come. Ms. Nivedita Vibhav, she is the Head Marketing and Business Development from Fundamax. Welcome, ma'am. And Mr. G.K. Venkatesh from Nemcon Façades. Welcome, sir.
Thank you so much.
So now that we have all the eminent panelists here on our dais, I would like to get straight down to the business. This is a very, very interesting and intriguing topic for most of us. This whole event is about facades, right? So it's called as World of Façades, and I guess we will have a good overview of a lot of questions on finalizing or deciding upon a facade, how everybody's, what everybody's view about how they go about finalizing on a facade. And I'm so glad that the panelists are from varied, kind of fields. And let's have their views on a few questions that I have prepared, and let's start with that, right? Okay. So here we go. Ma'am, I would like to direct my first question to you. You're the architect. You're the torchbearer of any project, right? I mean, you have the vision and you are the creator. So my first question goes to you. What are the potential challenges envisaged or experienced, while finalizing the design proposed by the developer or the consultant that the developer may have? And how do you kind of, approach your design with respect to the budget, the materials, and the execution of the entire works of the project? And this is basically all facade-centric questions, so you could probably give us your views on that, ma'am.
Sure.
I'll also take a chair if you don't mind.
Thank you. So in terms of how we envisage the material and the facade itself, I think it depends on the project and the brief from the client.
Yeah.
But I think there are some things that are standard in terms of the need of the hour, in terms of being the material selection being sustainable, and the performance of the facade itself being a key parameter when we're selecting. So even when we talk about what are the savings that we can look at and what is the budget that we need to look at, that little extra spend on the performance of the facade itself is something that most clients are willing, most developers and clients are willing, because it has an impact, cascading impact on other budgets, other aspects of the building cost. as well as the running cost. So these are primary parameters, and of course the aesthetics, no doubt, plays an important role. In terms of the size and scale of the project based on the site constraints, a lot of times, especially in high rises, we end up with a rectangular building and then we're going tall with that. But despite that, there are multitude of ways that we can actually treat that facade and treat the way we deal with that rectangular box that can actually make it interesting. So that's usually the challenging aspect of it, and how to make it different each time. Not every building needs to be iconic, but at the same time, it needs to actually reflect what is the ethos of the company that we're building for, either the client or the developer.
Correct. Very well answered, ma'am. Full marks to you on that.
Thank
I'm
you.
sure if there's a developer listening, he's going to come to you for the next project of his.
We'll keep fingers crossed on that.
All right, I'll move on to my next question. I would again direct this to you because these are interrelated questions. I mean, how do you envisage the massing and the material selections based on the client requirement, or again the project requirement or the budget? I mean, you covered some of it in your first question, but this is about your selection of material. How do you envisage that?
So I think in terms of the material selection itself, there's a lot of advancement in terms of technology that has happened, and that plays a driving role in that. The other aspect also is 20 years back, it was a standard to look at ACP as facades, and those were the versatile material that was available. But slowly people realized with one fire somewhere, realized that that's not the ideal product that we should deal with. So we learned from, it's a reactive kind of thing that, okay, we don't want to use this anymore in the next project, and let's look at what other materials that we can use. So that's one aspect, but at the same time, there's also what works for the building itself, what works in terms of course, in terms of the, one is what I already talked about in terms of the performance, but also the feasibility of how the facade itself is developed, whether it's a unitized system or what the building calls for in terms of the front elevation as versus the rear sides, what is the importance of it. So these are all aspects that we would consider and work accordingly to that.
Right. Well, this gives birth to another question in the sense when you talk about selection of materials, you know, like you rightly said, there's a choice of a lot of materials available in the market, but that has led to a big word which has been coined, which is called as value engineering. So for me, this is being a fabricator myself in my previous years of experience. This has always been a question which has been put to us as a fabricator or as a contractor about value engineering. So we have Sir here and Mr. Rupesh, who is from L&T. My question, Rupesh, to you first is, since you do a lot of negotiations with the contractors, you do a lot of negotiations with the vendors as well, and I have heard this word quite often about value engineering. So what do you think? I mean, when should this value engineering come into play? I mean, does it come into play at the time of award of contract or at the time of concept? Because you are a design and build contractor yourself. At times you are a EPC contractor also. So what is the right approach? I mean, how do you approach this value engineering thing, and what does value engineering mean in your terms?
Yeah. Good evening all. Value engineering, it's a good question and it's a wide topic. Value engineering, generally we think about what value engineering is reducing the cost. It is not such. We have to enhance the product value and take care of the customer requirement. What is the customer looks for? We have to deliver the end requirement without what requirement of the we're diluting the specification rather. So coming to value engineering, where it comes to play, we operate in two models. As such, we largely operate in two models. One is design build and second is an item rate contract. So coming first, the value engineering plays a very vital role in the design build job, where we have a large room to play around. So here we need at the beginning stage itself, at the design stage itself, we need to get involved with all our stakeholders, from system designer to consultant and the supplier processor part. So what is the material available and selection of material, and we will frame a concept of the drawing, concept design will be framed at that. It's a preliminary database we will create. So from there, our activity starts further. So we do a lot of exercise in that stage of the design building, and we have a lot of wastage control part also will be control over
Optimizing.
that. Optimization, which is a major factor it is there. And for design building, yeah, there is a large scope is there in the conceptual stage itself before getting award of contract. That is what. And coming to item contract, there is not much of room because everything has been specified. Only unless otherwise there is a crunch of the material, or some places we will not find that material due to timeline of project, we are bound to come out with an alternate make. So in that case, there on the item rate contract, there is a scope for value engineering. Hope I haven't said my...
Right, yeah. Well answered, I think, Rupesh. I mean, this is what we do in L&T, which is what I'm aware of. But sir, I would like to have your views as well. I mean, you're a facade consultant, and you must be coming across this question quite often from the developers or from the architects or something, that we've designed this, but we want to value engineer this. So how do you take up that challenge, and at what stage do you do it? Like,
I would rather address this as engineering values. See, value engineering, I would rather address it as engineering value.
Right.
Why we have a situation where in most of the projects we land up into a controversy, specifically related to facade. The primary reason is that in 95% of the projects promoted in the market, the design criteria is never specified. The project goes around between 6 bidders only on the basis of the price quoted, and it is invariably the lowest bidder gets selected for the project. In the architecture, there is civil construction, there is plumbing, there is electrical, there is so many activities which happen. There is no activity where a contractor is expected to submit some drawings or calculations. It is only in the case of facade, the selected contractor has to submit design calculation and shop drawing and get it approved. Now, this is the first stage where the basic value of the design or engineering gets diluted. Because it is, we don't require Einstein to come and tell us that the design and drawings are going to be submitted based on the commercial value finalized. I quoted 6 crores. I was finalized after negotiation at 4.2 crores. My design is not going to be related to 6 crores. Value engineering would be definitely value engineering if the entire criteria, you see, architects are working very hard for the conceptualization of the project. The developer wants the realistic conceived project to be coming up. Then why not the facade is also taken up in advance, and the entire design concept, everything, what is required for the project is finalized in advance, and then every contractor is informed that this is what is expected, so you quote your price.
Right.
This would be the real value engineering if adopted to facade.
Absolutely. Well said, sir, well said. Thank you so much. And with all these questions that we had so far, it spoke about how we choose the material, how the architect envisages the massing, the materials, the selection of materials, etc. We spoke about value engineering. Now, to sum all this up, I mean, would it be better if, sir, my question is to you basically, because you are a client's representative. Cushman & Wakefield represents clients and developers for many projects. You do your probably own development. So apart from the architect or from the facade consultant, would you also, kind of appreciate or involve or engage something kind of a design assist or, to select the material, to select the, facade? I'm talking facade related only. To, engage vendors on board or contractors on board or consultants on board for a design assist. And have all these problems kind of cropped at right at the concept stage, like he said, when we give a lot of attention to a lot of other things apart from the facade at the time of concept. Would you also like to have a design assist or this kind of assistance? Would you appreciate and engage on your projects, or would you like to promote this kind of a thing? What's your take on it? Like?
Yeah, like sir said, the involvement of the contractors or the architects and the project manager should be starting from the initial stages of the project. Currently, or in most of the projects, due to short timeline, the developers start investing the money in selecting a contractor, main contractor. Everything is almost 50% of the structure is done. Then they start designing the facade elements. So that's where the real problem comes. And as he said, it's more of vendor-oriented. Facade is a vendor-oriented product. So involvement of a contractor from day one is essential. That's the main thing.
Wow, nice. So I think this is a great, I would say, comment, or this is a great opportunity for subcontractors also to look forward to connecting with people like you and try and get on board with the project right before the award or at the concept stage.
Yeah, correct. Because it is an integration between a structural element and the facade. It's integration to be done, but there's a lack on that.
Having said that, I mean, does it lead to us, speaking of having a collaborative approach towards, finalizing a project? I could, probably this question could be answered by you or architect or the main contractor like L&T who basically does this kind of work. So would you appreciate having a collaborative kind of a thing, or would you like to still have a secretive kind of a, tender or your, what do you call, approach towards awarding a contract? I mean, Rupesh, if you would like to answer, like, how would your approach be? I mean, as L&T, let's say, or as a developer, or as a main contractor?
Yeah, when we are doing the mega projects, and all, definitely the collaborative effort makes a much more sensible there. Because there will be, we will have only concept in front of us, not much, but then the basic guideline specifications will be there. So in this case, we will have a detailed discussion with our partners, channel partners, and consultant and system providers. We will discuss on that. We will have with a close network, not to everyone who are closely associated with us. So we will have an open discussion and how to formalize that. So we will get things formulated, and we will have a talk with all the vendors in a forum, and we will make a broader aspect. One sort of project requirement will be made. With that, we have found a lot of areas we have succeeded, and the main thing will be there will be always an assumption, and overshooting budget will be there on the assumption part, because certain areas it will not be cleared. With our design help, we narrow down those issues, and which helps to bring all the bidders, like our subcontractors, fabricators, to come in a common platform, rather than having each will be having their own presumption, and they will be quoting the prices. There will be a jeopardized, there will be a huge gap. So once we have a collaborative approach, definitely these sort of thing can be narrowed down, and this has helped out in a larger scale.
Right.
Just to add on to it, Mr. Gendry.
Yeah, I'm coming to you. So being collaborative, does it also mean that it is like, is it a commitment, or it's just like, just collaborate? So let's say, I mean, would you like to commit at the time of collaborating, or is it like just to bring everybody on the same platform?
It's a friend. We will not give any such commitment, because as a customer, we generally it will not work in that way.
Correct. Yeah. So I ordered him to answer that before I could come to you.
Sure.
So now there is no commitment from the client that he is going to collaborate with you, basically to take information and take your guidance on the project. But under a scenario like this, I mean, would a vendor like you, which is a large vendor, which is quite popular, would you also like to be a participant, knowing that you're not promised the job?
Just to add to this, and I'm sure that everybody in this, in the audience, amongst the audience, from a material supplier perspective, right, would agree that there's nothing secretive about anything. It has to have a collaborative approach, and I'm sure all of us, from the consultant to the architect to sir, all of us, would agree that in today's world, nothing is secretive. You have to be collaborative to attain what the design is meant to be or what your deliveries are meant to be, right? So it has to definitely, right from the day one, right from this word go, you have to be collaborative in your approach. That's one, right? And I'm sure, ladies and gentlemen, you would agree to it, right? That it has to be a collaborative approach because there's nothing secretive. And if it is secretive, it doesn't work, right? So having said that, on your other question of design assist, which was to Mr. Devi Prasad, all of us and I would take this privilege of talking on behalf of all the material suppliers who are present here and of course out, that we believe, it's just not about the product which we make, we intend to sell it. Of course, we are here for business, right? But having said that, it's very crucial and it's very pertinent and important that, we have to give a solution, whether it's an architect or the consultant. So again, coming back to, it has to be a collaboration. By the end of the day, it might sound cliched, but it has to be a teamwork by the end of the day, because the intent of each one of us is that the design sustains its over a period of time, and we make something which is like, not only aesthetics-wise great, but from functionality perspective also wonderful. Right, so it has to be collaborative, and any day we have to work as a team. All design assist has to prevail.
United we stand.
Yeah.
Can we look at it in another way?
Yes, sir.
In the entire process of bringing to life a building, this collaborative does not figure in when the structure is taken up for construction. Right? The procedure that he explained only prevails. Every contractor has to bid.
Good.
The reason why the collaboration subject is not discussed in structure, why the collaboration subject is not discussed in plumbing, why the collaboration subject is not discussed in electrification, even landscaping, it is because the details, what is required is clear.
Correct.
Every project, when the structural drawings are released, the main contractor to the subcontractor to the superintending engineer to engineering head to the vice president will be monitoring whether the execution is being done as per the drawings released. This is the only subject where we will not commit to give you a job, but you come and give us all the details. You take the preliminary drawings and you give us the Fundermax installation drawings. How the wastage of Fundermax is happening, why? Why will Fundermax give it? Right? The question is, he will say, I will not release the order. He cannot commit, obviously, because ultimately he has to be obligatory to the cost also.
Absolutely. Yeah.
Then the question is, where is the question of collaboration? This collaboration subject is only discussed in the facade. It is primarily because I have seen BOQs, 4-line BOQ for 1,000 square meter of curtain glazing, right? What it says, providing and fixing of aluminum framework with soft coat clear low E, DGU, 6 mm, 16 mm air gap, 8 mm glass. That's it. Now what you can make out of that? You can only make out that there is an aluminum and there is a glass. So it is, you see, I will tell you a small background. When Disney World was being inaugurated, Mr. Walt Disney had already expired, and Mrs. Disney was going to inaugurate the Disneyland. There was a press reporter around. He said, had Mr. Disney been there? So she said, then what would have happened? So the reporter said, he would have also seen it. She said, you are going to see it. He has already seen it. That's why now you are going to see it.
Correct.
So in facade, we don't have a predetermined specification. We don't have a predetermined drawing. We never, in this country, approximately 15,000 crores is the performing glass sales by the 3-4 companies manufacturing. How many of you agree with me? Please raise your hands. 35% is the wastage on glass. Nobody is agreeing? Oh, only 3 are agreeing. In ACP, 6,000 crores is the turnover of ACP being sold here. ACP companies, do you agree? Vivekanandan, 6,000 crores is the turnover all over India in 1 year. and 35% is wastage in ACP. And the interesting part is how any ACP companies will come forward to collaborate with you, how a glass company will come and collaborate with you to give you the optimum use of the basic material on the facade, when there is no commitment to give a business, right?
Absolutely.
We should stop talking this collaboration. We should stop talking about the value engineering. No, we better talk about engineering value first. Every project, it is commercially finalized first, and then design and drawings are expected. No civil contractor gives a design and drawing. He is given a good for construction drawing.
Correct. Yeah.
No plumbing contractor gives a drawing. He is given a good for construction drawing. We should transform this facade industry first into giving good for construction drawings. If a contractor can submit a design calculation, who is not competent to submit a design calculation, please tell me that. If a contractor can submit a shop drawing, who is not competent to give a shop drawing? And when I studied in 6th class, my maths paper was checked by my maths teacher. Now here, the facade contractor submits a design calculation, which is checked by somebody who was teaching Sanskrit. He himself doesn't know what to check in that. A 4 pages, square root, some large bracket, some small bracket, to the power of 4, some calculation given, approved. So this procedure must stop. We must, the industry must learn. Faizer Ali Dastagir, will you support, what is the terminology we are using?
Collaborative.
Will you collaborate for every facade ACP design and drawings to be given free?
He is already collaborating. If he says no tomorrow, he will not be able to enter LNT. So you ask this question to anybody, everybody will say collaborating.
So therefore, we should stop talking about this value engineering. Value engineering is not something which is done after commercial finalization. There will be no value engineering, right?
There is no end to it, basically. Yeah.
It is already frozen,
yeah.
right? And we are always influenced to go for L1. We don't bother about the name of the company, the brand, the quality, the fire safety, all that is only in world of facade we can sit and talk. But then the question is, the moment we go out of the room, hey, on the that project we lost at what price that fellow took it? Sir, he took it at 3,100 rupees per square meter. Okay, now you quote 3,050. There is no basis even while tendering for the project. So therefore, this is the broad, my judgment. I may be wrong. Please excuse me. Those people who feel that I am wrong, please excuse
Nobody
me.
is, no, I mean,
I feel that
everybody is.
I feel that collaboration, value engineering, nothing required. Everything should be released as good for construction. People should be asked to quote, right? And then about the work.
Right. Point well taken, sir, but I think we're running out of time, so I'll quickly come to the last question. And this is a question which is basically going to be common for everybody, and I would like to have everyone's view. This is the bane of our industry, mostly to do with us contractors. We are also contractors in a way, and to our subcontractors who are, the facade contractors and the facade fraternity that we have, including the vendors, not just the contractors. So, sir, do you do you give us enough time? I mean, does the client give enough time for the execution and procurement of material? And this is facade centric. It's not about civil works and all that. I mean, in your different views, I mean, you're a client representative. So do you think that you get enough time, or do you have that kind of leeway with your developer to provide enough time to the facade contractor or the vendors who are associated to execute the project, to source the material? What's your view on that?
Everybody knows the answer.
Sorry?
Everybody knows the answer, I am saying. In most cases, maybe around 80 to 90% of the cases, we don't have time. And we are sorry that we are also not giving sufficient time to the architects to do perfect drawings, to the subcontractors or the contractors to source the materials. because we can't blame the developers also, because they are in turn giving to their clients who sits in US, who has their business, because their inauguration date, their business date is started already. So they are back working the construction part.
Right.
So as an industry, yes, it's tough, but we need to go along with the vendor.
Ma'am, you as a vendor, what do you
Well,
think? Do you
so,
get enough time to source your material
Right.
supply?
So
Or?
if I may be audacious enough in saying this, it might sound, with due respect to everyone out here, that, it's always like yesterday, right? So when it comes to delivery. However, jokes apart, to be honest, I don't want to sound philosophical out here, but whatever said and done, and I would still reiterate, although Mr. Venkatesh said that, it's not a collaborative word, we in this generation or in this world try to be collaborative, of course, and we would give our best to be collaborative and under all circumstances. Yeah. Having said that, as material providers, as manufacturers of material, the onus lies on us that, how do we integrate our processes to ensure that we deliver on time, right? So when we have a portfolio, let's say, and we are presenting to XYZ, right? Yeah. Of course, we have to ensure that we all have it in, right? There can be circumstances, there are situations which we all face, wherein there is a lag or there's a glitch, and we especially, and I'm sure that others also, we especially as Fundamax, we do not manufacture in India, we import. Having said that, there can be lags wherein the deliveries, but the onus lies on material manufacturers, and I would, with all conviction, say that, we should have enough to ensure that we are making the deliveries on time. Having said that, again, Mr. Ginde, it might sound a bit too much, but as we say that, the customer comes first. If the customer comes first, then only the customer will last, yeah. is all I would say to end it up. If the customer has to come first, he has to last with you. So if you put your customer first, of course, and for this, the deliveries have to be made on time.
Absolutely.
Yeah. So we have to bear with it.
L&T. So Mr. Rupesh is from L&T, and I think he is one of the biggest, job provider to a lot of subcontractors and to a lot of material vendors. So do you give enough time to your vendors and contractors to perform, to deliver, and to build? And what's your take on this?
Most of the cases, the answer will be no, because the trend has been changed. Because earlier we used to have ample of time. Nowadays we are talking about an airport, greenfield airport, which should be completed in 36 months.
Yeah.
So facade being the last element, and it should be completed in the first. Without completion of facade, you cannot commission the interiors and other part. That means the work has to be start in the day one itself. So the most essential thing will be having a vendor on the board. That is the critical. You should have a vendor at the earliest, a fabricator, and because it has a lot of logistic to be followed. You will get extrusion from one end, it has to go to coater, it will be another part. Same way for glass. Glass also again, it has to go for secondary processing. And altogether the final material, it will be at the end one fabrication it happens. So you have to coordinate with almost 10 to 15 parts, and you have to get the material, which is in time consuming and time taking on. Second is now we have to adopt the latest technology and the trends, how best you can cope up with the timelines, like modular concept and lifting and transportation, horizontal handling of the material, vertical transportation, and simultaneously handling at the multiple axes, where instead of rather you will have a sequence of work, which will have again you have a lot of dependency that has to be breakdown, and that you have to engineer it out, how you can work. In that way, you can, we are working towards that. Most of the projects we will be in firefighting mode only. What we are.
So basically 2 takeaways. I mean, one thing again coming back to our previous question of being collaborative, so that we can probably collaborate in a better way, so that we don't have this kind of time crunches and this timeline crunches. And the second takeaway is basically for all the contractors to understand that you have to keep your EOT letters ready, ask for extension of time, and kind of buy your time out.
Delay will due to other trade also will be it will be affecting. You will not get work friend at the time.
Yeah, true. So great. I mean, I do not have too many questions to ask, but since we have such eminent panelists here, I would like to throw this forum open to everybody of us who is here. And you could probably take this opportunity of asking, because I haven't seen in the whole day session today about anybody wanting to ask any questions. Probably we were short of time, and I think we still are short of time. But still, if anybody wants to pick up a question or something and address it to the lovely ladies and the gentlemen here, you're most welcome to do that. Or else then we'll call it a day. Okay, looks like everybody wants to rush home.
I think I want to touch upon what Sir mentioned, in fact, about at what stage do we finalize the specifications and the design finalization before it goes into tender. I do think that's an important aspect, and we as architects, consultants, it is a responsibility that we need to make sure that these are very clearly spelt out so that the client knows at the end of the day what they're getting. There will still be the submission of the shop drawings, the submission of design calculations, and ratifying what it is that they're actually going to build, the fabrication drawings. This aspect would come after the contractor is on board. But it is important that at the design stage, once we decide what is the elevation, what the building envelope is going to look like, once we have an agreement with the client or the builder on that, it is important that as architects we do at least spell out what it is that we're expecting in terms of the performance, in terms of the detailed specifications, as he said. A 4-line specification, I was pretty shocked when he mentioned that, but it is important, I think, that we should have all of this clearly spelled out. And when we're talking about the collaboration, as architects, we are expected to be jack of all trades. You have to know your MEP, you have to know your structure, you have to know about your facade, all aspects of it. So the collaboration doesn't necessarily have to happen at the drawing board for that particular project, but it is important that we are kept abreast in terms of what is the latest available. So that happens with interactions with various vendors, but it doesn't have to be that we're specifically sitting out for that particular project and collaborating with a particular sub-vendor who is not yet on board or who may not get on board eventually. So that doesn't necessarily need to be an expectation if we're already looking at what are the products and what would suit for a particular thing. It is important to have the interaction, but not necessarily having a collaboration on a project-to-project basis. It doesn't need to happen. And when you're talking about even the value engineering, when you're talking about value engineering in the facade itself, it doesn't always translate that a saving cost on the facade doesn't always translate to a saving in the overall budget of the project, which is a very key factor in this when we're talking about that. Because you may, how do you justify? There was a project almost 15 years back where the client was quite particular that they wanted single glazing. So we had to prove to him that by spending this extra, going for double glazing, going for a better performance glass, we could eliminate one chiller, the associated space, the associated electrical load, all of that we were able to eliminate. So eventually there was saving on the entire cost by spending extra on the facade. So it's a very tricky subject when we are looking at talking about value engineering on the facade itself. You can't look at it separately because you have to look at it as a building as a whole, as all aspects of the design. So
it's like saying cost is what you pay and value is what you get. So.
Exactly, exactly. So even I think the previous presentation, Mr. Tony was talking about how to monetize the glazing, how to monetize the facade. There's so much that you can do with it nowadays. So it's never ending. I mean, for a brand like a Nike or a Samsung, using an entire digital facade is branding for them, is marketing. It's a cost. There's a value associated with that.
Correct.
So it doesn't necessarily mean that if they cut that and they come down on the cost, it's not value engineering for them, actually speaking. So it depends on what is the value associated with it to that particular project, the client, as well as the developer.
Right. Very well said, ma'am. And I think, yes. Yeah. Sorry, come again?
Precast buildings.
Yeah.
So they design everything. It is like shop drawing.
Yeah.
So what we are discussing, in precast building, they won't face any problems because the cast time, it is almost shop drawing, no?
Yeah, I know, but there will still be some interfaces.
Because you cannot change. Once you finalize all design, so you cannot change. What we are discussing, once you start construction, then you will think later on we can finalize elevation. The client also want 10 or 15 elevation from our architects. See, we do every week one elevation. So you will tell I import one elevation material from Italy, one from China. At the end, they find out in local. This is the problem. But in precast structure, everything is finalized where is a value of engineering is placing order. That's why the Autodesk is introduced collaborate AEC industry.
Right.
If we use properly Autodesk collaborate AEC industry, 100% we can achieve as per our schedule.
Great, sir. Great. Thanks for your input, sir. Anybody else wants to speak up, or Suresh, sir? You want to cross question somebody? All right, so we'll call it a day then. I think we are well ahead of our allotted time schedule. So Ahad has to kind of give us brownies, not brownie points for that. So you want to? Okay.
Thank you very much for that session. I think value engineering is a topic most of us engineers and architects will, it's a never-ending topic.
Yeah.
But what I say is over-value engineering leads to too much of firefighting also on site at execution stage. So rather we stick to budgets rather than go into value engineering too much. So in saying that, I think that was a great session. And overall, I would like to call now Kushagra ji from Shuko to hand over the mementos to Sri Krishna ji and also all the panelists here. And please welcome on board Kushagra ji.
While they give the mementos, I thought I'll just take a couple of minutes to close today's event. I'd like to thank all of you for taking your time out for attending today's event. Thank you all. I hope you enjoyed today's session. We had a wide range of topics being discussed. I know not easy to process everything, but as I mentioned this morning, we've recorded the session. We'll share with you the YouTube link, which you can then use it to review it or share it with your colleagues. So thank you all. Thanks for attending. And then those who have the delegate badge, if you notice, there's a USB stick. The USB stick has the brochures of all our event partners. So it has two folders, one which you can use and the other one which is a locked folder which has the brochures of all our partners. So thank you all for attending today's session. I'd also like to call upon the other speakers of this session, Mr. Amer, Tony, and also any sponsors who have not collected their mementos. If you can come on stage, we will just complete the photo opportunities. So thank you all. Until we meet next time in Chennai.